and all the issues that you had, you can see Mr. Saxena has left his holidays and joined at the plant. He has come to, because today administrative office is closed. The administration building, if you know, in Vizag Steel Plant, where the directors sit, that is a part of the administration building. That building is closed today. In spite of that, he has taken the trouble of coming to office only for this. So I'm really grateful to Saxena ji, and for all the trouble he has taken. And Pravada, he had a very important meeting today. In spite of that, he has to leave at 5 o'clock. So we'll have to ensure that we start exactly at 4 so that we can leave Pravada by 5 o'clock, and also Saxena Saab before that. By 5 o'clock, we'll have to leave Saxena Saab also, unless he is comfortable in staying back for some more time. So he loves the subject. Since when he loves the subject, I'm sure he will spend as much time as possible, unless he has some urgent business to go to the plant. So
I'll be sometime.
Thanks in advance. Thanks in advance.
Thank you, brother. Thank you,
Nirmala Babu. There
Yes,
there is only one lady in this panelist. She is Rashmi. So let's welcome her on.
I can't see her. Has she joined?
Rashmi is there. Rashmi is there. Rashmi is sitting here.
Yeah, Rashmi, wish you a happy Ganesh Chaturthi, and let me welcome you, since you're the only lady panelist. And
thank you, sir.
If I can just share something with you, today's webinar was actually conceptualized only for you. Do you know that?
I'm honored to hear that, sir. Thank you so much.
Believe me, you can ask Professor Argo Majumdar why it was conceptual, because the moment I read that link which he sent me, I got mesmerized that if this is what you can do with dross, then we are set for a change altogether. Saxena Saab, what Rashmi will be talking about today, using dross in furniture. Can you imagine dross being used in furniture? So she is going to basically, take this industry for a storm and today's session. This was something unique. You have heard of all other users of waste. Have you heard of furnitures being made out? And she's an architect who has actually done it. There are examples. I'm sure she will highlight all that. There are examples where she has actually done, designed furniture out of dross. So Shobhada, I think you're aware that when we conceptualized, it was only for Rashmi alone, and then we had everyone together. Mukesh Kumar ji, aap kabhi sune honge dross being used for furniture?
But this is a news to me, and I think this will be a very, very interesting thing.
Thank you so much, sir. That was really kind words. Thank you.
Actually, Rashmi, I have talked with her, and she has done really good creating these furnitures at her own office and her own factory. And this looks really good, and it can be a really game changer for the Indian real estate industry. And for using the slags for making these furnitures, it will be a real game changer. I can tell you, I can assure you.
But one thing should not happen, Argo Babu, that if the furniture business becomes too profitable, people should not ask for more slag.
So I assure you that won't happen.
Okay, let me welcome Mr. B.N. Satpathy. Mr. B.N. Satpathy is PSO to, advisor to PSO in Prime Minister's office. So, Satpathy ji, namaskar, and let me wish you happy Ganesh Chaturthi. And I'm sure in Delhi celebrations are also on. And in spite of being a holiday, Satpathy ji, the fact that you have joined us, my real thanks to you for joining us on a holiday.
Thank you. Thank you.
So Satpathy ji, we are almost at 4 o'clock, so without wasting much time, I'll have to only request our moderator and who's going to take it forward, Dr. Mukesh Kumar, whom I think you already know. Dr.
Yes.
Mukesh Kumar, you know him already. So Dr. Mukesh Kumar will handle the session today. And I only request Dr. Mukesh Kumar, if you can just advance Prabhat by a few minutes so that he can finish before 5. He has to go by 5 o'clock. So
Sure.
with that, I will request Ankit to start with the introduction of the speakers, and then we will go to the inaugural part. So Ankit, please take over for the inaugural part, and then we'll have the welcome address by Mr. Subrata Mitra. So go ahead with the program. You can start.
Am I audible?
Yeah, go ahead.
Yes.
Perfect. Very warm welcome to all the panelists and attendees today. Our topic for today's webinar is Harsco Environmental Presents Waste to Wealth Session 2, Reducing, Reusing and Recycling Byproducts and Waste in the Indian Steel Industry. So today's webinar is the second of a series of 3 to 4 webinars that we have planned for the coming weeks, with the common goal of minimizing waste and converting existing waste to usable resources in whichever way we can. So we thank you all for your active participation yesterday, and we look forward to a vibrant session today and in all our upcoming events. Before we begin, I would like to take a moment to welcome our title sponsors, Harsco Environmental, and our co-sponsors, EcoMeister Beats India Private Limited and CCRT Laboratories. We thank them wholeheartedly for their support. A warm welcome to the chairman of our organizing committee, Mr. Subrata Mitra, who is the ex-joint managing director, M.N. Dastur & Co. Limited, and the secretary of our committee, Mr. Shoposhachi Bantopadhyay, CTO, Big River Steel, USA. So now I would just share my screen to introduce the panelists. Is my screen visible to everyone?
Yes.
Yes.
So our panelists for today, we have Mr. Subrata Mitra, ex-joint managing director, M.N. Dastur & Co. Limited. Mr. Shoposhachi Bantopadhyay, CTO, Big River Steel, USA. Dr. Mukesh Kumar, director, SRTMI. Mr. V.R. Sharma, managing director and CEO, JSPL. Mr. B.N. Satpathy, senior advisor to the principal scientific officer to the Prime Minister of India. Mr. Ajit Kumar Saxena, Director Operations, RINL, Vizag Steel Plant. Mr. Prabhat Kumar Ghorwai, Senior Vice President, JSW Steel Limited. Mr. Abhijit Gupta, Director, Sales and Marketing, Harsco India Private Limited. Ms. Rashmi Bidasaria, Designer and Architect. Mr. Amit Kumar Srivastava, Managing Director, EcoMeister India Private Limited. Dr. Santiago Fokker, Chief Executive Officer, Eco Materials Incorporate, and Chief Technology and Operations Officer. Dr. Sanjay Kwande, Managing Director, CCRT Laboratories. Dr. Sudhindra Biswal, Head of Mr. Devojyoti Roy, Principal Executive Officer, Tata Steel BSL. Mr. Pavan Verma, CEO, Techno Enviro Services. Mr. Ritesh Kumar, Head of Marketing and Business Development, Industrial Byproducts Management Division, Tata Steel Limited. Mr. Sanjeev Manocha, Global Steel Industry Manager, Carmius. Mr. Anil Pasari, Managing Director, Gang Engineering Private Limited. So these are our panelists for today.
Mr. Ankit, Mr. Maru Kuri is also present in the panelists today.
Can you, Ankit, can you promote Mr. Maru Kuri because he is traveling? So I was not too sure whether he'll be able to join.
Yes,
Yes.
I have promoted Mr. Maru Kuri as well.
Okay, Mr. Mauro Kuri,
Yes.
can you? Are we audible? Can you hear us properly?
Yes, good afternoon. First of all, thank you for the invitation. As I said, I'm traveling, so I hope the noise will not prevent me to be really understandable today. But, I just use a couple of minutes to introduce myself and the company, and then I leave my colleague Abhijit to go through the substance of our presentation, the theme that we are discussing today. So my name is Mauro.
Mr. Mauro Kuri, can you switch on your camera so that we can see what?
But I am in the airport, so I don't think it's gonna be very, very good to see all around.
Yeah,
so you excuse me for.
Yeah, okay, as you wish.
All right. So a small introduction of myself, Mauro Curi. I am the Vice President Global Operation for ASCO Environmental. I am very privileged to be with you, and you know, I'm very attached to India since I had the privilege in the past to start our business in India in 2010. Already 10 years gone. I lived in Hyderabad for 3 years, and obviously more than 20.
I think there is a connectivity issue with Mr. Mauro Curi. We'll come back to him whenever he's connected. We'll take him back. Mr. Forshaw, can you hear us?
I
Mr.
can.
Santiago.
Thank you.
Great.
Good
So-
morning, everyone.
Good morning and good afternoon from India. Well, with that,
Can you hear me?
Yeah.
yes, yeah. So you can continue, Mr. Curi, yeah, before we
Okay.
go.
All right.
I
So
don't
just
know why that's.
Yes. Hello. So I just give 1 minute presentation of the company. So Harsco is an international corporation based in US, Harrisburg, Pennsylvania. It's more than 1 year old company. We have basically 3 divisions, but mainly in the environmental services. Our division serving the metals industry, but particularly the steel industry, is called Harsco Environmental. We operate in almost everywhere in the world. We have 140 sites operating around the world, including India, where we started the business 10 years ago. Our core business is basically talking about steel industry. We provide services that go from raw material handling to finished product handling and byproduct sales. So we embrace all the kind of services except obviously melting, casting, and rolling. Our total turnover is around, divisional turnover is around $1 billion. As a corporate, is almost $2 billion. And we are very keen. And 2 years ago, we embraced a journey into the environmental theme. So that's why we changed our name, and now we are called Harsco Environmental. And I'm very happy to be here. As I said to you before, I lived in India 3 years and started the business for my company in India. And today we are very, very happy to give you a little bit overview of what Harsco can do in the steel industry. We have, of course, a nice presentation that Abhijit will drive you through. And I hope, I will be staying on the background if there is any question at the end of the presentation. So Abhijit, please go ahead. Thank you.
Thank you, Mr. Mauro Curi. Mauro Curi, with that, let me just find out whom Mr. Shubhajyoti Mukherjee has nominated today. Any idea who?
He has nominated Mr. Shailen Shukla. And Mr. Shukla, are you there?
Mr. Shukla, are you there?
Yes. Very good afternoon to everybody.
Yeah, I can't see you. Whether okay, yeah. Okay, I found you. Well, very, very good afternoon and happy Ganesh Chaturthi, Shuklaji. So
Yeah, same.
instead of Mr. Shubhajyoti Mukherjee, Mr. Shailen Shukla from ArcelorMittal Nepal Steel India will be represented. Okay. So with that, Ankit, shall we have the national anthem so that, or do you want the national anthem after the welcome?
So we would have the national anthem after the welcome address, I think.
Yeah. So welcome address by Mr. Subrata Mitra, Chairman, Organizing Committee, and followed by Mr. Sabyasachi Bandyopadhyay, Organizing Secretary of this webinar.
So just before we move on to the welcome address, I would just introduce our moderators for today. So we have Dr. Mukesh Kumar, Director, SRTMI, who has also actively helped us in organizing this webinar as a pivotal member of the organizing committee. And of course, Mr. Nirmalya Mukherjee, Editor and Steel and Metallurgy, will be the co-moderators for today's webinar. And as the session progresses, we expect the attendees to naturally have some questions and remarks for the panelists. So for that, we have a Q&A section in Zoom, which will be accessible to all panelists and attendees. And I would request everyone to post your questions and queries in the Q&A sections. And the panelists can then choose to either answer it live or directly in the Q&A section. So without further ado, I would request Mr. Subroto Mitra to deliver his welcome address and take the session forward.
Subroto, you have to unmute yourself.
We can't hear you, Subroto. You have to unmute.
Yeah, you're still not unmuted. To go to the microphone.
Yeah, now it is there. Now the
yeah,
central control is there. Yeah, okay. Now I'm sorry for this. So it gives an immense honor and pleasure to chair this session, which we have been continuing for quite some time in various topics. So this waste to wealth being a very serious issue all over the world for managing the environment, we take pride, and it is due to relentless effort of Nirmala and his team. This is the third webinar. We are sitting with eminent personalities and experienced dignitaries in the field to share some of their views. So we are privileged to have Prime Minister's scientific advisor, Shri B.N. Shatpathy, Shri Shatpathy, then V.R. Sharma, CEOs, various CEOs and directors of steel plants, where we can share their knowledge and experience of handling the waste material. It is not only making business, it is creating a habitable environment in not only in the steel industry area, steel industry inside the industry, making a good working ambience, and keep the world free of, at least let us start this venture of creating awareness amongst everybody. Everybody is aware. We cannot say the steel industry doesn't know what to do, but the motto is reduce, reuse, recycle, recover, redesign, remake, if possible. So basically, this is a vast subject. We are in the third phase of it. We'll continue our effort, and we are eagerly awaiting to listen from the various panelists and dignitaries. The interesting topic today is, as was told, Madam Bidesariya, about using slag and other ways to make furniture. That's a real interesting thing. India has gone far ahead in utilizing this, but we have much more work left over to continue and do it. With this, I don't want to talk much, and I welcome everybody, and let us start the proceedings. Thank you.
Thank you, Subroto. Thank you so much. Now we'll have the national anthem, followed by the address by our organizing secretary. So let us rise for the national anthem, and then Sabyasachi, your address, please. So let us rise for the national anthem. Ankit, are you ready?
Yes.
Yeah. Okay. Let us rise.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, ladies and gentlemen. Now, may I request Mr. Sabyasachi Bandyopadhyay, the organizing secretary of the Waste to Wealth series, to deliver his address.
Thank you, Nirmala, and thank you, Subhrata, for setting the stage. It has been an honor to be part of this initiative. Nirmala requested me, and I think that this is one area that all focus is there. But there are challenges like yesterday's inaugural session. We heard about most of the steelmaking community, the real core steelmaking community coming in and talking about their challenges, also the efforts that they have put through, including the steel industry colleagues. There is also a role for the policymakers. We heard some of them yesterday, and we will hear Mr. Satpathy today. The other thing which is also equally important in the whole exercise is the role of the solution providers, the researchers, the academicians, and the institutions. So who are in some ways or the other are the innovators. And so we are very extremely delighted to have a lot of solution providers today on the panel. We had some yesterday. I'm really delighted to see Ms. Rashmi Bidasaria here. I was really impressed with her work when I got the link and went through our work. So I'm very keen to listen to her. One of the things that I have always believed, and our series of webinars actually start with that focus, is reduce. So before anything, the control needs to be in place. So, and in order to do so, there is another simple principle that have been used for ages. I call it a DMIC, and you can find it also if you Google it. It's very simple. D stands for definition, define, M is measure, A analyze, I improve, and C control. So the biggest stage actually stays in defining. So I think through these webinars, we are trying to define the path ahead for the industry as such, for our industry peers, for our policymakers, for our innovators, for academicians, for the solution providers. And I call it a defining moment. And if we take this opportunity to define what path we should progress, what are the objectives that we take for ourselves, it would be an excellent value proposition and an excellent platform to get to that point of measuring and analyzing what we are doing or how we'll be doing in future. When we talk about waste to wealth, obviously our focus right now is to talk about the byproducts, the solid waste, or the gas emissions or the affluents. But if we think about it, there are several types of wastages in any industry, in any sphere of business. So here we are either talking about wastages that are physically measurable in some way or the other, and converting them into some sort of form which we can either reuse or recycle through our own process or other auxiliary processes. Let us also take a moment and put a food for thought for ourselves in terms of another wastage, which I call spiritual wastage. And by doing that, what I mean is decisions. So at every stage of our life, in every stage of business, we are here, all the people that we are assembled here or the people who are attending, we take decisions in life. How are those decisions leading to wasted efforts or results? Because by the simple definition of work in science, which we read in grade 6 or 7, displacement by the application of force is work. Everything else is just effort. So which is most important, work or effort? So naturally, this spiritual waste or the decisions are equally important. Let's think about some of the things. Why do we need certain specifications even existing today for our steel products? Can those be formatted differently? Why do I need a normalized steel plate rather than tempered and quenched steel plates? Why do I need certain level of chemistry in my steel? Why can't I make the steel from a different specification, or why can't I adopt a different practice? There are lots of questions that are there, and challenging the status quo is something that we all need to do. We have been doing things in certain way, traditional way. One specific way that we can certainly lead ourselves is using information that's available in a meaningful manner. So we all know about Industry 4.0, but how we have embraced it, how we are using it, how information is leading to wisdom is something that as an industry, I think the steel industry overall is still lacking, and that's where we need to go. So with all that, I'm very excited to see some of the faces that I very well know. In fact, when I was in India for a couple of years in 2017, 2015 to 2017, I have come across some of the people on the panel today, and excited to see them. I'm looking forward to innovative talks from people, including Ms. Rashmi. And all the best for global companies like Harsco. Know them very well. And also other dignitaries. Thank you for your time. Thank you for being here. And Nirmala, over to you to consider proceeding with the proceedings.
Thank you, Dr. Sachita. Thank you, Sopoda. Thank you so much. You have always been our leader from the front, you and Subratoda and Dr. Mukesh Kumar. Three of you who came together when we came together to form this committee. The three of you have led us from the front in real sense of the term. So thank you so much for always being there to take our flag forward. With that, let me just inform you, Mr. V.R. Sharma is still in a meeting and he will join us at 4:30. But let me once again repeat what Sapachita mentioned. Rashmi is the star of the show today. Without Rashmi, this would not be there. Let me accept that you're youngest among us, but you are, let's say, the most talented among us, because we only know how to make steel. We do not know how to create art. So that's where you come in. And just remember one thing, today's entire webinar was conceptualized only to highlight your contribution to the world of art from the world of steel.
Thank you, sir. That's a lot of pressure to put on, but it feels really good to hear that. Thank you so much.
Yeah.
And I hope that the panelists here today understand what I'm trying to convey, and same likewise for me as well, because I'm a designer, I'm not a steel person. So it would be a really interesting conversation to have after the discussions to bring everybody on a common platform.
Exactly, that's what I wanted to convey, that steel can contribute to art and steel can come together. That was the whole idea. So once again, thank you, Rashmi. With that, we'll go into the main subject now. May I now request Dr. Mukesh Kumar to introduce Mr. Satpathy and followed by Mr. Saxena. So when Mr. V.R. Sharma joins, we will take him in by 4:30 or 4:40. So in the meantime, it is you. The floor is yours, Mukesh Kumar sir.
Thank you, Nirmala. Let me just introduce Mr. B.N. Satpathy. B.N. Satpathy, right now he is working in the office of the Principal Scientific Advisor to the Prime Minister. Before that, for about 5 years, he was with the Niti Aayog. And in the Niti Aayog, it was his main subject, resource efficiency and circular economy. So he has developed the concept paper for resource efficiency and circular economy in iron and steel sector, aluminum sector, electronic sector, waste and management sector. The ultimate objective was to bring India at par with other European countries and other things. Because you know that in Europe and other places, lot of development is taking place on waste utilization through this resource efficiency and circular economy. And when Mr. B.N. Satpathy was there in Niti Aayog, they were helping even in Ministry of Environment and Forest also to prepare the national resource efficiency policy. And that draft has already been released of that. So with that, I will just request Mr. B.N. Satpathy, with his vast experience in this field, to please share his views on this thing, waste management, not only for in the entire mining and metallurgy sector. Thank you, Mr. B.N. Satpathy ji. Floor to you. Satpathy sir, please unmute yourself, sir. You are muted. Ji.
You have to just unmute the microphone. Yeah, you can see the microphone icon, the red icon. You have to just unmute that.
Yeah.
Yeah,
On
it is done. Yeah.
Thank you, sir.
Yeah, thank you, Dr. Kumar. Thank you, all the organizers. It's a great pleasure, though this is today's Ganesh Chaturthi. I wanted to participate for 3 specific reasons. I will say what are those reasons why I wanted to participate. First, in the second 5-year plan, way back in 1957-52, when the first steel plant were going to be erected, the main thrust of the plan was self-reliance. We wanted to be self-reliant in the economy and wanted to have so many steel plants. Today, the same ideology is back again, Atmanirbhar Bharat, although in a totally different context. And so your title of the webinar today, reducing, reusing, and recycling, is very, very critical for Atmanirbhar Bharat. So look, so many years back, when you decided to have a steel plant, the same philosophy was there. Today, again, we come back with the same philosophy, but in a totally different context. I will take you forward also in this. I think there should be some research on what is the future of steel factories in India. Another 10 years, another 20 years down the line. Will these factories remain as it is, or there will be a total transformation in this? This is something for which you should do some research, all those people who are engaged in this. Now let me come to the second context what Dr. Mukesh Kumar was saying. When I was in the Economic Advisory Council to the Prime Minister and in Niti Aayog, in 2017, December, we came out with a strategy for resource efficiency. There were 2 very important contributions in that. One, there is a need to adapt a strategy for recycling. It cannot happen just like that. We need to promote it. The government needs to promote it. And the industry can be a partner in that. That policy was followed up with 4 sectoral papers. One of them was on steel, where Dr. Mukesh Kumar was a very important contributor in that. That was approved by the Ministry of Steel also. That laid down the roadmap for reducing, reusing, and recycling of steel products, byproducts, and waste, minimization of waste. It's an excellent document. I don't think it is available in public domain, but that is something that has really moved both 2 ministries, Ministry of Environment, Forest, and Ministry of Steel. Ministry of Environment, Forest, that Dr. Kumar was saying, came out with a policy on resource efficiency covering all the sectors where these 3 things, reduce, reuse, and recycle, are the basic mantras in that. So it is not now merely related to steel, but all other sectors are also covered in that. The second aspect was, how did the Ministry of Steel look at it? The Ministry of Steel came up with a draft, as you know, scrap policy which is on there. I think the last date for the comments are over. That is another very important innovation contribution that we made, and the ministry has really kind of came up to our expectations and released that draft policy. And I can assure you this will go a long way in making scrap available at a competitive price, and will make the secondary steel sector a very vibrant sector. I do not want to go into how much time it will take, whether it will be available in due quantities or not, whether imports will stop or not, but this is the beginning that has been made. The third aspect, today we are in the grip of coronavirus. The whole thinking has been changed. The way you look at things, whether it is steel manufacturing, whether it's aluminum, whether it is cotton textiles, whether it is shipbuilding, everything today is now having a different perspective. If we do not survive, what is the use of all this? If we are able to counter such a deadly disease, in spite of all scientific advancement, what is the use of all that? So what is the lesson that we get out of it? The lesson that we get out of it is the following. Research and development is a key parameter to human progress, human prosperity, human happiness, and perhaps freedom from disease. If you are not free from disease, what is the use of the steel making that you are making? So the research and development is key not only to human health, but also to the steel industry. So the Dr. Mukesh Kumar's responsibility is greater today, and all the people who are in his territory are extremely important for the future of the steel industry. We have prepared a report on research and development expenditure ecosystem, which was released again exactly a year back on 24th of July, against the backdrop of the Global Innovation Index, which was released by the World Intellectual Property Organization. And please mark my words, in 2019 July, when this report was released, the theme of the Global Innovation Index was creating healthier lives and creating a better world. And exactly after 6 months, the coronavirus hit the whole world, and the entire world is devastated today. So what we are doing today on 13 August, we had another meeting to devote as much resource as possible within the system towards research and development, to have a better understanding of not only steel making, steel processing, but also for human life. After all, everything is for human life. So these are the three aspects. I'll again repeat them for your benefit. In 1957, when we started the steel making, it was self-reliant. Today, it is again self-reliant, but in a totally different context. And we will have to rise up to the expectations and bring about the steel making industry in that framework. The second aspect was that the resource efficiency will continue to be a very important parameter for the whole economy, for the whole world today, whether it is due to climate change or whatever is environmental pollution, whatever it is. So in that, the Ministry of Steel has come up with our expectations. So also Ministry of Environment and Forest. And the third, the importance of research and development is much more important today than anywhere in the past. We pride ourselves that they are the best brains in the world, but we are also a victim of a deadly disease. So with all these three things, I want to again thank you, the organizers. I wish you all the best. And there are many, many ways to promote these 3 R's. And I'm sure with the help of Dr. Mukesh Kumar and his team, you'll be able to achieve the agenda which you have projected in this today webinar. Thank you very much.
Thank you, Satpathy ji. And what you have explained that today is a time has come when there is a need to all three group, means R&D bodies, institutions, educational institutions, and industry has to join hand together, because this is a challenging time. And unless we create a sustainable world, there is no use of making any progress. What you told, we have achieved Atmanirbharta in steel production. We have last year produced more than 102 million ton steel, and we are the second largest. But if we don't take care other part of the steel production and other things, there is no use continuing like this. We have big plans to go to 300 million ton, and with a sustainable approach. Thank you very much for your time and accepting our invitation, for coming and sparing your valuable time and sharing your views with us. Thank you very much.
Thank
you, Sarpatji ji. Thank you, Dr. Mukesh Kumar. Dr. Mukesh Kumar, मेरा एक ही request है. You brought such a wonderful speaker to lead us today in the form of Sarpatji ji. So I'm really grateful to both Sarpatji ji and to you for giving the suggestion of inviting Sarpatji ji. So the thanks should also go to you for that. And with that, I have just one request, Mukesh Kumar ji. Since Mr. Prabhat Kumar Ghorui will have to leave, just after Saxena ji, if you could ask Mr. Ghorui to address us.
Yeah, so, I was thinking I was thinking to request Mr. Saxena ji if Mr. Prabhat Ghorui can give us.
No, we still have that time.
Okay.
So,
okay.
Yeah.
Okay. Can I leave, Dr. Kumar? I have another meeting going on.
Okay, sir. Thank you very much, Sarpatji ji, for your time.
Thank you so much, sir. Yeah.
So now I request Mr. A.K. Saxena ji, Director Production, Rashtriya Ispat Nigam Limited, to share his views. He was very kind enough to came yesterday also, and with a request, because today his chairman was to come, but due to some pre-occupancy he could not come. So he has agreed. Thank you, Saxena ji, for accepting this thing and coming again today.
Thank you, Mukesh Kumar sir, and good evening, Mitra sir, Sabyasachi sir, Dr. Sarpatji, and Dr. Mukesh Kumar, Nirmalya ji, the only lady in panelist, Rashmi, and all others. And it's a great opportunity. Nirmalya sir is giving me again and again. And today I am supposed to represent our CMD sir, but I don't know to what extent I can do justice, because this particular topic, waste to wealth, is very close to his heart, and he has steered many initiatives in this plant, which we are talking of today. So I'll again be discussing those things, but yes, not with his depth of knowledge and range of knowledge. So with that, again, I'll just refer what Dr. Sarpatji said. It should be a sustainable development, yes. And it has to be an all-round development, not the lopsided development that we are developing on some front and not developing on the other. But if you recall, when we came to the steel plant as vacation trainee way back in 85 or so, we really used to wonder, who has conceptualized the integrated steel plant, where nothing is being wasted at that point of time. Maybe 30 years or 25 years from then. So now we realize that there are different kind of waste, but somebody who has really conceptualized integrated steel plant has definitely gone to the range of analyzing and utilizing most of the waste or most of the resources, you can say, which was considered at that point of time. Again, yesterday, while going through different material, I came across a very good sentence that waste is a useful material in a wrong form or at a wrong place. So now again we are consolidating this approach or going ahead. So we realize that the things which were considered as waste are and can be converted to certain material of use. And daily it has happened and it is happening. And if you go to the just analyze the figures, it is nearly 1 to 1.2 million ton of steel. A ton of waste is being generated in production of 1 ton of steel, as compared to 0.5, around 4.5 ton of waste of global standard. So this shows that yes, there are sectors, there are regions, there are segments where we can improve upon, And also, whatever has been generated, one is how to generate less waste, and whatever is generated, how we reutilize it. That is again, if you look at the figure, of course, the figure is slightly old, of 2017, where European Slag Association has reported that nearly 94.3% of their waste, that is of around 37, 38 million ton, they have utilized almost all the waste, and it was only 5% or so which has been used for landfilling. So we have to look at, the different research segments, what and how they are utilizing it. And recently, just a week back, we have at IIM, we have also conducted a webinar regarding this co-product or waste product or waste utilization. So there, if I start from the beginning of the steel making chain, one step which we have taken at RINL is that uses of slime. We are taking slime from NMDC, and last year, on an average, we have used 9% in sinter making, and in Q1 we have used around 20%, and this month we are utilizing it to the tune of 28-30% in our sinter plant, in our sinter making process. So that is one step which we have taken. Of course, it is not reutilizing or utilizing our waste, but it is definitely utilizing the waste of someone who starts the chain of steel making. Coming to sinter making process, we have started utilization of BOF slag. I think this is a common practice, but we are also in a process of starting the use of anthracite powder in place of coke bleach. I think the process will start, say, within 15 to 20 days, and we will see if, I don't know, how are the results. We are also in an advanced stage to install a pellet plant along with KIOCL in our at Vizag, and going further, iron making slag, I need not discuss, almost everybody is utilizing it, but in our webinar, this point came that with this introduction of IS 383-2016, it has recognized, after certain processing, it has recognized that even BF slag can be used as a replacement of sand, river sand. So that offers a new business opportunity for the entrepreneurs, and also a new another avenue for BF slag. Of course, that is not a major issue. The major issue comes in the slag of steel making, and here, yes, everybody is wondering what will be the best use, but some part, that LF slag, ladle furnace slag, we have started utilizing as a replacement of lime in our converter. Not much, but at least it is replacing 6 to 8 kg of lime. And then coming to the new projects, we are in the process of finalizing the briquetting and macro pellets plant, utilizing dry ED, dust, wet sludge, scales, fluxes, including LD slag. And yesterday, Mukesh Kumar has mentioned one thing, that nobody is utilizing the heat of slag. Of course, we are not utilizing, but we are utilizing the heat of sinter mass, and we are generating power through that. And also we are also in process of utilizing this fly ash for our AAC, that is autoclave aerated complete bricks. Another thing which came out as an outcome of the last webinar, which we conducted for our core products, that is that these power plants are going to utilize this minor sizes of limestone to a great extent. That is to desulfurize their flue gases. So that is a new thing which we came to know. And yes, with the great efforts of many of those who are in panel, this BOF slag is also included in the list of NHAI items where it can be utilized for certain layers of road making. And yesterday also it was discussed that, of course, this issue came some 2 years back, this BOF slag can be utilized as to neutralize the acidic soil of our country. Of course, yes, these results are yet to be finalized, and what is the effect of chromium and other elements available in slag and how they will be neutralized, that is yet to be seen. So with all this inputs at not inputs, without what all we are doing at RINL and what all is happening, I'm really eager to listen to all solution providers, and especially the new face in the panelist, that is Madam Rashmi, that how she is going to utilize, and I wish it is BOF slag. Thank you. Thank you, thank you everyone.
Thank you, Saxena ji. It's really very encouraging to know that you have started using slime in your plant also. Presently, you are using in sintering, but in time to come when briquetting and micropelletization is available, hopefully you may be able to use it in a better way also. And it is because nowadays IBM rule also has changed. Now nobody can throw the slimes and fines if it is having iron content, depending upon siliceous hematite or non-siliceous hematite, 35 or 45. But I think this is one of the basic objective of our waste management, how to conserve our natural resources. And I think such type of step need to be taken by other industry also. I congratulate you for these initiatives. And like sintering also, you have done fantastic job. And I think similar approach you will take for blast furnace slag and BF slag also. So that will come. Thank you very much. Now I request Mr. Prabhat Gore, because there is no question. If any question is there, because right now I was checking the question answer, this thing, but there was no question. If any question is there, I request all the attendees, please put it in the question answer, this thing, so that we can see what is there, sir.
So yesterday there were two questions. Should I address them now or?
It's better if you can answer, Saxena ji, and then we will.
One of them was whether we are doing anything extra additional for utilization of slime. Yesterday also I said, and today I maintained that not specifically any measure. Of course, we have coated our this chutes and with the reclaimers with this polymer film, and we are utilizing this compressed air in those so that there is not much of jamming. And another question was regarding utilization of sinter at converter. So whether we utilize sinter or iron ore or scrap, it is one and the same. It is generally decided on based on the availability as well as price of the commodity, and not much of difference while using it. Of course, if you go by chemistry and stoichiometry, you may find certain differences, but not much of difference, and the selection is based on the availability and the price of material.
Thank you, Saxena ji. And I just want to inform attendees and all the panelists that RINL is taking initiative in geopolymer field also for using fly ash and blast furnace slag and other slag. So geopolymer cement, which is a replacement to our cement industry, and that is the future type of the cement, and RINL is taking interest and initiative in that direction also. Thank you very much. Now with this, I request Mr. Prabhat Kumar Gore, because he has to leave also before 5 p.m. So I request him to please come and start his presentation.
Thank you, Kumar sir. Good afternoon or good evening to all. Yesterday we had deliberated, a lot of issues related to the process waste, generation, utilization, especially the reduction in the waste, and then the recover, and then the reuse or recycle. So in continuation with that, some of the aspects which we have missed out yesterday, I want to just focus on those points. We all know that the LD slag, there are a lot of research work is happening in the country. A lot of academic institutes, even the industry itself engaging their R&Ds for utilization. And if I list out, the list is not small. That everyone says that LD slag can be utilized in sintering, in cement plant, as aggregate, soil conditioner or fertilizer, as a replacement of river sand, iron making in blast furnace of Corex as a replacement of flux, and in steel making also as a replacement of flux. So after having so much of avenue to consume the LD slag, but today the status quo remains same. We are still discussing about the usage of LD slag. So this is a real concern. In spite of knowing the things and the scope of utilization, we are not able to utilize. So that means what I feel is that a lot many things to do from the government of India or the state government, as well as the R&D, the central R&Ds, or the industry R&Ds. So you have to work together and really come out and really see that all these areas we are able to consume. And I think, as I told yesterday also, the LD slag problems will get resolved very soon if we all join hands together. Second aspect, what I wanted to just say that ladle furnace slag, there were a lot of questions yesterday also. The ladle furnace slag, it is of two kinds. One is the silicon kiln and another is the aluminum kiln. So we are coming up with the technology with HARSCO, the LHF slag briquetting, and that will replace the entire synthetic slag usage in the special grades, IF grades and all. So that is going to, we are going to set up that technology. Of course, there is no solution for the usage of silicon kiln slags as of now. Third thing, we have KR process for desulfurization. Means we are doing the lime injection for taking out the sulfurs. So whatever slag we are generating to the tune of 25 to 30 kg per ton, the entire slag we are reclaiming the metal, and the remaining slag we are utilizing back in sinter making. So 100% utilization of the HMPT slag, that is hot metal pretreatment slag. As Mr. Satpathy was talking about the R&D, if we just look at our R&D expenditure in the country is far below compared to any other developed countries, including China. So our R&D will be less than 1% of GDP compared to maybe 2.5 minimum to 4.5% in US. So definitely that is one area we need to focus, spend the R&D time to come out most of our problems. And one more thing, just for the information to the House, LD slag, why we are not consuming in the cement industry? Because of few reasons. One is the high Fe content. Another is the basicity is very high, which is not required by them, and they want some amount of alumina, which is also not there. So I think if we can develop some technology, and people are definitely thinking abroad. So in the liquid stage itself, if we can reduce the entire FeO, bring down the Fe content, wherein you can recover some amount of metals, and at the cost of some oxidizer, say maybe, reductant, that is maybe aluminum or something else, which will be economical. So you convert this slag into clinker, and most of the problems get resolved. So it is as good as clinker, which can be utilized in the cement plant. So, and one more thing is that definitely we have a lot of the mind block, I will say, that the resistance is very high whenever talk about the process waste utilization back into the process because of either zinc content or the alkali content or some other unusual elements which is detrimental to the process. So probably we have to come out of these mental blocks and start using and get the benefits out of it, and whatever problem arises, engage our R&Ds and sort it out in a course of time. One more thing what we are doing is yesterday it was discussed by Mr. Subhajyoti Mukherjee from ArcelorMittal. He was talking about the fly ash, recycling issue. So I'll say that today we have developed this fly ash, which is of high carbon, mainly generated when you consume the Corex coal. So that fly ash we're utilizing as binder for our micro pellet, as well as we have developed to use it in pellet plant also. So very soon we are going to use that also. So we replace the bentonite which is also having high alumina and silica. So with this, I think a lot of solution providers are there today. We have a series of lectures. So and they're definitely they're going to give us all the solutions which were discussed yesterday and today. So look forward to hear them and see what best and we implement those technologies and get out of this, dumping and accumulating the process waste in future. So thank you all, and thanks Mr. Nirmalo for organizing this very beautiful events, another topic which is very close to everyone, and it's the need of the day. It is the need of the future also, when we are growing, in terms of numbers of volumes, in terms of maybe 300 million tons or whatever maybe in near future. So thank you all once again. Thank you.
Thank you, Prabhatji. I think JSW has always been the leader, and will remain leader in waste management. And I have personally visited your plant, and I was really impressed where you are more than 90% of the waste you are trying to utilize within your listing. There is one question, Mr. Gautam Banerjee has raised, and in case you would like to have some answer, is that in HDMS slag, this slag has high sulfur, and that goes out as soaks during sinter making. So are you capturing it or releasing it in air?
No, we are not capturing it. We are not capturing it. Only we are utilizing the CaO value of this total slag, because it's got very high CaO value. So we don't want to waste this material.
Okay. Is there any other question if anybody is having? Because this was the question I have already asked. If there is no question, then I think Mr. V.S. Sarmaji has already come, and he has some prior engagement also. So now, Nirmalaji, I request you to please take over, and if you can welcome Sri V.R. Sarmaji, because he has come out from the meeting. I think Nirmalaji is not there. Sarmaji, good afternoon.
Yes. Good afternoon, sir. Good afternoon, everybody. And this is great to be part of different webinars nowadays. And I think we are meeting more often now than what we used to meet earlier. So it's something very good, and there's a good dissemination of knowledge. And I listened, though I was on mute and I was not visible to you, but I could listen all of the speakers. This is something excellent. You see, the time has come when we have to focus on two different agendas. One is how to utilize the waste of a steel plant. This is what we listened earlier. And the other is how to utilize the waste of mining sector, like iron ore mines. Today, we have more than 70 million ton of iron ore fines having Fe contents as low as 45% in tailing ponds, and as high as 58% as iron ore fines. So this is a big challenge in front of nation. Then similarly, we have a lot of coal fines, which are called pond fines, or pond fines in washeries, in cement plants, in steel plants, and also in coal washeries, and also in coal mines. So these pond fines, or ultra low size fines, this is a big challenge in front of nation, that what to do with these coal fines and what to do with the iron ore fines. Apart from using the iron ore fines into sintering process, now we are talking to a couple of companies in the world, though the test trials, the laboratory trials have already taken place. That is called micro pelletizing. So there are a few companies from Germany and a company from Brazil. They have shown interest that we can convert the even 45 microns of iron ore fines, which is a pellet feed, into or pond fines or tailings into a micro pellets. Micro pellets means a pellet size having 2 millimeter to 5 millimeter green pellet balls. And then these balls are in a rotary furnace. Rotary means the travel grade rotary furnace. These fines are baked, or you can say agglomerated, up to 150 degrees centigrade. And then these fines are transported through a conveyor to sinter plants. And then the sinter plant, they use it as sinter feed, as we are using 1 millimeter to 8 millimeter. The other good thing is we have the technology from VAI. Now it is Prime Metal, where they guaranteed us that we can use 60% of microfines less than 0.1. And now the trials are going on, and we will try to utilize these microfines in our sinter plants. There is a very intensive mixer which we have installed. And if this happens, then I think most of the problems will be resolved. But you know, the stock level in the entire country is pretty high. Today morning there was a report that the Karnataka mining industry, they approached government to allow them to export the iron ore fines, which are lying about 8 to 10 million tons in Karnataka. These are undeclared reserves, but when they go for true values and true quantity, it will be at least more than 20 million ton. So they are now requesting government to allow them this 8 million ton officially, but finally it will reach to about 20 million ton to export. Now the agony here is, we always say that don't export the minerals. On the side by side, we never think that what is the usage of these minerals, especially when China is in a position to take 52, 53, 54, 55, 58% iron ore. And if they can beneficiate and use in their pellet plants, why can't we? Here the problem is, we feel that the pellet plant people are making more profits. If we stop export of pellets, maybe this will solve the problem of scarcity of iron ore. But the question is not that. I mean, today, out of 70 million ton of pellet capacity, the actual capacity utilization is only 45 million. So the 25 million ton pellet plants capacity is still idle. So what is required to be done? The industry, the pellet industry, pelletization industry, sponge iron people, they should be given a special status by Government of India, because they are acting as scavengers. They are clearing the waste of the country. They are converting into beneficiating and converting into pellets, and pellets people then finally they sell it to the sponge iron units, and finally the sponge iron is reduced through iron ore fines duly beneficiated. So finally what has happened? We have reduced the dust pollution from the country. This is one. Number two, whatever was not utilized by major steel plants, we have utilized that particular product. Now the major steel plants, what are they using? The steel plants for their sinter plant, they are using 1 millimeter to 8 millimeter. So they don't use below 1 millimeter because they don't have the technology. Nobody in this country has started with a micro pelletizing. And in fact, in world, only one plant is working in Brazil. And now Jindal Steel and Power, we are working on this. Hopefully, we will install this plant in the next 6 to 8 months' time. So once the micro pelleting starts, then we can use these microfines also. Now, the next point is the iron ore. 4 DRI plants for the rotary kilns or SRN kilns is 5 millimeter to 18 millimeter. So below 5 millimeter is not suitable for the rotary kilns also. So ultimately, who is the taker of these fines? The taker of these fines can be only pellet plants. So we have to beneficiate, and then we have to use it in making pellets, and we have to go a China way. There are so many things and not many things, but we have to learn from China. We sometimes say that we can compete China, but it is very difficult to compete China unless we develop our own homegrown technologies, and we should learn from them, and we should try to utilize the entire iron ore finds which are lying in the country. So one is these people, all of the palletization people and sponge iron industry, they create a lot of wealth for the nation in terms of providing employment to the very highly illiterate or less qualified persons. Then they all are in the rural areas, so they provide steel to the rural areas. They they are clearing and they are consuming the waste products or unwanted products which are not utilized by the major steel plants. We have seen that millions of tons of dumps are lying in the premises of Steel Authority of India, and also I think with Tata Steel and with many more steel companies, those who are having their own iron ore, so they are not using this below 58% of Fe contains iron ore. So I think the time has come to utilize this. The second is, today I'm seeing that Honorable Prime Minister has told that the recycling of steel should be, the right place should be Alang. Alang is a ship breaking area in Gujarat. Here, I'm requesting to all of the government bodies and the policy makers, decision maker, Niti Aayog, that we should immediately go for one country, one tariff policy for electricity. So today electricity is ranging from 3 rupees per kilowatt hour to 12 rupees per kilowatt hour in the country. So this electricity should not be more than 3 rupees 50 paisa per kilowatt hour anywhere in the country, Kashmir to Kanyakumari. Then, many electric arc furnaces or induction furnaces can come in different pockets of the country. This will help consuming or recycling the steel scrap into a steel product. So this is where the government of India will have to find out the right solution, how to provide electricity throughout the country as one tariff, one country policy. China has one tariff, America has one tariff, Germany has one tariff, France has one tariff, Sweden has one tariff. All these countries having one tariff. I think perhaps India is the only country where the tariff changes from one state electricity board to another state electricity board. I do not know what are the reasons, but today the power through the e-exchange, the electricity exchange or the energy exchange is available even at 2 rupees 20 paisa at times. So when it can be made available at 2 rupees 20 paisa, why regularly it cannot be serviced or it cannot be supplied at 3 rupees 50 paisa across the country? So for that, the Coal India will have to play a very vital role, and Coal India will have to supply coal at a price of about 40 to 45 paisa per megacal, as against of 65 to 80 paisa megacal in current situation. So if it comes to 40 or 45 paisa per megacal, depending upon the distance a person has to travel with his material, so then we can produce power. The direct coal cost to generate power will be 1 rupees 30 paisa per kilowatt hour, and taking say about 15 to 20 paisa for the interest, another 10 paisa for depreciation, another 20 paisa for wheeling charges, and some profit for the industry. I think 2 rupees 50 or 2 rupees 70 paisa should be the price ex power plant, and finally keeping the profit margin of the state electricity board, DISCOM, distribution people, the power should be made available at 3 rupees 50 paisa across the country. So this is one area. The second area which we have to ponder upon and how to do it is the coal. The coal, as we have discussed many times, that coal will not be required after the year 2050, because alternate sources of energy, they are developing very fast. And this is how the coal-based economy has to enter into a gas-based economy. This is what Honorable Prime Minister told last month to US business houses, that India wants to be a gas-based economy instead of coal-based economy. And he is looking that somebody should come and they should convert our coal into gas, and then finally gas to gasoline, gas to HSD, high-speed diesel, gas to olefins, gas to plastics, and gas to DRI. So I'm pleased to inform everybody, those who are participating here, that we are running our gasification in full swing. Our DRI plant is running now regularly, continuously, non-stop at 200 tons per hour, and we want to elevate it to 250 ton per hour. Hopefully, in next 1 week time, we will reach to 250 ton per hour. It is based on 100% domestic Swadeshi coal. We are not using any imported coal. Thanks to Mahanadi Coalfield and thanks to Coal India, they are providing coal in Angul to us. And this is a direct import substitution. We are substituting the costly, expensive coking coal. Had it not been there, then we would have put another blast furnace today. So we are not now thinking for any other blast furnace. We want to work that we should try to produce DRI up to 250 tons an hour. And now the production is 200 tons an hour. Mr. Naveen Jindal, he has dreamt this project and his dream has come true. He has already invited the steel fraternity to come and to see our coal gasification and to see the DRI plant, how we are doing. And this is a hot DRI, direct link from hot DRI to 250 ton of electric arc furnace, which is the largest electric arc furnace today in the country. 250 tons furnace is the highest level and largest capacity furnace. We are also using DRI in our converter shop. We use in converter shop every day around 1,500 tons of DRI as a chiller. So cold DRI we are using as a chiller, and hot DRI is going into electric arc furnace directly. And this is how Angul is producing about 14,000 tons steel every day. And this is a game changer, we would say. I'm also happy to inform, just for the knowledge of everybody, so that you all are encouraged toward this technology. And I don't want to be a brand ambassador, but I want, as a technical person, as a technocrat, I want to share some data so that you all will be in a position to take some decisions. Today, we are producing DRI with the increased pellet cost at 14,500 rupees a ton. And this is including coal gasification cost and material cost in DRI. So, which is a very competitive cost when you compare with the SRN kilns or the rotary kilns or revolving kilns. And the other good factor is that we are now using, this is the first time in the world, anybody has tried out, we are also using 30% coke oven gas, COG, in our DRI plant. So the COG and syngas together, they are mixed in the DRI plant, and we are using COG as well as syngas. So this is what has given us a new life, and JSPL has proven that coal gasification and coke oven gas can be together used to produce DRI. The entire chemical energy available in coal gas and COG, and also the chemical energy that is hydrogen and CO available in syngas, they can be used hands in hand simultaneously together. So this is how we can make our country a country of our dreams, and we can reach to the final destination, how to reduce our dependence on imported high-cost coking coal. Next point, I'll not take much of your time. The next point is the whole world is thinking how China is working. The China with 1.45 billion people, they are now consuming more than 1 billion ton of steel, and we are aiming 300 million ton steel. So I always tell people that, look, unless we invite the FDI in steel sector, the Indian banks will be unable to fund the projects worth 180 million tons in next 10 years time, because always banks are having a negative outlook on steel. So there has to be a financial institution, as it used to be 30 years back, ICICI, IDBI, IFCI. There has to be a steel or core sector based financial institution in the country, so that these plants can come and we can reach to a level of 300 million ton. Finally, the steel is an economy trigger, and we must utilize this. If we cannot, then we must invite the multinational companies, because the gap today is 180 million when we see the today's capacity and production versus 300 million ton. So we produce today about 120 million ton, and the final destination is 300 million ton. That means 180 million ton is still a gap. So in 180 million ton, if you put up 10 million ton each plant, then you need 18 plant. And suppose we say that, okay, SAIL will produce 50 million, JSW may produce 50 million, who else will put 50 million? So the gap is 180 million. So from where the another 80 million will come? So the 80 million can come only from the 10 plants of 8 million ton each. And to produce 8 million ton, a company needs about 7 to 8 years time. So there is no time available. So I am afraid that in 2025, we will be importing at least 50 million ton steel in the country, because there are no plans on anvil today. We keep hearing that SAIL will be at 50 million ton, JSW will also produce 50 million ton, but the journey is too long. To reach to 50 million ton, they should have started their work today, but they are still late. If they have that appetite and they have the funds available to reach to 50 million ton, then it is very good. We feel in JSPL we can only reach to another 4 or 5 million ton. We cannot reach 20, 30 or 40 million ton unless the financial arrangement, financial closure is done. So last point, after 2050, neither the coal nor the iron ore will be required in the world. Why iron ore will not be required? Because if you see the data is available worldwide, all the developed economies, their steel consumptions are negative 3%, 4%, 5% like that. So once the whole world by 2050 is developed, then the steel consumption as a virgin steel will be negligible. So what we have to do, the steel produced in the year 2000 to 2010 will come for recycling. And that will be a gigantic volume. That will be around 1800 million ton a year. These are the published data. So 1800 million ton per year from the world, the steel will come for recycling. So the topic chosen by Mr. Nirmala today, that makes a lot of sense, that 1.8 billion ton of recycling, who will do it? How it will be done? Where are those electric arc furnaces that they can do it? So people, those who are youngsters now, those who are in the early 20s or 25, 20, 30 years of age, they may see that in 2050 or 2055, all of the iron ores in the world, all of the iron ore mines in the world will be closed down forever. All of the coal plants, coal mines will be closed forever. And there will be some composite metal available in the world, and recycling will be the business. So it's a very good topic, very good subject. All of us must try to influence the policymakers to look for 2050 and not only 2030. We should look on 2060 when there'll be no mining anywhere in the world except for the rare earth minerals. But sure, not coal and not for iron ore. Thank you very much.
Thank you, Sarmaji, for your inspirational views and speech. And what you told, that is very right, that 70 million ton fines. But if you see official record, 70 million ton fines and waste must be lying only in one unit, that is SAIL plant only, various units of the SAIL plant. Because we have made an estimate in ministry and we observed that it is more than around 150 million ton of fines, waste in form of tailings, dust, so many things are lying in various plants, and you have rightly told that these natural resources has to be utilized. In country has set up 116 million ton beneficiation plant capacity and 88 million ton pelletization capacity in the country. But you have rightly told more than 50% are lying closed. So time has come, if we can start using through these ways, so that natural resource conservation also will be there, and we will be more competitive in the global market also. And what initiative you have taken for your COG utilization, because COG, coke oven is nothing but a pyrolysis unit, which is giving better gas than a syngas. because it is having 50 to 60%. And I think you have shown a path to the steel industry that in time to come, COG can be used in blast furnace also and other places also, so that its basic object benefit can be utilized by the industry to become globally cost competitive. Thank you very much. And now I request Nirmala Mukherjee ji to especially
And
give thanks.
Nirmala, before you make a comment, I would like to tag along with Sharmaji's last phase of his speech, which is about recycling. In fact, recently we, from Big River Steel, we have been chosen by some of the European steelmakers for their Vision 2039 and Vision 2040, 35, and 2050, where they're looking for completely recycled steel usage and using renewable energy sources only. And from that standpoint, in fact, they're looking for people who can produce the steel grades, the different steel grades from 100% scrap sources. And this is coming, in fact, a big time. So Sharmaji's point is, in fact, it's going to be even driven, maybe even driven earlier than 2040, 2050 level. I mean, the rate of change is going to be tremendous. We are, they're introducing all these taxes on CO2 emissions. So carbon taxes are getting levied. So people will be really challenged in most of the developing countries to keep their production through the iron ore route. So it's going to be a game changer, as he said. So thank you, Sharmaji, for pointing that out. And this is absolutely brilliant. And this is going to be a real game changer.
Thank you, Sabyasachi. It's good. So, this means in United States and Big River Steel, your customers, they are encouraging and promoting the recycling. That means they will buy the steel which is processed through a recycling route and not through a virgin route, not through a iron ore route, so that you can preserve the forests and you can preserve the mines and you can reduce the load on the environment. Am I right?
Yes, absolutely, sir. In fact, one of the biggest challenges, and India's scrap policy is very much time perfect. If you look at the entire scrap industry, and Sharmaji, you have been around for several years and you know the entire process. Scrap industry is running on a very old way. Scrap is scrap. There is no knowledge. Every single kg, every single pound of steel is sold, consumed based on proper certification. Not a single pound of scrap or kg of scrap is processed, sold, purchased based on any certification other than visualization and a general categorization, which needs to change. So if we have to have a circular economy, the consumers of steel today must recognize that what they are creating as a waste, scrap, is a feed source for their future material consumption. Naturally, that sense of recognition and the implementation in their own processes to segregate those scraps for specific grades and for specific use needs to come in place.
Good. Right. Very good. Thank you.
Very good.
Thank you, Sharma ji. पहले तो मैं आपको गणपति गणेश चतुर्थी का अभिनंदन आप इस छुट्टी के दिन में भी the fact that you could join us, and I know that I can see that you are traveling. In spite of that, in between your travel, stop. But
no
without
problem.
you,
I'm in the car. I'm comfortable. I'm in the car. No problem.
Now, whenever you are there, there are a lot of questions which arise. For example, the issues which you raised with regard to the electricity tariff, with regard to promotion of coal gasification. So these are issues which is already a hot topic today. And I always keep telling you, Sarma Sahab, that you always think ahead of time. Whatever.
One more thing, Nirmala, which I could not tell you, and this is picking up very fast, that, there are 3 rating agencies, international accrediting agency in the country, and they do the rating of the steel plants and some other plants, all of the plants, and they rate them A, AAA, A+, B+, B-, And you know what the banks are doing. I also spoke to Madam Sitaraman, Nirmala Sitaraman, and I requested her that kindly devise a methodology that the rate of interest fixed by banks based on ratings is a very wrong benchmark, because when we are any company, which whether it is triple B minus or triple B plus or double B or A or triple A plus, any company which has been extended loans or working capital loan after due diligence, that means all strength and weaknesses have been taken care of. So now, if some company is at A level or A plus level, they are charged, say, 7.5% of rate of interest. And the companies, those who are in triple B or double B, they are charged at 10.5 to 11% of interest. So this is something ridiculous, because the triple B person is a on-time payment they are making. There is no default, and they pay 3.5 to 4% additional rate of interest, which is a huge money. So this means the banks are not supporting the people, those who are tier 2 or those who want to come up in their life. They are understanding that this money is going to be NPA, and that's why they are charging them very hefty rate of interest. So this is what I requested Madam Sitaramanji, that kindly, Madam, look into this matter. This is a very, very abnormal anomaly which should not happen. If yes, you have to incentivize or you have to encourage the AA, AAA people, then okay, you maintain a gap of 0.5%. Why the gap should be 5% or 4% in between the best borrower versus the best borrower, but not performing, or his company is having triple B rating, but he must be the best. So this is what we are now taking up in the nation, no matter whether interest rate is 7% or 8% or 9%. I'm not advocating that you reduce the interest rate, but the delta should be as low as possible, like 0.5. If I were the finance minister, I'll make it 0, because my calculation will be based on the repayment cycles and no default cycle. Whether the company is in triple B rated or double B rated or plus triple A rated. There are many triple A plus rated companies, those who have become bankrupt, and they have enjoyed the low rate of interest. They have taken lakhs of crores of rupees. You know, I don't want to name those companies. And then finally they found that they are bankrupt. So this rating business, that has to go away from this country. There should not be any rating business for interest purposes. Rating business can be only in notional or a nominal barometer, that yes, this company is better maybe for the stock exchange, for the street, but not for the interest rate. So these are biggest anomaly in the system, and we all will have to come forward to eliminate this this anomaly, that if a person who is paying on time, no default whatsoever it may be, still he has to pay 3 to 4% more rate of interest than AAA rated or AA rated or AA rated or A rated. So this is what we are raising now. So why I'm telling you through your form, because your association is a non-profit making organization, and you can always write to anybody in the country. So I'll also request you from your desk, please write to the chairman, write to the Prime Minister, write to the Madam Nirmala Sitaraman, also write to RBI, because you know your voice is the industry's voice. Thank you.
Thank you, Sharma Sahab. You know, the first thing which I think you did when you came back as managing director, before that you were deputy managing director, but in the second stint when you came back as manager, the first thing which you did as MD of JSPL was to look at finance management, was to service the debts effectively. And because you do that, because you have done that effectively, that is why JSPL stands on a much stronger footing today. The fact that you took this up, I would say, on a one footing to reduce your debt burden. Next to you, I can see Mr. Saxena, Director Operations of Vizag Steel Plant RINL, which is now facing that same challenge. If I'm not wrong, Saxena Sahab, your total debt burden is now close to 24,000 crores. close to,
let-
if I'm not mistaken, it is close to 24,000 crore, right?
little less than that.
Yeah, because that when during this, especially during this period of pandemic, and a little bit period before that, RNL had a big challenge. It was one time a zero debt company. In 2005, I went to Vizag to celebrate the turnaround of Vizag Steel Plant because it became a zero debt company at that time. Mr. B.K. Panda was the chairman of Vizag Steel Plant that time. Today, again, we all know steel industry is cyclical. So, as Sharma Sahab rightly pointed out, this will go on, but we should have that steady policy in place. Where we have what we call a level playing field. It's not a level playing field as of now. Any questions for Mr. V.R. Sharma? I'm sure Mr. Abhijit Gupta, Mr. Amit Srivastava, they'll be having a couple of questions. So because Mr. Sharma is, as you can see, traveling in a car, so we can't hold him for very long. So any questions that you have for Mr. Sharma? Mr. Abhijit Gupta, do you have a question for him? You have to unmute yourself. Yeah, do you have a question for Mr. V.R. Sharma?
Hello.
Yeah.
Yes, please.
No, not specifically. We heard Mr. Sharma, and it was really encouraging. And we know that he is taking a lot of initiatives, especially in case of pelletization. And we as a HARSCO are very much interested to talk about on this subject already. So it's a really great move towards waste management, which will really serve the country in future. So he is always a front runner. So it will be obviously a motivating factor for us to work in his journey. Thank you.
Thank you so
Okay,
much. Thank you.
EcoMaster is known globally. So Mr. Amit Srivastava or Mr. Santiago Fosher, your CEO. Mr. Amit Srivastava is Managing Director of EcoMaster in India. And I think they have done already a lot of work in, if I'm not mistaken, in JSPL Angul also, right?
Yeah,
Mr.
so
Srivastava,
thank you.
JSPL Raigad as well as Angul, both the locations.
Thank you, Sharma Sahab has given first opportunity to our new technology in India. That was in JSPL Raigad and Angul in 2013. And still we are working and we are taking guidance from him. And we know his long vision and he's thinking always. So whatever he's thinking for 2050 and 2060, we all should work for that.
Yeah, especially micro pelletization, which you spoke about. There are various areas which actually JSPL has been I would say the leader in terms of or the pioneer in India. So having said that, I would always like to see Sharma Sahab lead the country in terms of technology, in terms of adopting ways and means which the others have not. Now someone is sharing the screen. Can you stop this?
Mr. Pawan Verma, I think from
You
your
are
side,
sharing. Yeah, please stop.
Screen sharing.
Yeah, please stop sharing the screen. Please stop sharing because otherwise I cannot see everyone. Amit, can you stop? Yeah.
Sharmaji, Vermaji, please.
Yeah, please. Please share the screen when only you are presenting. Otherwise, it creates a problem. Mr. Fosher, do you have a question for Mr. V.R. Sharma?
I found it very encouraging, the discussion, and the growth I think that we'll see in India is amazing. India is amazing as a country, and it's so exciting to hear, Mr. Sharma speak about the challenges. I think for us, it brings great opportunity. Micropelletization was discussed, and that brought about a lot of thoughts in my mind as to how can we use ladle furnace slags as the cementing materials, and that would help us in those sintering processes. And with the plants that we have present at Angul, within JSPL, Rygar, you know, those materials can be converted into cementitious materials that would then find use in these micropelletizations and these other applications. So I think it's extremely exciting. I also think the discussion as to the transition of India towards a circular economy is also amazing, and that we see this happening globally. Big River Steel, you know, focusing on those advances, that know-how, that development being shared throughout, the work on DRI production and syngas synthesis and use of those gases. It's beautiful to see, actually. It's what we need to be working on, actually, as humans, as environmentalists, as socialists. So I don't know that I have a question per se. I just wanted to thank Mr. Sharma for this. It's really encouraging, and it makes me very happy to be here with you, getting up at 4 in the morning to participate in this conference. So I just want to say a thank you.
Thank you so much. Thank you.
Yeah.
I have a
Thank you so
question
much,
for
Mr.
Sharmaji.
Thank you.
Yeah,
Thank you.
please.
Narmala.
Yeah,
I want
please,
to-
Shobhita.
I want to pick his brain. Sharmaji, you rightly put that perspective on the recycling. So from your standpoint, and being also over at Bangladesh steel companies where they use a lot of scrap, how do you see this change coming in place, especially in Indian scenario? Because obviously scrap is going to be generated, scrap is going to come in. How is this journey going to take place in India?
You see, the future of India in terms of recycling is very bright. Today, the automotive industries, including car, trucks, motorcycles, commercial vehicles, we consume about 10 million ton steel a year. And this 10 million ton, after 10 years, it becomes, it is available for the recycling. So if 10 million ton per year vehicle shredded scrap is available, then you can imagine that at least 8% of the total requirement of the steel can be met out today from this 10 million ton. So today India imports about 8 million ton scrap, mainly HMS. People don't know what is shred, and they don't use it because it's about $15 to $20 costlier. Whereas in Bangladesh, 80% of the shred which is coming, that is in the form of shred. And out of the total shred coming to Bangladesh, 95% is coming from US West Coast, be it Sims, be it Snitzer, be it PNW, be it Metro Metal. All these companies are supplying to Bangladesh. So they have also found a convenience supplying to Bangladesh through Pacific and then coming to Indian Ocean and then finally reaching to Bay of Bengal and Chittagong. So that takes about 22 to 25 days time, a 30,000 ton or 32,000 tons of vessel. The draft level in Bangladesh is about 8.5 meter on the berth, whereas outer anchorage is about 11.2 meters. So a vessel of 190 meter long is most suitable with having 8.5 or 8.8 meters of draft level. So this is how Bangladesh has developed their steel industry. And they are continuing doing it. The HMS or the PNS, the plate and structure, so that scrap is locally available from the ship breaking. And there's a good blend of ship breaking scrap, that is HMS or PNS, plus shredded scrap. So this is something blessings to the steel industry in Bangladesh. So three major buyers today, four major buyers I would say. The Abul Khair is one, number two is BSRM, and number three is KSRM, that is Kabir, and now the upcoming company is GPI. So they are the major consumer of scrap, and it is quite surprising that Bangladesh consumes more scrap than entire India consumes. So they are number one now. Times to come, today the world scrap market is governed by Turkey. I think the Indian subcontinent by 2022 or 2023 will decide the world scrap prices, because the Turkey consumes about 20 million ton of scrap. Put together India, Pakistan, Bangladesh, they can do around 30 million ton scrap in next 2 to 3 years time. It is only a matter of electricity cost. The moment the electricity cost is rationalized, then more and more electric arc furnaces will come throughout the country. And today, in fact, there is only one company which is a truly international or I would say export-oriented company that can be declared, and that is RINL, Rashtriya Ispat Nigam Limited. That's the only steel plant in the country. We are proud of them that they are port-based plant. And since they are port-based plant, government must acknowledge them that they are a EOU, export-oriented unit. It is not only a domestic unit. I mean, whatever fiscal benefits government can pass on to them, they should pass on to them. So they are worth declaring as a export-worthy unit, if not export-oriented unit. Now, if it is electric arc furnaces, then there is no limitation. Today, people want to put electric arc furnaces in the areas where there is electricity is cheaper. But those areas do not have scrap. Then again, they are based on DRI. They are based on sponge iron. They are based on pelletization cum sponge iron, like that. So that is not a very effective way of getting a better yield. So the slag levels are very high, and the overall production is very less. 30% is the slag level in DRI route. So if you put a million ton of steel making, then you generate about 300,000 tons of slag, which is not a very good scenario. So the best is we must have our scrap processing units throughout the country, having HMS, PNS, and also the shredded scrap in a big way. If the need be, we can import these scrap cars duly compressed and pressed, remove all of the engine parts and tires and gas tank or whatever, and bring only the car bodies, and that can be shredded in a good shredder. Unfortunately, today India does not have any shredder. So the India should have automatic, best of the state-of-the-art shredders, what United States is having, or what some of the companies in Rotterdam is having. So we have to have those kind of facilities here. Though the scrap policy has been hovering around for last 5 years in the country, but finally the decision has not yet been taken that what should be the right way and what should be the right philosophy to put up these scrap processing units. So coming back on your question, the scrap-based electric arc furnaces will be in big use. One, the government need to rationalize the price for the electricity, and then they don't need to come to the central part of the country, which is already overloaded in terms of environmental issues. The 7 brothers and 7 sisters, we call them 7 sisters. All the 7 northeast states. States, and 7 brother states are, it starts from Madhya Pradesh, then it is Chhattisgarh, Jharkhand, West Bengal, Odisha, and Bihar, and part of Telangana and Andhra Pradesh. So these 7 brother states are overloaded in terms of industrialization for the steel making or metals and mining. So we have to come out from these 7 states. The 7 states are fully occupied. The railway lines, the logistics, the movement is always in trouble. So how to come out from them? We can come out only by rationalizing or reducing the electricity cost. And we are flooded with 350 billion ton of coal. We are a socialist democratic country. So we have approach, our mind is socialist. and our system is democratic. So if we pick up our mind, then we must give the benefit of the coal available in Jharkhand or in Odisha or in West Bengal or in Bihar. That benefit should go to the last mile person in Rameshwaram and or in Kashmir, and that can only go through the wires. That means through the transmission towers. That means through electricity and nothing more than that. India is having a very least electricity consumption per capita, less than 1,000 units per year, whereas United States is having 9,500 units, China is having 8,000 units. So it is very low. So there is a long way to go. So we must consume this coal, this 350 billion ton of coal buried under the grounds for millions of years. I mean, that should be used in next 20, 30 years time. And we should develop our country. We must think like what Saudi Arabia thinking. We must think like Qatar, Bahrain, Abu Dhabi. They are pumping out oil whenever is required, full. They are not saying that we need it for our next generation. Why people need it for next generation? There's no need. So this is what we have to do. So, and here the next generation can also can't use it because they will be not allowed to use scrap by the world economies. And that's all. So the port-based electric arc furnaces is the solution. The scrap recycling is a solution. All of the buildings made out of brick and mortar are to be stopped immediately. We must produce buildings from long products, rolled products, fabricated products, steel products. And this is what we should do. And the moment we do this, then we can do a different business. I tell you one more thing. More and more steel buildings means more and more solar power, because all of the steel buildings will have the glasses, and these glasses will not be ordinary glass. All these glasses will be the solar panel glasses. So they will generate a lot of power. So these buildings will be self-sufficient, self-reliant in terms of producing power. So this is what's happening in China. This is what's happening in Norway. This is what's happening in Sweden. This is what's happening now in the new buildings in the United States. So these are the areas we should ponder upon.
Thank you. One of the areas that I have always wondered, in fact, in US, if you look at it, sir, that many of the steelmakers have done backward integration in the scrap business. And I have been wondering whether the Indian steel industry would take similar step given the upcoming future needs that's in front of us in India.
You see, the business is always a proximity effect. There are few people, those who will take the lead, the others will follow. That is called the proximity effect. So once somebody has taken a decision, like we in JSPL, we have taken a decision in 2007, we thought that we will put up a coal-based coal gasification plant and coupled with a DRI plant. It took a lot of time. 2013, the project was ready. The first DRI was produced on 14th of February 2014. But unfortunately, because of no coal, we couldn't sustain, we couldn't run it. And now, from 28 December 2019, it has been working regularly. We started with a very humble beginning of 80 ton or 100 ton an hour. And today we are reached to 200 tons an hour. And hopefully in next 1 week time, we'll reach to full capacity of 250 tons an hour. And we started with all 100% syngas. And now 33% gas, we are using coke oven gas. And this is where the catch is. And the high methane, having about 10 to 12% of methane. Now we are breaking this methane within the retort at 1000 degree. And this is where we use it. Earlier we were using a lot of oxygen. Now we have reduced the consumption of oxygen, and we are using to burn this methane, convert into the final value chain and CO2 plus H2O, because it is CH4, and that we are now converting within the retort, and that has helped us in reducing our overall the footprint of the gas consumption. So we are today better than the natural gas-based DRI plants, because the cost of gas today In our case, it's just 3,000 rupees per ton of DRI. And this is what we were aiming for. This is the reason we are now producing DRI at 14,500 rupees. I'm sharing all these numbers to all of you to encourage you, because all of my fellow panelists and the listeners here, they must feel that, okay, initial cost may be high, but there can be a solution that government, the Coal India, they must come with a mega coal gasification units on the pit head basis, and then they should lay the pipeline and deliver within the vicinity of about 100 kilometers to all of the small DRI kilns and DRI plants. Now, when the first DRI plant was produced in the world, that was with 5.15 meter diameter, and it we have reached 0.85 meters with 2.5 million ton capacity. So I think the right time, people should come to a level about 500 to 600,000 tons of mini module, and with the piped gas of syngas from Coal India or from Indian Oil or from other private producers through a pipeline to various steel plants in the vicinity of about 50 to 100 kilometers of the coal mines, they can be serviced. And this is what the challenge is now. The moment they are having this gas, because natural gas is not available in the country, so this gas is the best alternate to produce DRI.
Yeah, Subrata, do you have a question for Sharma sir? One on a lighter vein, I saw your interaction with Sabyasachi Sharma sir, and one thing came to my mind. The irony is, Sabyasachi never worked with you. He did not get a chance to work with you rather. When he joined, you had left. But you also worked with Ravi Uppal. He also worked under Ravi Uppal. So I think he still misses working with you. So he still wants to come back to Angul to work with you in Angul. Because
I tell you, it's all destiny. I met Sabyasachi first time when I visited myself and I was in Bhushan. So myself and Mr. Sanjay Singhal, we visited his plant. He was heading the steel melt shop, and it was he who took us around in Big River, and we visited the entire plant, and we had a nice lunch together. So actually, as you know, as Columbus discovered America, so I discovered Sabyasachi.
Yes. Sharma ji, I don't know whether you remember, when I was in Dastur, we met you in your Delhi office. You were in JSPL that
Namaskar,
time.
sir. Namaskar.
Really an absorbing discussion you had regarding power. I fully agree with you. Power is a big problem in India. But one thing, scrap melting, 250-ton arc furnace, the grid has to be strong. Absolutely. So there are a lot of issues which we have to sort it out. When we distribute the arc furnaces, grid power has to be there. Now, regarding the alternate energy, solar power, actually, I am not sure whether you can throw some light, not here maybe, how the solar power can contribute in arcing.
Yes, sir. I tell you, we have studied this matter. The solar power cannot substitute the fault levels of the grid. So the grid in any case is required, and jointly the Indian, if you see the total matrix of the grids in India, so like the eastern grid is having 32,000 megawatt grid, the central grid is about 28,000 mega grid, northern and western front grid is about 51,000 megawatt grid, and the down, if you see the western side, is again 40,000 megawatt grid. Put together, India is having 340,000 megawatt, and all the grids are interconnected. Okay, because of the country's requirements, sometimes few of the grids are kept always on the island mode, so that in case of any disaster, in case of any failure, the entire country does not go to blackout. So the difference of solar versus electric arc furnace, the solar will never be used as a electricity source for the electric arc furnaces. Solar will be used for the another 43% of another 43. There are total 47% for 53% of the power India uses in terms of steel, in terms of industry, and another 43% is used for the commercial buildings, houses, domestic, and small loads. So we should assume that this solar, wind, everything will be servicing through grid, of course, to this kind of industry, and which is today it is very negligible, because India is having only 4% power through nuclear, and through non-conventional like solar and wind power, we are still at only 7%. So it is very less amount, and balance we are still working. 2% is on gas base, and balance we are working through the Rankine cycle of using boilers and using coal and everything. So which is more than 85%. So the hydro is also very minimum, about 7 to 8%. So I think the solar will never be used as a source for the electric arc furnaces, because the fault level will not be serviced. So the best way is to maintain everything we have to inject into grid, and the grid has to be made more and more stronger. The another point, the good future for this nation is, today we still have 230 kVA lines. So this all 230 kVA lines are to be phased out. So we should now move to 750 kVA and 1250 kVA. And we don't need any right of way, new right of way, because the 230 kVA lines, even 132 kV line and 66 kV lines and 33 kV lines are also running in the country. So all of these lines should be uprooted, thrown out. And we should be under the same right of way, we must build 750 kV and 1250 kV lines. And the moment that comes, that means more consumption of steel, more consumption of conductors, more consumption of insulators, more consumption of the new, brand new 1250 kV, 750 kV, the substations, and means less, or I would say negligible faults. And finally, the losses are less than 0.05%. That time will come in this country. When this time will come, the policymakers, the decision makers, the Niti Aayog, Government of India, Ministry of Energy, they'll have to look after. Power Grid Corporation of India will have to look after how fast they should convert the lines to first graduation to 750 kV, and the new lines should not be less than 1250 kV in the country. We have the steel available to meet out all these requirements. We have the cement available. We have the conductors available. We have everything available. The only thing is, and we have the land available, because it will be in the same land. There'll be no new right of way. We will not damage the agriculture fields. So this is what this scenario is. We have to graduate and post-graduate to that levels. So with 250 tons of furnace, electric arc furnace, like we are on the eastern grid, which is very strong grid, 32,000 megawatt, there is no issue at all. The fault levels are very high. Nowadays, I'll also reveal that for the last 5 years, Bangladesh grid is connected with Eastern grid, Calcutta grid, and Calcutta is supplying them about 1500 kilowatt line, and Agartala is supplying them another 250 kilowatt. Agartala grid is also about 11,000 kV, 11,000 megawatt, and the Calcutta grid, Eastern grid, is again part of 32,000 megawatt, and this has also increased the fault levels and the tolerance of Bangladesh grid. And Bangladesh is on 230 kV, and Bangladesh, there are ample scopes for Bangladesh industrialists to put up more and more and bigger electric arc furnaces, and this is called the inclusive growth. One more thing I'll tell for Bangladesh people, those who may be in this webinar, that Bangladesh is having a potential of supplying at least minimum 10 million ton steel to India. All of our 7 sisters, they are just 200 miles away from Chittagong. So there is no point supplying steel or cement from central part of India to Manipur, Imphal, Aizawl, or Itanagar. We must supply from Bangladesh. So this is called a inclusive growth This is how, when a bigger country grows, the adjoining countries, friendly countries, they also grow. So it's a very good approach. Government of India and Government of Bangladesh are enjoying a very good relationship at political level, diplomatic level, and I think one day we will have more and better cooperation in times to come.
Thank you. Thank you, Sharma ji. Nicely
Thank you,
explained.
Sharma Sahab. आपका मोबाइल पलट गया था, so you have to just turn around the mobile. 180
Okay, thank you.
degrees.
And
Yes, yes.
Nirmalya, I have to thank Sharmaji for his excellent memory
You have
and
to turn it around.
compliments.
Yeah. Sharma Sahab, again, turn it around. अभी भी उल्टा है. Now it's okay. Yeah, thank you, Sampradha. Thank you, Sampradha, for your.
No, I was just trying to thank Sharmaji for his excellent recollection of events. And yes, we had first met in 2008 in Columbus, Mississippi. Thank you, Sharmaji. We must sometimes catch up and have a little chat about those days.
Thank you so much. God is great. Let us see. We never know when we again cross together.
Sure, sir.
Thank you, Sharma ji.
Thank you, sir.
Thank you, Sharma Sahab. आप अभी बने रहिए. We could.
I'm online. No problem. I'll be traveling, but I'm online. No problem.
Thank you, Sharma Sahab. So with that, let me tell you, we really have not lost much time because Mr. Prabhat Kumar Ghori is already done. Mr. Shukla, he is going to be a listener today since yesterday most of it was covered by Shubhajyoti Da. So he will prefer to be a listener today than do the talking. So we go straight into Mr. Mario Curie also clarified that he will not do the topic. He will leave it on to his Indian colleague, Mr. Abhijit Gupta, Director Sales and Marketing. So Dr. Mukesh Kumar, the next speaker will be Mr. Abhijit Gupta, who is the Director Sales and Marketing of Harsco India, and followed by Mr. Abhijit Gupta will be the most important presentation that we are waiting for, which is Rashmi. I'm sure Rashmi is ready by the time Mr. Abhijit Gupta finishes his presentation. The floor is yours, Mr. Gupta.
Now I request if you can take the floor. And because Harsco, everybody knows that the way you are operating in various steel plants, the type of services you are offering in the waste management services, material management services, most of the steel people who are either in the steel business, and they will be very keen to listen to you about your new areas and how wherever you have made innovative type of thing, your operational things. Now floor to you.
Is it visible to you, sir?
And your slide is not visible. Please share a screen. There is a button in the bottom, share a screen, if you can do that thing.
Yeah, I have shared the screen. Just a minute. One moment, sir. Can you see my screen now?
No, right now, till now not. I think you have not pressed the bottom green button, share screen.
Yes, sir. I have pressed the green button and then I am sharing my screen. Is it now visible?
No, but what you can try doing, Mr. Gupta, is maybe you can open the presentation first and then you can go to the share screen option and you will see the PowerPoint presentation over there.
Just a minute. Yeah, I'm shared my screen. Can you see my screen now?
Yeah, now it is coming. It is coming.
Okay. So it's a pleasure for me to participate into this after such a wonderful discussion given by the panelists. I mean, coming back to this technical discussion is a challenging one because we heard a lot of things from Mr. Sharma and all dignitaries and the experienced panelists. So I was listening. I was learning a lot of things from this. Anyway, as a part of the discussions, I would just like to run through what we're doing in this. As you told, Mr. Kumar has told that we are in this business since quite a long time. It's true. We are there. Since 1853, Harsco has established their business, but in this particular environmental business, where from 1956, almost at the same time when the Indian steel industry began their journey, that time Harsco has started their services, and mainly our motto was that we will be providing the environmental solutions, and environmental solution actually encompass the whole things. Not only it covers all the activity inside the steel industries, and that is our motto. We always focus that this will be a zero waste, zero emission, and zero harm objective. So from that point of view, Harsco started their journey. They started giving the solution on a BOO basis, when they take the responsibility of the complete solution, design, build, and own, and give this solution to the client. And our main focus was that when client is focusing on their core business, we should take care of their non-core sector and let them be busy with their core sector where the steel making is there. We should take care of the rest of the things so that they will be happy and they don't have any pain points. So we are doing that. We are doing the complete services, which right from the iron slag recycling, the hot slag management, all the sludge treatment, scale treatment, scrap management. I was listening the scrap management topics, which was very, very interesting, because probably most of you knows that we are doing a scrap management in Europe plant. We have a regular shredding. We are doing the shredding and all other things in Tata Port Albert, Cardiff, in a lot of the places. And we are doing that ladle metallurgy management. So I would just go through what we are doing, what kind of services we are providing to the industry. And by with the kind of experience so far, we were processing nearly 30 million tons of slag per annum and recovering almost 5 million tons of metals, which is quite a large amount. And we are actually serving 10% of the global quantity. We are yet to reach to that level, because there are plenty of opportunity in China. We have started working, but we yet to gear up that we are really crossing the 20-25% of the global quantity. Markets in excess, 10 million ton of slag product we market. We process around almost 2.5 million ton. So what we are doing actually in case of steel plant byproduct, when there is a lot of improvement in the steel making, but one thing we could not get out of it is the generation of the byproduct. We cannot say that we are creating a very less byproduct at this moment of time. A lot of work has been done so far across the globe, but the byproduct generation is a challenge from them, reducing that quantity. So when there is a byproduct, always we have to find a solution, and there are numerous solutions available at this moment of time. Over the years, we have several innovative solution technologies developed to allow the efficient management and utilization. What is most important thing is that we found that if we can do the correct management of this byproduct, we can recover value. We can reduce the existing operating cost. So that's our motto. We have started doing these things. And when we are talking about the byproduct, as our previous speaker told, we have actually taken the byproduct in two categories. One is a slag, another one, rest of the oxides. So why slag? Because slag is contributing to the circular economy to the greater extent. So when we are going to the slag, the first step which we understood is that we have to really segregate the slag at the first step of the slag management. What happened so far in Indian industries also is that we actually did not segregate the slag properly. And that's why we lost the value associated with them. We have just dumped all slag in the same place, and we lost the opportunity to extract value out of it. So the first step which we are doing is that we are separating the slags. We are treating each slag separately. When we are treating EAF, we are treating BOF separately. We are treating alumina slag separately. We are treating KR and HMDS separately. So each of them has contributed in the cycle of the value production. If we mix it up, we never can recover those things. So our request to everybody and all steel manufacturers here also, so please keep each slag separately, and which we are actually as a part of the services always given importance. So once we are in the separated the slags, and this is generic process, which we all know that it goes through a normal process of cooling and then metal separations, which metal goes to the SMS and the rest of the non-metallic circuit goes through further processing. Now here, I will go back to the first step, and where we are now done little bit work on that, and a technology which is called Steambox has been introduced. Why it is so? Because you know that the slag which has been coming as a non-metallic slag, it's always been a problematic having a high expansivity and the free lime content. And when we are talking about the slag utilization as in this byproduct, or it's a utilization for the further development, we need to really process the slag carefully and to address the issues of the expansivity and free lime. So we introduced this Steambox technology, where we are cooling the slag in a controlled manner, having your rapid quenching system with the steam, where we are maintaining the size of the slag within mostly almost 60 to 70% to the range of 60 millimeter to 70 millimeter, and the expansivity is almost coming down by 40% from the incoming slag expansivity characteristics. So when we are going to the, after the MRP, when we are reaching really on the non-metallic slag, we have the liberty to check that if the slag expansivity is less than the recommended value of 2%, this slag straight away can go to the market for its commercial use. But if it is not, then we have to adapt either to the natural weathering or a little faster process, which is called steam weathering. Natural weathering, as our previous speaker also told, it's now a real challenge because the land acquisition is a problem. Maintaining the whole infrastructure is an issue because of the pipeline, because of the regular, the water sprinkling, the maintaining the a pond. All other over and above the environmentalists are now again, it's this activity. All the nearing villages are creating huge objections to set up a natural weathering facility. So the advancement has happened. Tata has taken steps. They are doing the steam weathering also. We are associated with them in Kalinganagar also. And once this slag is done, then this slag is fit for commercial use and we are taking it. HARSCO since last 30 years has opened a separate division for that, who are taking care slag as a commercial value, slag as a product, and which we are giving in a various forms. And over the years, what we did actually, when we separated the slag metal of the very high quality to the tune of 96, 98% purity level, where we are giving it back to the system. We have also removed the metallic from the slag to the tune of 0.5%, so that the slag is ready for the further uses, either in case of road applications, either in case of as an asphalt. Just I am happy to tell you that HARSCO has got a plant in UK where we have almost laid a 1500 kilometer road, and we have a dedicated unit of asphalt plant. We are using conditioner in agriculture. We are making paver block. We have a sea defense and dike application as a filter media for acidic water treatment, and relay ballast, because HARSCO has a rail division separately. So we have the opportunity to use it, test it, and implement it, and we have done it. But one point Mr. Kumar was discussing last day, and I want to just give you a small touch on that, sir, that as of the slag in the agriculture, we had actually taken this initiative with our AOD slag in Jaspur, and we got associated with University of Agriculture, Bangalore, along with Odisha University, where the main objective was to use the calcium silicate to, along with say rice hull ash, both baked together and used in 10 agro climate zone in Karnataka, which we had chosen Mandya being a almost a southern dry zone, and we had chosen Brahmavara, which was coastal zone, and we applied there, and the reports are available with us. It was an excellent growth in crop we found. It was really encouraging. But as all our panelists knows that the basic problem in the application of this is hexavalent chromium. Hexavalent chromium, the recommended level is 55. Now, in our, it is written that it's in place of hexavalent chromium, it is written total chromium. Now, I just wanted to tell you that it's not the total chromium. Total chromium in India limited of 1500, even in US, it is 5000. It is 55 is the hexavalent chromium, and that need to be corrected. I hope the policymakers are trying to do that, this, if they bring these changes, the days are not far away that when even the calcium silicate will get a greater applications from the steel plant, mainly now AOD slags in down below, also the other slags can be tested for these agricultural applications. Coming down to the other product we are talking about, yesterday there was a lot of discussions on the different kind of waste generated at various levels, in blast furnace area, converted area, LD, as well as a rolling mill sectors. So we all are we understood the kind of waste generated at various level. What is important, and I think all the panelists is focusing that, what is the waste are generated and what is the best use out of it. So when we are getting the sludge, we are actually analyzing that what is the sludge, is it sludge, is it BF sludge, what are the kind of Fe content, total Fe content is there, and what could be the best utilization for this. So what we did over the times, and probably we are the only now in the company who has successfully installed a plant in for JSW in Bellary, where we are taking all the waste material, which includes sludge. Sources are various level, and like SMS, we are getting the pond sludge, we are getting the Corex sludge as well, backfilter dust, and we are getting the backfilter dust out of it, lime dolo fines, and also the coke dust. We're mixing it and we are making the micro pellets. Now, micro pellets, it's a very good product which have been already established in our Indian industry. I don't want to elaborate on that. Yes, we are using 4 to 5% in the BECS mix. It has reduced the stack emission level, because earlier the fine particle was being sucked by ESP. Now it's not happening. So we are actually reduced from 250 mg to 100 mg level. We have actually started byproduct utilization to the tune of 70 kg per ton. And we are also using CDQ almost 2%, which was difficult to handle. So this is the kind of advantage happening, and we all know that benefits of micro pellets, because micro pellets with a high CaO form a compound which is CaO, FeOCSO3, and eutectic melting point goes around 1230, and in the first place, when it is in the bath, it melts quickly and it helps us in the refining process. So this is a real product which is really helping the Indian industry. We have set up a plant in JSW Bellary, and where the capacity is 6 lakh ton, but now we are producing 750,000 tons of micro pellets, and these micro pellets having enough strength to take a sufficient falls, and it's a CCS also is very good, and it's got a very good application. It's never been segregated into fines, and it never been sucked out on the by the ESP. It broken into 1 or 2 pieces during the fall. We found it is the CCS goes around 10-12 kg, but it's never been properly checked. It's sometime it's been checked, but it's not the always we are checking. But this is a good applications in case of sinter plate we are using in JSW Bellary, and as Mr. Saxena told, we are also making our best effort to provide our services in RINL also, where we can probably set up a plant if we are successful there. Coming to similar application in case of briquetting. Briquetting, we are focusing on using the more total Fe content wastes, which is mill scale. We are taking mill scale, we are taking backfilter dust, lime fines, and then we are using organic binders like molasses and hydrated lime, and we are converted into mill scale briquettes. And here we found a good example when we found that when we are using the mill scale versus ESP 1:4 ratio, we found that the sloping is actually changing from high to medium. And also we found that if we are making around 25% ESP dust and for 25% sludge, 45% mill scale in the recipe, we are getting a briquette which can substitute this to 2:1 level, like the scrap being when we are using 2.2 tons of briquette in place of 1.1 ton scrap. So it is replacing 2:1 level. And that is one of the great that when we are replacing the scrap, and the molten ratio also increase, means I mean molten ratio means hot metal by the scrap, that also increase in this usage of the briquettes. So we have set up the briquette plant in JSW Dolvi. So Bellary, we are producing 2 lakh tons of briquettes, but now we have reached 2,50,000, and we are also taking the DRI funds to make the DRI briquettes there as well. Now, what is the other point we want to discuss? I think a lot of speakers already talked about is that alumina killed ladle furnace slags. These alumina killed ladle furnace slags, when segregated and processed in a controlled manner, produce a low melting point product, and it can be used as a base material for briquette products. Advantage is that, what we used to do earlier, we used to use fluorspar calcium chloride, which is actually helping to fluidize the slag. But the problem was it was very abrasive. It was really affecting the LD refractories. So then we can check Tex calcium aluminate, which is nothing but synthetic slag. But it's very expensive, 22,000 rupees per ton. Then we found this AKLF slag is very, very effective into this one. It is a low melting point. It has got L2O3 combined with CaO. So provide an ideal calcium aluminate base, and it has a low CiO2. So it gives a very good in the steel making process and fluidizing the slag. It helps in fluidizing the slag and having the low melting point. At the initial stage, it melts out. So this is the great advantage of LF briquette. And LF briquette also, I won't say the substitute the aluminum fluorspar 100%, because it is also depend on the percentage of CaO, but it really reduces the content of aluminum and consumption of fluorspar. Not only it replaces the expensive synthetic briquettes, and it also increases the desulfurization rate. I mean the incoming sulfur minus outgoing, or rather I would say incoming LOP minus outgoing LD by incoming LOP ratio, that's effects. And also it increases the refractory life. It reduces the power consumption as well. So because of the low temperature also, there is less power consumption required. So under these circumstances, it's really a very good product and a very good substitute. It has brought down the cost of the production, mainly the cost of the synthetic briquettes, which is 20,000 or 22,000 per ton, to the drastic level. Harsco is the only manufacturer of this LF briquette plant. We have installed already this plant in ArcelorMittal, US Steel, Nucor, and BlueScope, even in Tata Steel Europe. But now we are setting up 2 LF briquette plants. One is JSW Dolvi, another is JSW Bellary. JSW Bellary installation has already started. JSW Dolvi will come soon. Now, next is what we are doing is the back filter and ESP dust. That is also this application wise. We are collecting this dust. Main challenge is that handling of this dust. So the correct management, as we told, it's a bubble tankers which are really being required pneumatically conveying into silos, so that the dust can be taken care of properly. And then we are utilizing it into micro pallet and also sinter base. We are also using briquettes for this ESP dust and the back filter dust. ESP dust, and when we're talking about the back filter dust and ESP dust, because they are having a high FeO and carbon content, along with the moderate silicon dioxide. So always it's helpful for making micro pallets or briquettes to the tune of, when we have a requirement of say 40 to 50% of iron in the micropallet requirement. We have done this BSP dust in JSW Steel, Bellary, and ArcelorMittal Dunkirk, and US Steel Chicago as well. We are talking about then Corex sludge. This Corex sludge is this sludge being taken care of for the briquetting, and here the mode of handling is open tankers, and we have done this briquetting and the dewatering also, because effective dewatering is important in case of BF sludge and Corex sludge. And in this case, I will tell you a lot of discussion was happening how to remove. We know that in Corex sludge there are some zinc present over there, and there are discussion was that how the zinc being removed. We didn't have much options available to remove the zinc, but yes, there is a opportunity to introduce something there at the plant end. We introducing a hydrocyclone. One is the dewatered slime or the sludge is being taken in the hydrocyclone. The low content zinc and the high content zinc getting separated, and from there we can reduce the zinc content. But we can't say that it's a complete cure, because it's a pyrometallurgy basically, and it's an expensive process to remove the zinc. So we can reduce the zinc content, but we cannot get rid of it completely. Now, another point is that mill scale. A mill scale, when we're talking about the mill scale whose contents of iron is around 70%, and having, this mill scale is really giving us a great content to make a briquetted product, because it's consisting of mixed iron oxide. Three type of iron oxides are available, and this mill scale can be briquetted, which we are doing in case of JSW Bellary. 70 up to 75% of briquetting is done, and it's been added with the binders, organic binders, and it's been associated with other waste as well. And then we are using it for mill scale briquetting, and which has been proven in JSW Bellary in India, and we have done it in ArcelorMittal and US Steel. And now we are glad to tell that almost all the mill scales we can consume and can make in steel industry. We don't have to really use the mill scale in other area. We can briquette it, and we can create a more value for this. Another area is that oily mill sludge processing. This oily mill sludge processing we are doing, where oily mill scale and sludge produced in the rolling mills are hazardous, and it's hazardous for the landfill. So successful adoption of a technology developed for the oil industry, and HARSCO can process this material in a steel mill environment. What we are actually doing, we are separating the mill scale oil and water out of oily mill. And then we are sending mill scale for briquetting, and the oil which is recovered is sellable. So we have set up a plant where we are doing the direct heat through rotary kilns or modular plant technology. We can process the oil up to 30% content, and we are separating the clean mill scale, clean water, and oil. We are sending oil for resale, clean water sent back to the plant, clean mill scale is used for the briquette manufacturing. So it has got a proven commercial scale, and this is the main landfilling, the pain points had been addressed through this oil water separation. The next part is Performix. It's a other form of LF briquetting kind of things. This is a calcium aluminate in an expensive material for steel makers. So what we could find out that a blending together quantity of refractory brick and recycled ladle slag. Recycled ladle slag and refractory brick all blending together has shown up produce a good quality of calcium aluminate type material, and which can be used. And this is best fluidizing agent we have seen in place, where the BF briquette, LF briquette is also a very useful product. This is also a very good product. We are operating quite a long time Europe and Asia, USA for this Performix. And another product which I am talking about is a Plasminox. Plasminox, we are operating these things. Actually, Testronic company is there who is using the DCR furnace, and we are using this DCR furnace to actually handle the stainless steel byproducts, and which has been processed to recover the valuable nickel and chromium component. We are processing and you are recovering almost 90% chromium, 90%, 97% nickel, and 95% Fe. We are operating these things in Italy for a long time, almost more than 10 to 15 years. And we are we are trying to get this kind of application elsewhere. We can discuss these things if somebody is interested offline. We can elaborate our technology on the Plasminox as well. So this is our deliberation on what we are doing at this moment of time with the waste management. Our services, we are giving complete cycle except the last 2 to 3 products like Plasminox and others. We are not giving services in India, but we can bring it here. Other than that, we are giving the complete value chain here, right from taking the slag from the under furnace, hot red hot slag. In JSW, we are doing the under furnace digging, taking the slags out. We are doing the slag management. We are doing this through the steam box. We are controlling the slags expansivity. We are doing metal recovery. We are upgrading the metals, which was minus 6 mm metals, which was actually been thrown out. Now we are upgrading it, having a commercial value. We are using it in briquetting. We are processing the stainless steel slag. We are also making the all melts of services, because melts of services, effective melts of services is really a matter, because they are the source of waste material as well. We are doing the briquetting. We are doing micropalletizing. And what hot topics which has been discussed today is the scrap management. We have not yet started in India, but yes, we are doing the scrap management elsewhere, and we are engaged in various European plants. We are handling the finished product. And the most important part, which is now we are focusing, is the slag cells. We are actually engaged with, even right at the beginning, since 2011, we are in close associated with CRRI. We are the only other company apart from Tata Steel who has been accredited by Indian Road Congress for using our BOF slag. And we have been associated with CRRI to test our slag, first slag from Dolvi as well. And it was given a very good result. And we are always in this particular, we are always been, engaged into this particular discussion, because we are very much associated with that. Last 3 years, our various senior executives came here in India, like Nick Jones and others who've been associated with CRRI in discussion and developing these things, the slag as a commercial use. So we are also engaged with the different kind of agreement with Tata Steel for finding a solution for the slag cells for them. We are also planning to set up few facilities where we can develop the slag products, which can be sold in various industries, not in steel, but also in aluminum industry as well. So this is our, effort, and I hope that we will be in a position to do that, because slag is not a waste, it's a part of circular economy, we all know, and we have to gear up, because next 10 years time, it will be 40 to 50 million tons of slag. Each BOF slag, LST is producing 150 kg of slag. So various area where LD or slag is coming out, similarly BOF, Codex slags, and it has to manage somebody somewhere. Otherwise, it will be, the space will be a constraint, the environment issue will be a constraint for us, and moreover, the cost associated with that. You probably all know, we are present across the globe. We have a 4th division, EMA, Americas, Asia Pacific, and India. India is a single zone because of the importance given to India. India is a standalone, territory. Otherwise, others have multiple countries. As Maro Kuri told, that we are environmental, HARSCO Environmental has 3 divisions, HARSCO Environmental, Rail Division, as well as Clean Earth. We are a $1 billion group, whereas HARSCO Corporation is $2 billion. We have a 33 in country, 150 operations. We are almost 10,000 employee, and we are listed in New York Stock Exchange. We are present in India, in Kalinganagar, in Jajpur, in JSL Jajpur, Visa, JSW Steel Bulari, JSW Dolvi. We were present in Tata BSL also. Our contract ends with Tata BSL, and we are trying to continue some other contract with Tata BSL as well. So this is about Harsco, and we are really honored to get the opportunity to describe our what are the services we are providing to Indian steel industry. Thank you.
Thank you, Abhijit. This is really an excellent presentation and very, very detailed presentation you have made. And it was very, very informative, although a lot of questions were there. So I will just take few questions from you if you permit. One thing you have mentioned that PlasmiNOx technology you have developed. Can it be used for treatment of SS slag?
Sir, you are absolutely right. I am going back to the PlasmiNOx, and I will. It is you are talking about SS slag, right?
Yeah, stainless steel industry.
Yes, sir.
Because stainless steel industry is facing a tough problem of treatment of this thing, slag and other things. So can it be?
Actually, we are doing, sir. Actually, we are doing the stainless steel operation. Actually, byproduct from stainless steel operation can be processed to recover this nickel and chromium component. And in Italy, Terni, we are actually serving the stainless steel companies for last 15 years. So it is made for stainless steel companies. So we can do that.
Okay, thank you very much. And second thing was regarding this use of slag in agriculture. You have told you have tried in Karnataka also, as well as in eastern states also.
Yes, sir.
It was for some Indian company?
Yes, sir. Actually, slag collected from JSL Jajpur, and this was, I will show you, sir. This was being done under the supervision of Dr. N.B. Prakash, from Associate Professor of Department of Social Science, and it was done in 2011. So we have given the slag from JSL. It was been applied in Karnataka, Mandya, as well as Brahmavara, and this was for 10 agroclimate zone. And reports are with us. It was really good report. Very, very good crop yield has happened. And you know, sir, I don't have to say, you are sitting on a decision-making place. You know what is the difficulty now we are facing with that total chromium versus hexavalent chromium. Somebody, I don't know, somebody has to take an initiative to correct this one. If it is get corrected, I think it is ready for use. And we are doing same business in USA, sir. We have a complete business unit in USA who are handling this agricultural part, and it's contributing almost 10 to 12% of our revenue as a this slag as an agricultural aid in US. So we are doing that, and because we in US also total chromium written as 5,000, whereas in India total chromium level is 1,500 allowed, but unfortunately somebody has mingled with total chromium and hexavalent chromium. That's why we are in a little bit issues. Maybe this can be corrected and can be utilized.
I think just I wanted to inform you that because Ministry of Steel has already started this project, and whatever you have told, that is very, very right point. And we those agriculture university also has identified that only hexavalent should be considered and not the total chromium. And I will appreciate if this report, whatever is you are having, because Ministry of Steel has taken a special initiative in using this BOF slag into the agriculture area. So I think your past work can be utilized to expedite use of blast furnace, this thing BOF slag into the agriculture. In case you can say,
it will be our pleasure, sir. It will be our
your
pleasure.
Your report is not confidential.
Definitely we will do, because we actually, as a part of, you told that R&D is required, sir. Actually, Harsco invested money. In fact, Harsco is doing a lot of R&D. I would take that opportunity. We have been always interested, and we actually got associated with IMMT and CRRI also. And we always said, whatever support is required, whatever development is required, we are there. We are giving you all support, whatever you need. In fact, sir, we are also working in water area. Water is one of the major area where focus has to be shifted, where this is our next area, that in India, we will be setting up a water treatment plant with a different kind of technologies are available, something called nanotechnology, which we are also adopting, and we are going to make it that whatever our responsibility, one of the major responsibility is to bring back the water we have polluted, because we are polluting millions of gallons of water through cooling. And that is our social responsibility to send it back to the plant. And we will be doing very soon, sir.
Because Ministry of Steel also has given water filtration as one of the priority, and this job is being coordinated by Simfer, Dhanbad. And whereas the agriculture use is being coordinated by Indian Agriculture Research Institute, and nodal agency is Pusa Institute. So I think your all the work, it will be very, very useful. And HARSCO may like to be associated with those type of research also. So we will share all the detail of the line. Thank you very much. Some questions have come from the attendees also. One question has come from Dr. Kishore Chena. He is asking what is the approximate cost of steam box weathering of LD slag? How does it compare with other ways of weathering?
Well, sir, actually, I would say if we go for the part ton basis, at this moment of time, it depends that what facility we are setting up. If I answered the question, there are the civil cost associated with that, and not much more, and there are mechanical equipment. So we, at this moment of time, when it is somewhere, it is coming around 200 rupees, somewhere around 210 rupees per ton, and also somewhere going around 150 rupees. So this cost is directly related to the volume of slag production we are handling. If you are handling 10 million ton and the production is slag production is around say 1.2 million, it has got a rate. When we are going for handling 15 million ton and having a slag content of 2.1 million, rates goes down around 40%, because it is a volume of slag.
Sabyasachi, you would like to add further something?
Yeah.
Sabyasachi?
Hello.
Sabyasachi, would you like to add something in this thing?
No, not right now. I think I would leave it up to Avijit for that. But I think there is another question that I would like to listen from him, and that's from Mr. Patra, because that's very close to my heart as well. So
before taking Patra point, I'm just taking another point also. Avijit,
sure.
Because you are working in JSW, so in JSW, are you facing any problem in handling sludge also? Are you in a position to use sludge completely? Because one question has been raised, there are certain issues about use of sludge in JSW Bellary plant.
Sir, I am telling you, we are handling the sludge here, all the sludges in JSW Bellary. And if I have shown you that what are the things we are doing in case of JSW Bellary, this is the, look at this one, sir. We are taking all the sludge, correct? Your LP mill, pond, DRI sludge, all the sludge, in fact, BF sludge and LD sludge we are using in Bellary, and we are already converting up micro pallets. So there is no problems of handling the sludge. Only the point is, sir, which we are also talking to Tata BSL also, that sludge has got a moisture. And that sludge moisture should be limited to 20%. If we are having a sludge moisture of 20%, we are okay. We can handle the sludge for micropalletizing. But if we are, or also if we have a sludge, the moisture content can be limited, then it is easy for us. Actually, sir, when we are giving the micro pallets, when the micro pallet size is limited to 6 to 8 millimeters, there is some moisture also associated with micro pallets, which goes around 10%. But that is okay for so during the dispatch also, we control the moisture percentage around 10%. But incoming moisture should be limited to that level. But we are handling almost all the ponds, and as I told you, the sludge handling we are handling properly, and that's why I mentioned how the handling procedure are there when we are handling the microfines, when we are handling the sludge each of them has to be taken care, use the proper handling and transporting equipment, because each transport equipment will contribute to your environment. Because if you can't really protect this transportation, you can't operate the plant. Everybody is standing on the road and finding, if you are dropping a single droplet on the road, next day somebody will stop your vehicle and say, no sir, you are polluting this one. It's a very interesting and very detrimental topic. So sir, anybody and everybody can go against you if you violate any particular norm. So we have to be very careful, and we do that, sir.
Okay. One more question has come from Mr. Patra, that while doing scrap management, how do you classify different type of grade of scrap for more effective utilization? Because you know that there are some ISRI guidelines are there, and but as far as other standards is there, I think I don't know whether any country is having standards or BIS, like BIS or anything for scrap management, scrap classification.
Right. When I, with all due respect, I would say I have limited knowledge on the scrap management because I am not doing in India. But when I'm talking to, visiting my plants in Port Albert and Cardiff and talking to this, there is a, they classify the kind of like sir, they first look at that where from the source is coming. If it is coming from the automobile, or if it is coming from the ship, or if it is coming from the local market is that, you know sir, that there is a huge scrap generation in the what I say, the consumer durables. That consumer durables has huge scrap also. That has a separate grade, and automobile has a separate grade. The source has been identified by the plant manufacturer, steel plant owner, and they give us the indication that this is the kind of source is coming through this ships. So there is a grade, there is a norms. Accordingly, the scrap are separated, they are shredded, some of them are baled out, mixed in a cube, and then they are being charged, and some of them are properly shared, and then this has been made in a cubical forms or in a small ball forms, and then it has been charged. So this has been there. Separation process are standardized, and I can share these things what has been followed in Tata Port Talbot in our plant, or Tata Cardiff.
Thank you, Abhijit ji, because there are so many questions, but due to paucity of time, I may not be able to take those questions now, because other speakers are
we can respond.
And only my request will be, because if you can go through the Q&A portal and just go through the questions what people have raised, and if you can answer those questions.
Sure, sir. I will do that. Thank you
Thank
very
you
much.
very much.
Mukesh Kumar ji.
Yeah.
Mukesh Kumar ji.
Yeah, yes, sir. Yes, sir.
May I induct myself and make a minute, worth a minute comment?
Sure.
So
sure.
Avijit and others who are in the processing industry for steel, please recognize the need for segregating scrap. And the segregation of scrap should not be by the way it is defined is in ISRI right now. A change, a revolution needs to come in, and scrap must be decided by the end use of the steel. If that does not happen, then the recycling portion of the industry would be extremely challenged. And as Mr. Sharma said, he rightly said that 1.8 billion tons of scrap would come back. So we would be challenged to handle that scrap, and we would start seeing mountains of scrap lying around not getting used. And as the economy starts, or the overall industry starts going towards renewables and recyclables, and carbon footprint becomes a major issue, which is already now, and tax is levied on the carbon dioxide emissions, scrap processing must take precedence. So in my opinion, think about scrap processing in terms of chemistry. So by the chemical content, because there are two different types of elements. One is oxidizing in nature and one is not oxidizing in nature. That means there are certain elements which you cannot remove from steel, and the solution to pollution is by dilution. And we do dilute with virgin iron metallics, and that's a challenge. Okay, thank you.
Thank you, Sabyasachi. And now let me go to the next speaker. Rasmiji is waiting for quite some time. we are already running late by around 1 hour. So my request to all the panelists will be if they can adhere to the time of 10 minutes and in their presentations, that 8 minutes for the presentation and 2 minutes for the question and answer. And sorry for the delay, which is going on for about an hour presently. And we will try to just make up this loss of time. Rasmiji, now the floor is up to you, Jay. And everybody is waiting to listen to you because this is a very, very innovative idea you have brought in. And I think this everybody will be interested to know how you are doing that thing.
Thank you, sir. It's been a really interesting evening for me because this is all new to me, and it's been a great learning experience to be on this panel today. So I'll start by sharing my screen. Are you able to hear me clearly?
Yeah. And we can see your screen also. Yeah.
Okay, fine. All right, just a second. Okay. So good evening, everyone. Thank you, Mukherjee sir and Sabyasachi sir for the wonderful introduction earlier this evening. I'm thrilled to be speaking here today. Before I begin, I'd like to thank Dr. Arghya Majumdar, Mukherjee sir and his team for having me on this panel, for the support and encouragement, and also to introduce a platform for different stakeholders of society like researchers, scientists, industrialists, designers to have this dialogue. And so it is an absolute honor for me to be speaking today on this prestigious panel. To give you a brief introduction about my background, I'm a designer and an architect, and I've recently graduated from my master's program during this pandemic from the Royal College of Art, London, and I have done my bachelor's in architecture from BMS College of Engineering. My professional practice today has been, sorry, are you able to see my screen or my note?
Yeah.
You can see my screen, right?
Yes.
Okay. My professional practice today has been shaped by various designers and architects that I've worked for in the past. From architecture to product design, a common thread has always been the relationship between materials, craftsmanship, and the needs of our environment. Let me start by giving you a little context about my project DROS. Due to COVID-19, I had to return to India whilst continuing my master's program online. And because of the way that I work, I learned through making. So I began to look around my ecosystem to make something. And so I started researching the steel factory that is run by my family and looked at the waste material that it produces. We are all here today because we understand the urgency of the amount of waste material generated by the steel industry that goes into landfills. And I took up the challenge of innovating with this waste to convert an expense into revenue for the company. I started my research into two materials, steel slag from an induction furnace and waste ramming mass or quartz powder from the furnace lining. The COVID-19 crisis was crucial to this project as it made me realize the value of resources around me, the scrap metal, the workforce, energy resource, the labors, and so on. As a designer, I had very limited knowledge of the properties of steel slag, so I went with its common application, mixing it with cement. My initial trials involved attempts to make hand-pressed cement tiles with slag, but I soon realized that there was more to this material than just an aggregate for cement. I expanded my research into different industrial processes and began to look at using slag as a mold to cast metal, sand casting using slag sand beds, casting hot slag directly from the furnace, and so on. But then I delved deeper into the factory's process. I looked closely by observing the induction furnace and how the induction furnace is lined with quartz. The quartz, when it is rammed into the material, it is sintered and it forms a solid surface. So I took the same process and I did exactly that in my project on a smaller scale. I looked for steel waste from the scrapyard to create molds, anything that I could find, waste pipes, cylinder tops, cans, etc. And rammed the mixture of slag and quartz waste material in, heated it with hot slag. I let it sinter and then demolded the object. This was the first initial prototype, the early prototypes that I got from this process. And so I decided to take it one scale higher to try a basic table with 4 legs from the scraps of a bicycle, waste steel rods, flats, angles, whatever was there in the steel factory. I'll just play a quick video to show the process. with this first prototype, we quickly realized that we needed a better mixing ratio of the materials, a uniform baking method, and some flexible modular molds to achieve a finer product. At this point, the laborers in the factory also started getting quite curious and involved in the process. So it became this wonderful collaboration between us. And with their innate knowledge about the material and the factory processes, we came up with new mixing ratios, modular clamps. And every day after the factory shut down, we started utilizing the residual heat from the rolling mill kiln, as it provided a suitable temperature to sinter the mixture. Instantly, we saw some improvements. Even the aesthetics and the design of the objects we were making were a reflection of the waste pieces from the scrap pile, an old round tin box, a lunch box, a discarded window frame, and so on. These started influencing the way that the product was looking. And this was our first successful product. With this product, we tried to experiment a little bit with the design, various accent techniques like cutting, engraving, double layers for materials. But the height of the kiln started becoming a limitation. And so with the next product, we tried something different. A sketch video of the same. So we're ramming the material in with the rebars to strengthen the object. We put the modular molds, we ram the material in, and then we bake it in the kiln. And then we put that again, we make a new mold, add it to the existing object, and then reheat it with the residual heat. So this was the final product of this process. And with this process, we got a new height in the project, because earlier it was only small materials and smaller height products. With this product, we were able to achieve a higher height product. A few more examples in this range of furniture that we made. With this collection, you will see that I've also tried to experiment with just steel profiles, waist profiles to add to the furniture, because it was adding to the weight. So we decided to lighten the object by adding just tubes and plates to strengthen the object. We also tried to experiment with tiles and blocks and bricks. Sorry. Yeah, we also tried to experiment with blocks and bricks, and then other collections in the same process. I believe that this project is just the beginning of what we can experiment with these waste materials, whether it is by introducing it in architectural elements, fusing traditional crafts with it, metal inlay work, and so on. And then we can create a business enterprise with this. As a designer doing a university project, I had very limited time and knowledge of the capabilities of this material. But now I plan to take this forward to collaborate with technical experts to improve on this process and make it commercially viable. I'd like to finish off by playing a quick trailer video of this entire project. Thank you so much.
So this is really a lady of substance, I must say. And I also acknowledge the inclusion of Rashmi here, courtesy Dr. Orgo Majumdar. So thanks, Orgo, for bringing Rashmi to this platform. Thank you.
Precisely, this is what I wanted to ask Orgo. Where did you get this great talent? So in a way, UK's loss was our gain. The fact that London lost Rashmi. It was a gain for India that she came back to her roots.
Thank you, sir.
Where else would you have got such excellent experimentation to come out with a successful story at the end of the day? Subrata, would you like to comment on Rashmi's effort and initiatives that she has taken?
She has shown how art can convert itself to a real life use. And she has graduated from one of the topmost Royal College of Art, London, where the art, starting with art, her specialization, using the waste, converting into usable things. Wonderful. Nothing more to say. Using the technology of induction furnace, ramming, and putting into an action in making those items. Good. Very good.
So I have a question. Yes, please.
This is purely a metallurgical process she has been using, because the metallurgical process mixed with art has given us the aesthetic part of it. And most importantly, she is going to improvise it through her experience of making tiles. And I think Rashmi, you will be sharing your idea where this tiles idea can be put it onto this, and glue things can be coming, and so that it gives the aesthetic, more aesthetic to it. I think Rashmi will be sharing that.
Yes.
Shobhita, before you put in your comments, I have just one question to you and Argota both. How can you best, utilize such creativity by commercializing it, and how can we promote her in doing that? Maybe Dr. Mukesh Kumar would also have an answer. How could we commercialize her talent? Shobhita, first your answer to this.
So if you want me to answer, so first of all, I don't know what kind of business model Rashmi has been able to develop so far, or responses from the industry itself. I feel that couple of things obviously would need to be answered in terms of whether it has got any effect on the human body by using such material. So is it environmentally friendly? There are other implications of not using slag in the human life. So that's why it has been getting discarded. But what you have done is brilliant, and I think if it is proven, so if you have already done it, fantastic. If you have not done it, that's what I would focus on, that it is usable in human life normally. I am sure that the longevity would be another factor that you can impress upon, that whether it is crush resistance or heat resistance, breakability, fragility. So whether it's fragile or not, because that's another thing. Aesthetics. The other thing is about joining pieces, like Orgo was talking about tiles, right? So if you are going to build tiles, whether they can be grooved instead of glued, so joint interconnected rather than glued, because gluing is another problem. Because when you try to replace it, if it is grooved, you can easily replace it. But if it is glued, then you have to change a bigger area. So things like that of nature. But commercially, I see potential. Rashmi, don't give it up. And please stay in touch. I would love to stay in touch with you and track the progress, and need any point of time, if I can contribute in any sort, I would love to do it.
Yes, so definitely. I think that's some amazing points that you've raised. I have been thinking about all of these that you have mentioned. I think starting in the first is the toxicity of the material. This is something that I want to research with scientists and experts as to how much this can be pushed as commercial, as a household material. My immediate precedence was that it's been used in concrete blocks and people handle it with hands. So at this point, it's not as toxic, but I want to explore this further and see how it can go. I also want to experiment with ceramic glazes, and to see if that can coat that material to make it more, usable and worker friendly, like more smoother worktops and things like that. And yeah, definitely about the tiles, it's a great point to see about how the edges can work and how they work together. So that's something that I really want to develop on in the future. And it'd be great to collaborate with anyone, everyone, whoever.
Yes. Please feel free. The other thing that you can think about, and I saw those people having tea on the table, outdoor furniture. Because the outdoor furniture, as India progresses to generate more opportunities for national park, reserved areas, and because if you have seen UK and similarly in US, there are a lot of parks that are maintained, developed, nurtured by the government. Those outdoor recreation is a big thing here. Similarly, in India, if those outdoor recreation comes of age, these kind of opportunities that you are creating with your innovation would be fantastic, because we don't necessarily have to use wood. Wood furniture should be replaced by this kind of material, and also plastic, because the other option is to put plastic in or metal. So instead of that, if we can use this kind of material and use this kind of furniture, it would be very eco-friendly.
Yes, so definitely.
In fact, Shobhasachida, I have given the same idea to her. I was talking to her in that let us take a project of this. This can be taken into real estate industry, where a project like this can be implemented and can be seen, and the people will be getting interested to it, and so that in India it can be a real game changer for the real estate industry also. And in fact, with this type of project, if she is using non-toxic things and the scraps, and she is talking about the slags, and if it is non-toxic and it can be used everywhere in India, it can be used as a milestone, aesthetic milestone in the roadways. It can be used in the parks. It can be used in hospitals. It can be everywhere. And this I think will be a game changer. And another thing is, I will request Rashmi to go for a patent of this, so that your idea cannot be taken away by the people. So
absolutely,
this is also a request from my side.
One question, Mr. Majumdar. I think she has definitely tested it. Outdoor application in heavy rain. How does it behave? In water, heavy rain.
So I haven't tested it out in heavy rain yet. I have to test it out. But in terms of strength, it works because we've installed rebars in. So I think I tried, at least 3 people had stood on my table and it didn't break. So yeah.
You find I think one of the things, Nirmalya, that if Rashmi can be brought back, along with some of the people involved in real estate or policy making in parks and recreations. So what I think, Nirmalya, it is getting tremendous opportunity for you to bring together people from different areas into this platform. It would be excellent. And Rashmi would get a good opportunity to, again, pitch for our ideas.
Yeah, I think
taking to Mr. Bandyopadhyay's advice, Ms. Rashmi, actually, have you checked any leaching is happening there? If you put it outside, any kind of, leaching out, if you put it in open, mainly the external atmosphere, when there is a lot of, moistures, a lot of rain, as Mr. Mitra told, that will give you a clear idea for the external use, which Mr. Shobhasachida has advised, because you can check if there is any leaching is there. If not, then it's fantastic. I mean, it can be really applicable in the open park area.
Here, I think it's very important for the panel to understand that she has an innovative idea. She has floated an idea. And I think, I don't know where from she is operating. Maybe the nearest some lab can, or maybe say experts can assist her. Whatever the questions we are asking, whether a metallurgist or a steel person, she's an artist. and she had developed a concept, and we should appreciate it's innovative. And I'm from the field of art, and I myself have been a painter and artist throughout my engineering and also later on. And I have done a lot of work on the scrap various models, scrap steel models and non-ferrous or ferrous models. So I will appreciate what she has done is innovative, and we should help her to commercialize the technology. Thank you.
Thank you, Pawanji. I completely accept and I endorse your views. She does not belong to the field of metallurgy, nor is she let's say from civil engineering, not chemical engineering. So as an artist, it is our duty, our responsibility to see how best we can support her in commercializing this venture. And Dr. Sanjay Kwande, who runs a lab. By the way, Rashmi, which city are you from?
Sir, I live in Hubli, in Karnataka.
Karnataka.
Yeah.
So
Just
Dr.
having
Kwande,
some background, having some background in civil engineering and what we are doing in civil engineering, what everybody suggested to as outdoor furniture, and she is using a rebars. So rebars are bound to corrode, and the issues will start. So, and India is such a diverse nation. There is an environment. We classify in civil engineering environment in different parameters: moderate, severe, extreme, and this kind of things. So the furniture which will be used in maybe Madhya Pradesh will have a different impact. Garden furniture will have a different impact in your Mumbai city or cities coastal region. So a lot of studies can be done in that before we take it out as a full-fledged commercial model. And I think if she wants, we can help in those aspects, because we know the civil structures for a longer time, and I think we can even able to help her into the right mixes also, because porosity is one of the major area which leads to the ingress of moisture into the product. So that has to be monitored into that. So good idea, good concept, but to adaptability and acceptability level, a lot of things need to be done, and we are there to help you out.
Yes, sir, definitely. Thank you so much. I definitely agree with you.
Yeah, so Rashmi will try and see if we can put you across to Dr. Sanjay Kwande or IIMT, who would actually look at the basic characteristics of and the properties.
Yes,
Dr.
sir,
Mukesh
definitely.
Kumar, anything that you want to add, please go ahead with the program, Mukesh Kumar. If you want to add anything or ask anything, otherwise you can go ahead. You have to unmute yourself, Dr. Mukesh Kumar.
Sabyasachi has already advised all the point, and I don't have anything else to comment anything. But our organization is there, Steel Research Technology Mission of India, that is under Ministry of Steel. And in case you need any type of support, so there are a lot of schemes are available on Ministry of Steel website, and you can have a look on that also. So if anything you want to pursue further, so those type of things can be utilized. And I wish you once again all the best, Ji.
Thank
and
you
this
so
is a
much.
very fantastic and creative idea.
Thank you.
Yeah, Rashmi, I'll share Dr. Mukesh Kumar's contact with you.
Yes,
so
sir.
You can keep in touch with Dr. Mukesh Kumar, and since Dr. Mukesh Kumar is, there in the, I would say literally there in the headquarters of the ministry, whatever new projects come up or whenever, such occasion arises where we could give you a platform, Dr. Mukesh Kumar would be happy to do it. So I'll share Dr. Mukesh Kumar's contact with you. With that,
thank you, sir. I really appreciate it, and everybody else's comments and feedback on this panel. It was really nice to be
God
here.
bless, and we are so proud of you.
Thank you.
Thank you. Now we have next speaker, Amit Srivastava from EcoMaster. EcoMaster is very, very well known in iron and steel industry. So they were the first one to come with a new innovative idea of making this thing sandblasting type of granules by using slag. And this plant was put up in JSW also, JSPL also, and they are still working there. So now I request Mr. Amit Srivastava, because they have entered into some other areas also like heat recovery and other things. So let us see, Mr. Amit Srivastava, now floor is yours. Whatever you want to explain about your company and new products, whatever you have brought it out now.
Good evening to everyone. Thank you very much, sir. So nice to see here you, Dr. Mukesh Kumar and Sabyasachi sir, after long time, after 2 years, almost more than 3 years. So I'm happy, and I must congratulate Mr. Nirmala Mukherjee to bring this subject, especially in this time. And really, we have discussed a lot. And we are the company, we are trying to create valuable from the waste, and we are creating. And the most important thing is we are saving energy and water for the country and for our future. So I have our CTO, Dr. Santiago Foche. So I'll take only 2 to 3 minutes, and then I'll hand over to Dr. Santiago. So I'll just share my few slides. Sir, are you able to see my?
Yes.
We can see your slides.
Yeah.
Yeah.
So I'll go in the basic, so what is the utilization scenario in the world? So India, presently, we are using steel slag, reutilization is 20 to 30%. And if you see Japan and South Korea, they are almost in the range of 80 to 100%. So what is our, vision 300 metric ton? So vision 300 metric ton, if we see reality by 2030, we will reach up to 255 million ton production, and where we will generate 31 million ton of slag. So what is the challenges? The other than the biggest challenge is waste management. Okay. So what EcoMaster do? We do the slag atomizing in the steel slag and heat recovery and creating valuable from the waste. So Dr. Santiago will discuss with you in detail what is our technology and how we are better than others in the market. And presently we are operating 11 sites outside the South Korea. We are operating inside the Korea around 11. We are also present in non-ferrous zinc plant. And in India, we are presently working with JSPL Raigad, JSW, JSPL Angul, Monet, and Tata Bhushan. So I will hand over to Dr. Santiago Foche to go for the next.
Thank you very much, Amit. I would just like to verify that everyone can see me and hear me. Amit?
Loud and clear.
Great.
Loud and clear.
Great. So it's lovely to be here with you today. It's a real honor to be part of this global community with you. And I think we are all working towards common goals in terms of improving our society, improving the market, and creating jobs and purpose for people to develop new things which sustain our families and sustain the world that we live in. So I'll share a short presentation, and then we'll take questions from you. So I'll share my screen, and hopefully as I go into presentation mode, I hope that it'll project for you. I have two screens, so give me one moment as I share my screen here. Good. So I am the Chief Technology Officer of EcoMeister in Korea. Amit is a close friend of mine, and I spend a lot of time in India. I counted that before COVID, I had done 14 trips to India over 2 years, each trip being approximately 1 to 2 weeks. So I love the country, and it's lovely to be here with you. My neighbor yesterday gave me some mango chutney just so I could try and maintain my spice tolerance and my taste for Indian food, which I love. So today I'll talk a little bit about waste but energy. And this is actually written on a tower in Korea. And it always stays in my mind, waste but energy. What do they mean? Are they taking waste and burning it? Are they recovering the energy from something that has lots of energy? And it has a double meaning. It's really saying, you know, we shouldn't consider it waste because it's actually energy. And it reminds me of something that my father often tells me, is that we ourselves are basically a transition between matter and energy in our forms. And now we can get into a spiritual discussion on this, but I'll digress and stay with the topic today. Importantly, I'd like you to know that I'm also the CEO of Eco Materials. And as you'll see in this slide, Eco Materials is essentially EcoMeister's and EcoMeister Beads India's sister company that we're establishing in Europe and America to bring the products from India, from Korea, and here I'm talking about slag products, to North America. But to also bring the technology here. So interestingly, Asia is very much ahead of America with respect to the transformation of slags into useful products. EcoMeister has a long history of working on slag, starting back in basically the early 1990s. So we now count 2 decades of technology development focused on the conversion of slags into products. I'm not going to go into all the details of this. This is an entire talk by itself for this slide. But what are we working on? What's the principles of what we're working on? Essentially, we take molten slag and we granulate it in its molten state to produce essentially minerals that are new to this world. These are minerals that volcanoes may have created in ancient times and that Italians may have used to make pozzolanic cements. We are creating them today from these slag products, okay? And these new minerals that are new to the world are stable. They do not have free lime because of the very fast quenching process that we apply to the slag. We produce very hard mineral particles that we don't give time for phase segregation, and so we don't produce free lime. And this makes them very stable from a expansion perspective, but also from the perspective of leaching, which we were just talking about. Rashmi was answering questions around that. And make these materials directly useful in the production of aggregates and cements. What we've worked on so far in the steel sector, and by the way, we do a lot of work in the non-ferrous sector, which produces about as much slag as the steel sector. But today I'll be focusing mostly on the steel sector. So these minerals that we produce, we can make them from steel slag. We can convert BOF slag and electric arc furnace slag into industrial minerals and aggregates. We can take ladle furnace slags. We can convert them into cements, fluxes, and fertilizers. We have 10 years of experience in the use of ladle furnace slags as fertilizers in Korea. And so there's a huge body of data, you know, that exists within EcoMeister, Eco Materials on the use of these materials. We can convert AOD slags into cements. We can stabilize AOD slags without the use of borax. And a few years ago, we won the AIST Best Paper Award just on this subject. We can convert blast furnace slags into cements. Really, the use of atomization and the products that we create is limited only by our imagination. Here's what our imagination has created so far. Blasting abrasives, which you see in the top left-hand corner. Flooring for apartment buildings. What you see here that is patterned into the floor that is black is actually steel slag. And this steel slag is mixed with different organic compounds, polymers, to create these dampening, noise canceling flooring materials. We make railway ties, we make cements, we make bicycle roads. Our slag products are used and certified by the Korean government to be used in children's playgrounds as soil material. We use our slags as water filtration media in industrial, and now we're looking at human consumption water filtration. And we use slags for heavy counterweights. If you walk around in Korea and you look at the ground, you will see our product incorporated in the pavement stones, the pavement style stones and pieces that are paving Korean sidewalks. Okay. I wanted to answer the question on toxicity. We have lots of data sets, but here's one from a North American laboratory where we tested, per our client's request, the stability or the toxicity of our product from atomization against freshwater and saltwater species. I'm only showing here the freshwater species. The saltwater species is exactly the same results. After being exposed to slag in water for 96 hours, there is no mortality of freshwater species. In comparison, if you were to expose these freshwater species to a slag that has not been submitted to atomization, you would get extremely high pHs in the water and you would get mortality of the fish species. Okay, so the use of atomization allows us to stabilize the slag, makes it safe. And that's why we can certify Jindal steel slag, which comes from Bellary, from Bijyanagar, and we can obtain a certification from the California Air Resources Board, and we can get certification from the Society for Surface Protection and Coatings as an abrasive. So we are taking slag, okay, 10,000 kilometers from India into North America. And really what we're doing is educating people right now. We're educating people, we're taking that 20 years of experience and educating people as how we can completely transform this industry and completely transform slag from a waste. I do not believe slag is a waste. Slag is a product. And just like we've seen in the case of blast furnace slag, in the iron making units, where now there's shortages of blast furnace slag, that story took 40 years. From the beginning of the water granulation to today being at a shortage point of having available blast furnace slag. I think that in 20 years, we will have a shortage of steel slag. It will not be a waste. It will be a desired and valuable product. And all of the people here today are working towards this end. We're all part of this story. Every single individual today that gave a presentation, okay, is part of this story. And we're all contributing to this, okay, together. Now I want to switch a little bit and say, we've talked about slag as a product, But actually, there's another part of waste in slag that we need to talk about, and that's the energy that's present in that slag. To put that into perspective, I last night did some rough calculations as to the amount of energy wasted in steel slag per year, and I came with a very conservative estimate of 30 gigawatts of energy per year. That is equivalent to 30 nuclear power plants. To quench this slag in a year requires 400 billion liters of water in 1 year. And each minute that we are talking here today, 1.5 million bottles of water, the equivalent of 1.5 million bottles of water, are being evaporated to cool this slag. In a world where water is in shortage, we really need to think about this and resolve this challenge. And furthermore, we need to recover this energy. We've been working on this. We are the only company in the world that has 2 slag atomization plants that recover energy from slag. And this is now the beginning of the second wave of technology that we're creating. The first wave is with the use of the materials, the ability to transport these materials 10,000 kilometers economically, whereas in the past we could not transport them more than 100 kilometers. Now we're looking at energy recovery. This plant here has actually been operating for 10 years, and the second plant has been operating for 8 years. And it recovers 250,000 tons it recovers the energy from 250,000 tons of slag per year continuously. It's coupled directly to the furnace. And then this energy is then used to dry materials that are wet. Those could be sludges, for example, which were discussed originally, earlier on. Those could be agricultural products. Those could be materials, clothing, whatever the case may be. It could even be used to dry food products. So again here, and this video you might see a little bit, but I don't want to spend too much time on it. Here, it's really up to our imagination as to how can we use this energy. And we're currently working, for example, for one company in Brazil, where we're looking to use this energy to dry wet electric arc furnace dust so that they can recover the zinc from it. It's just one of the many examples of what we can do with this energy. So with that, I will close off. I want to thank you for giving us this opportunity to share our knowledge with you so that we can transform the world together. And I look forward to working with all of you in the decades to come. Thank you very much.
Thank you so much, Mr. Kausha, Dr. Santiago Kausha, and also Amit Srivastava. Both of you were excellent. And, you know, I would say, in addition to the HASCO presentation, this was again a wonderful presentation covering many aspects which Dr. Mukesh Kumar would also perhaps highlight. Let me tell you, we are really impressed with the capabilities of EcoMaster, and you're already present in a big firm like HASCO is. And let us see how best we can work together with EcoMaster. And Amit is a fantastic guy. Let me tell you, your colleague in India, Amit is a fantastic guy. And excellent results. The other day when Mr. Sabyasachi Bandyopadhyay and myself were discussing about Amit and his capabilities, the first thing Sabyasachi mentioned was, oh, I know Amit very well. He's a fantastic guy. So Amit, if you are listening to this, there are a lot of compliments you have from the industry anyway. And I'm sure with your capabilities and that of Dr. Santiago, we are going to move forward in all the solutions that, you know, including, for example, for payments. This is an excellent usage. And as you rightly mentioned, Dr. Santiago, what exactly Dr. Mukesh Kumar mentioned yesterday, that nothing is a waste. A slag is always a resource. It's just that we need the capabilities to handle it. With that, I'll hand over to Dr. Mukesh Kumar for his comments before we move on to the next presentation.
Thank you, Nirmalaji. Santiago, what you have presented, it is really a very, very futuristic thinking, how we should go ahead. But only just one or two questions was coming to my mind. If you permit me, I just want to ask one or two questions. You have such a big experience in granulation of the slag. And what you have told, you have used it through air also, and air you have used for drying also. Why you have not put up any project till now for converting into energy? And suppose we want to take up some projects in India where we want to utilize dry slag granulation and converting into heat, converting into electricity. Whether EcoMaster will be interested in collaborating in such projects.
Yes, Dr. Kumar, you broke up a little bit, but I think I understood your question. Absolutely, we're interested in working on such projects. The world is a big place, and this technology is new in the world, and it's taken us a huge effort to get to where we are here today. The reality is this is what we've shown is really just a tip of the iceberg, and our rate of growth is only limited by the partners who want to work with us. And that's really comes down to education at this point. What I've shown here is futuristic, but actually it's the reality. All of what you see here is actually commercially implemented, has been commercially implemented. So definitely we are interested in producing energy. From a technical perspective, when we look at the production of energy from slag, we have to really look at the capital cost of producing that energy versus another incumbent technology. And therefore, if we take a look at the type of temperatures that we create, which are in the order of 400 to 600 degrees C, it is possible to put a steam boiler on such a heat stream and to produce energy. And I think this will be the future. As steel makers become comfortable to do what has been done in Korea, to couple to their furnace the granulation technology, we will see this. First, I think on blast furnaces. And I believe there's a great opportunity to create the first implementation of blast furnace slag atomization with energy recovery in India. And already we have done some work at full scale with JSW on this topic.
So have you put up any pilot plant or laboratory study to analyze this economic aspects of energy generation through waste gas till now? Or it will be a just conceptual project?
No, I think, we've built 2 full-scale plants for the conversion of slag energy into, or slag heat into calorific energy. It's very easy to then couple that into energy recovery. So we're well past, I think, piloting. I think now we're really talking about demonstration. The first demonstration plant where we take the know-how that we have and we apply it to a blast furnace, which is producing slag almost continuously to recover that energy and put it back into the process.
Thank you, Dr. Santiago. There is one question. There is one question from Mr. Pradeep Patra. Dr. Mukesh Kumar, can I take that question?
Yeah. You can take it. Yes.
Yeah, the question will be taken up by Dr. Santiago or Amit ji. May I request Ankit to just promote Mr. Pradeep Patra so that he can ask the question? Ankit?
Yeah, he is asking, he has given his mail ID and he is asking for heat recovery, details. So we'll
Yeah, but
check.
let him ask the questions. Let's see. Amit ji, 1 minute. Let us ask him. Can you see him?
Yes, I have unmuted him.
So Pradipta, you can ask the question, please.
Good evening to all. My question is that how to retrofit in existing furnace and what can be the payback period utilizing your heat recovery system also.
So if you take a look at, I'm not sure if we're talking about blast furnace or if we're talking about electric arc furnace, but in both cases, we can come off directly from the furnace. We call that online atomization. The image that I showed is from Korea is essentially an online atomization plant where we go directly from the furnace. If we take a look at the payback on a project like this, we are talking about, depending on your cost of energy, paybacks anywhere from 1 to 2 years on a project like this. But then you also have to consider what is the water costing you. So if on a typical blast furnace, you're producing 1 million tons of steel, of pig iron per year, that's a huge amount of water consumption. We're talking about 175,000 tons per year of water loss. So once you start including these factors and the value of the product that you produce, which can be used for cement making, we have actually higher glass contents from our process than with water granulation. I can get into the details of that maybe offline. But once you include all of that, we're looking at fairly quick paybacks.
Okay, thank you.
You're welcome.
Thank you, Mr. Patra.
One last question more I just wanted to ask. Santiago, you have mentioned that you are using PS balls in making railway sleepers also.
Yes, sir.
But in India, have you tried this option in India?
Amit maybe better place to answer this question because I know he had done some work, I believe, on this.
Yeah,
Amit?
we have done something, sir. I will share with you offline.
Okay.
Surely.
Thank you.
Yeah.
But I think there's a great opportunity. We're in Korea. We're producing a lot of railway sleepers this way, and I think it's a great opportunity. And we can bring that knowledge to India, and it's already commercial, and it's commercial on high-speed trains. These trains are operating at 330 to 360 kilometers an hour. So they need those ties to be secure, and they need those ties to be high performing.
Here you are using BOF slag and EAF slag.
Correct.
Santiago, you are using BOF slag and EAF slag both for making rail sleeper.
We are.
Okay. Thank you. Nirmala ji, is there any question is there?
I don't
Please.
think in the Q&A box I see any other question. Ankit, can you see any other question Q&A which needs to be answered?
So there are a few questions, but I think we can, Mr. Santiago can answer them directly in the Q&A. That way we can move on to the next presenter and save time as well.
Dr.
Thank
Mukesh
you very
Kumar,
much.
Thank you, Dr. Santiago Fosher. Thank you, Amit.
Pleasure.
Thank you so much. So, Dr. Mukesh Kumar, now the next presentation is by Dr. Sanjay Kwande.
Dr. Sanjay Kwande, MD CCRT Laboratory. Sanjay ji, floor is yours.
Yeah. Okay, thank you. I'll just take a second. I'll try to share my screen. Okay, so I'm visible as well as audible.
Absolutely.
Hello.
Loud and clear.
Absolutely.
Yeah. Okay. Okay. Great. So we are CCRT Laboratories. It's devoted to refractory industry specifically, and we are serving to almost all refractory consumers like steel, cement, and you name it, petrochemical. We are most of the customer. We are authorized vendor for their refractory requirements and quality testing, and that is how we got interest into all these industries, because to be a service provider, you have to know your customer better, and that is how we entered into understanding their issues, their problems, and where we can come into picture and play some role. And over a period of time, we generated a lot of love for the West. People call it as a West. Now everybody started talking about the raw material. So that is what the passion for us, and we are working in all the areas where we are providing our services, like refractories, refractory waste conversion into other products, construction waste converting into other usable product. So that is how we are working, and that is what our passion is, and that is where we are ready to tie up with the people to take up the things together, because we are doing a lot of private research for many of the organizations. So next is what we consider waste is. It's a time to wake up and attend on priority, make a strategy, work together to save our environment. That is what the definition for us for a West. So it is a hidden message for all of us that it's a time that we have to work on it. Why we should do that basically is a social development needs sustainable development of resources and energy. Previous speaker is already talked about energy and the kind of magnanimous figures he's talked about. That is what we have to work on that. So when any industry like metallurgical industry during its growth period, a lot of things naturally happens. Basically, indiscriminate use of resources, all kind of pollutions are started because of unplanned growth, and then waste generation. So last 2 days we are discussing a lot on steel, and a lot of wastage generated at every stage of steel making, and how those can be converted into usable product or recycled, and many aspects of it. It's all good sign, and I think one day that will give the bigger and better fruits. So we are not just thinking of steel, we are thinking of many other industries where such similar operations are happening and similar kind of wastes are generated, like these major metal industries like steel, copper, aluminum, and all other non-ferrous industry. More or less the operations are same, and the waste products are same, like sludge is there, dust is there, slag is there, then various chemicals wastage which are used in the entire process, and huge amount of water which is getting polluted. So these are the common problems if I try to club them into one category as such. So this is what steel industry we all discussed. So I will not take a single moment on this, because it's well discussed in last 2 days. A lot of good suggestions, a lot of good practicalities came out, and a lot of usage can be trigger further. Similarly, I put up a copper industries manufacturing thing, and at every level, what are the products waste are generated. So how this two more things which came to my mind while listening to the steel waste and conversion is a steel making dust can be safely used in a glassware production, because they act as a dye, molten glass dye. If that, I don't find any reference whether in India they are using it. So that is one the opportunity where steel dust can go as a good commercial product. And oily sludge, somebody has talked about separation of oil and water and that, but it can be safely used in Portland cement clinker manufacturing as a coloring additive, even in concrete. So that is another use of oily sludge as it is. And waste lime can be tried for zinc recovery, because if you see the zinc recovery process, a lot of lime is required. So whatever the waste lime is created in steel, can it not be used in a zinc recovery, so that circulating things or that projects things can be worked out, and two different metal industries can talk to each other and generate those. If any practical or the project to be done, we are open to do those things. because we are also working on a waste line, and we are trying to use waste line in one of our commercial product in construction activity. So we love to have those waste line from any of the steel industry as a sample to us, and then we can check the feasibility of using the same in our special product what we are developing. In alumina, red mud has a lot of issues because of alkalinity, and it cannot be directly used in many of this. But recently, day before yesterday only, Hindalco has signed an agreement with Ultratech, and red mud is going to be used almost 100% in their cement manufacturing. Already more than 15 million tons has been consumed by Ultratech, and I think day before yesterday they have made an agreement, and that is how Hindalco is going to achieve all 100% utilization of red mud. But whatever studies I have done during my masters, I used red mud. In my projects to adsorption of very heavy metals. So it has got a huge potential. If you can see my master thesis, it has a huge potential for red mud to be used as a filtration product for all these heavy metal, and we can make water treatment plants using filter disc out of red mud. That is what my dream was. That is left half over, but I will take up this project if any of the red mud producers can come together. Okay, and the fly ash. The other day, Hindalco chairman, Hindalco person was here, and he talked about the fly ash. We are already working on fly ash from the thermal power plant, and we are converting that fly ash into a fertilizer base. So all the good ingredient which soil is not having can be well spread on this particular fly ash after processing, and they can be stabilized on that, and it can be used as a fertilizer. It has got very high surface area which act as a water retainer. So less amount of water is required in agriculture requirement. And whatever the initial results what we got out of these fly ash fertilizers is that almost 30% growth in the leaf shape and 15% growth in a fruit shape. So that indicates that it works. So a lot of different fly ash waste resources has to be tried in a way. So we are open to take a fly ash samples from steel industry, alumina industry, or many other industry to work whether they can be a good player against this thermal fly ash. Phosphogypsum is already getting used in cement industry, gypsum plaster, and many other applications. So not much waste about phosphogypsum anymore. It is almost getting converted into a usable products. Foundry waste. That is another waste which is generated again. Foundry is a part of metallurgical industry, and a lot of foundry waste is found, and it has got again कहीं जो कहीं नहीं होता है वो कंस्ट्रक्शन इंडस्ट्री में चला जाता है, या रोड बैंकिंग में चला जाता है, या लैंड फिलिंग में चला जाता है. That is a one ideal way everybody has found out, but I am telling from my own experience, there are n number of usage for this particular products in various different industries with much more value addition, with much more, because till now what we are using is nothing but reuse, reduce, and recycle. These are the three concepts we are using right away. We are more focused on that. But we have to understand there is one more concept called repurpose. Repurpose is the thing, is the key where huge amount of value addition can be generated for this waste or a raw materials, what we call. See, just I will give example from pharma background. Like a few years back, metformin is a drug which is known to be used in anti-diabetes, diabetic control. Now the drug is found to be very good, useful to reduce your fats and reduce your body weight. So that is what. So unless you identify the repurpose of it, like hydroquinone was known for a malarial drug, but it is now promoted to use against COVID. So we have to understand any product, any waste doesn't have one limitation. You have to think from that other out of the box. Unless we think and we use not, if you are not use the repurpose mode, a lot of material will get entangled into, and finally they come out of the waste by not utilizing their proper value. So CCRT lab has developed a product called Potomix, a pothole repair material, where these foundry sands are used very effectively. So the roads repair using this foundry sand as one of the component to it, we have found that the heavy trucks with that kind of tangential force and the compressive forces acted on that, and that the heavy rains in Mumbai, they are well protected there for that region. And this particular product gets hardened within 15 minutes. So road repair by a concrete within 15 minutes can be thrown open for traffic. So these kind of wonderful products can be manufactured out of this kind of waste that we call waste, but they are the real precious raw materials for something else and with more value addition. Copper slab is used in making tiles, mine backfills and granular materials. And there are the different process used for recovery was pyrohydrometallurgical techniques. So I'll not talk much about this because these are well-established technologies to recover the things. Even zinc is considered a very hazardous waste, and that is what I was talking about. While recovering the zinc, a lot of waste lime can be utilized during their work. In non-ferrous metal, other metals apart from gold, silver, platinum, these metals are more or less toxic. So we have to work out on them. We have to identify the different techniques to use them. So a lot of research need to be done, not just focus area of steel or this thing. Of course, steel is very important because we have to become a #1 in steel one day. The lot of other uses like uranium, leftover uranium is used in armor and things like that. So things are going on, but somewhere wherever we are doing the landfill is one of the easiest solution. But our request while selecting a landfill, following criteria has to be strictly to be identified or verified, because of leachabilities. A lot of issues are happening in the area where the landfill sites are there. We have to identify the sites, see the permeability, depth of this, depth of water tables, a lot of things. But I think somewhere these some of the parameters are not understood, and then a lot of issues are happening. So best way is to use chemistry. So when we are doing the landfill as one of the items for waste disposable, so a lot of stabilizers can be developed, or complex manufacturing, like one metal can react with other metal and the entire chemistry of them is changed. Like what we did during my thesis of PhD, I worked on a project called low expansion materials. These are materials used in the space because they are very thermally stable. Their RTE, reversible thermal expansion, is less than 2.4 into 10⁻⁻⁶ mm at 1700 degrees centigrade. So such materials are used in space technology, where they're used as a coating for the space shuttle and space mirrors and other things. So why not that material can be used as a nuclear stabilizing material, uranium, which is after using depleted uranium is still radioactive. So if that uranium reacts with this particular material and they form a non-radioactive material. So such out of the box thinking has to be done, and that is what during landfilling also, if my waste or the sludge has these kind of leachable materials, then whether these leachable elements will react with some other complexing material and will form a stable waste. That is what has to be looked out, and a lot of research has to be done in that area. So these are the basic techniques used for pyrometallurgical, hydrometallurgical, physical, and one of the gentlemen has talked about the plasma thing. So these are the good technologies which are evolved. But what we want to promote as a CCRT laboratory, as a research company in this area, is biochemical methods. So a lot of enrichment of non-usable low iron percentage ores can be made usable by biochemical methods. We are working actively on specific bacteria, like you have very high amount of silica in particular ore, and if that is not being usable because of that particular silica, so this bacteria, particularly if you treat, like it's like an yeast, type of bacteria. That bacteria selectively eat away the silica content of it, and the entire silica, almost 0% silica remains after a certain amount of time. So these are interesting concepts, and if people come together, we can work on various other bacterial development, and this bacteria can eat away specific, like somebody wants to remove titania, that titania eating bacteria can be created, and that can remove the entire titania out of it. So these kind of things are possible because we're already working on a silica eating bacteria, and a lot of limestone beneficiation is possible now with that kind of bacterial treatment. So that is what my submission for today. So a lot of research possibilities are available. A lot of out of the box thinking need to be done, and people have to come together, as Santiago also talked about, so we can make this world more better, more usable. The natural resources can be used for more longer time, and we can save huge amount of energy and many other things. Thank you very much for your time and patience for listening. Thank you.
Thank you.
Hello.
Thank you.
I have a question for you, sir.
Yeah.
Can I go ahead, sir?
Yeah, sure. I'm able to hear.
Yes, you have been talking about the bacteria which can eat silica, which can eat alumina, isn't it?
Yeah.
My understanding is okay?
Yeah.
Then
It's just bacteria which is specifically eat that particular oxide element.
In that case, all the slags, whatever we are using in blast furnace slags, the blast furnace slag is mainly having CaO, MgO, and silica and alumina of 97 to 98% of it, right? So if these bacteria can eat out alumina and silica, giving rise to CaO and silica, CaO and MgO will be there in the slag. This can be used as a limestone and dolomite directly into the steel plant itself.
Yes, that is all possible. These are the possibilities. These are the definite possibilities. Only thing in this only thing is that the bacteria thriving of bacteria in that particular environment is very important. The key factor here, that bacteria has to survive and he has to multiply, because we can have only few grams of bacteria, but then bacteria colony has to be take over the entire mass where we'll have this, and that when they are progressing, that amount of conducive environment, that media that we have to mix with this particular thing. So a lot of technological part is also involved into that.
Yes, I think all the steel plants, they are having their slag yield. You can choose a place where you can put these bacteria and give it a try. If that can be done, then all the processes are not to be done. Directly, it can be reused in the steel plant itself. Nowhere it can be taken, no need to take anywhere. Directly, it will be a raw material for all the steel plants. It will be a great game changer.
That is my dream, sir. That is my dream actually. Because what happens right now, everybody is thinking he has done some project and he has got some success. So everybody start thinking from that line only. They have done at this level, they will use this. So, and beyond that, we don't allow our thinking. So what we are trying to put here is that we have to literally think out of box. Some other industry, some other solution, why not try that solution here? Repurpose model, what we are talking about. वो वहाँ हो रहा है तो यहाँ क्यों नहीं हो सकता है? Let's give it a try. A lot of chemistry researchers happen in the basin. A lot of chemicals are thrown at a basin because of not, and certainly one day somebody has found that some other metal or compound has been formed. So these accidents are happening all the time, but we have to have that keen observation so that we can utilize those observations to develop something. And that is what we think this kind of bacterial colony development, specific oxide eating bacteria, can make a major change in the what we are thinking, what we are doing today. Nothing required to be transported, nothing required to be, you will get almost 100% pure product. Just only driving developing of colony and then controlling of this bacteria, because at one point of time this reaction should not get beyond control. So we have to optimize the time.
Sanjay ji, I just wanted to ask one question. because you know that aluminium industry silica is a major issue, and 1% silica increase takes around 30 kg of caustic soda, and that's how the cost of alumina goes very, very high. And we have a large amount of bauxite available in Gujarat, central bauxite, where it could not be used only because it is having high silica there. So have you tried anything on those type of bauxite also, whether practically techno-economic way it is possible to remove silica? Because earlier Calcutta University was also working on silica removal by this thing. Some people have succeeded in iron ore also, but what do you feel about aluminium industry, whether it will it be possible to do that type of thing?
Actually I have already I'm staying in Maharashtra, so I'm working on bauxite from Kolhapur region, as well as something from Raigad region, and my work is at very initial stage. I will not claim anything that I am got success in removing silica from bauxite, but things are going in positive direction. That much I can tell, definitely. So one day, once we optimize the things and we mutate it properly, I think this will be a great solution for everybody, almost everybody. I think
another thing is that
because alumina and silica for iron industry also.
Pardon me? I could not get you, sir. Can you? Hello?
May I go ahead?
Yeah, sure.
Another thing is that, have you tried these bacteria for reducing the silica in limestone? Because why I am speaking on this, because our Indian limestone deposits at Andhra Pradesh and Rajasthan is high silica, is having high silica, almost around 46 to 50% of CaO. And if these silica can be brought down to below 1% or below 2%, then we need not import whatever SMS grade limestone is being imported from Bahrain, Dubai, or Thailand. So this can be directly a game changer for also this limestone industry. So have you ever tried for that?
Yeah, actually we started working on limestone only, and whatever I'm saying is that positive results are on limestone only. So we have not yet came out with the final results, but all the results whatever we did till today are really very positive, and we are very sure that in very short span of time we can talk about the commercial part of it. Commercialization trial or that level will be coming out. So all today's all our experiments or results are on the limestone only.
What you have told, that is very, very right, because all these type of non-ferrous industry waste, they are not only having these values for water treatment and other things, because they have other valuable items also. Like if you consider red mud, it is having gallium, it is having vanadium, it is having titanium, it is having
actually
aluminum.
I'm saying yes, sir. Yeah, Mukesh sir. Yeah, absolutely. Actually, I could see that red mud as a fantastic. All other water polluted water, we can make it potable. Really using red mud filter disc. We can create red mud filters. We have to process, some kind of roasting has to be done, and then some kind of surface area management has to be done, and these filters can be manufactured out of it, and it will be a really good. Wherever there is a fluoride issues in the water, we can solve those problems. Red mud is wonder. It just can't go into cement industry, because that is not a value addition. If I make a filter out
that
of
is not a value addition.
A real value addition for the red mud.
That is a low cost application. It is having a low number of high cost applications. And similarly, lead and zinc industry is there, copper industry is there, where we having nickel, bismuth, gold, copper, silver, etc. And you may be knowing that Hindustan Copper Limited has recently commissioned one plant for recovery of gold, silver, copper, and quartz from Malanchkhand copper tailings, because that is having around 88% quartz there. And the entire quartz, they want to send it to the glass industry, and gold, copper, and silver, they want to recover it from there, because that is also having a good amount of gold and silver. Earlier it was in ppm, but over a period of time, because of the leaching, concentration has gone up. So let us see the result of Hindustan Copper, because they have spent around 200 crore rupees in putting up that project. So what you have taken out, really, it is very, very informative. And I think you have covered all the area, whether it is lead, zinc, copper, aluminum, and all the areas. Till now, we were just concentrating on iron and steel only. This area was left out, and at least you have filled up that gap, what it was not there. Thank you very much.
Actually, I love to work with you.
Nirmala ji, is there any other?
I heard a lot of about you, and I love to work with you. Let's see, we'll collaborate on certain projects, or I will definitely take help from your side.
Thank
Dr.
you. Most welcome.
Dr. Kwande, you have made Dr. Mukesh Kumar happy today because he has spent his life in the aluminum industry. So this is one more angle which you showed him. Anyway, we can because I plan to bring people like you more and more for this Waste to Wealth series, and I need your support because I primarily the concept we thought of was to have out of the box thinking, and that is where your USP is. So I want you to be there for further more webinars. I was just discussing with our organizing secretary, Mr. Sabyasachi Bandyopadhyay, how many more series of webinars on Waste to Wealth we'll be doing to find out solutions, not just commercial solutions, but solutions for one and all. So
actually,
thank you so much.
Sorry, my limitation is that I'm very. We are being a small organization. We are spending research very hugely, and without any commercial support from any big companies. But still, we believe that one small research which will lead to one big commercialization will make the entire changes in the industry. And that way we are. I think our bacteria will.
That is why I want to. That is why I want to support you. I want to promote you because the big guys can take care of themselves. It is small players like you and me who need support. So that is why I want to give you that platform where I can help whatever little way I can help to promote CCRT. I will do that. It's a commitment from my side. Sabyasachi wanted to add something.
Well,
there is one question,
I think Mukesh Kumarji, just 30 seconds.
Yeah.
Nirmala, you have put it very well in perspective. In fact, you have the right platform and right bandwidth to partner with lesser known solutions providers and give them a platform of talking about their solutions and innovations and strategies, because I think even though today is a holiday, you have been able to pull all these eminent speakers here in one platform. But naturally, I didn't know about Dr. Kwande, but I'm glad that I have been here and knowing him and hearing his solution. I would like to have him more on this platform, Nirmala. So please continue to do that. Dr. Mukesh Kumarji, please go ahead.
Dr. Sanjay ji, one question is there. Mr. Nand is there. He has asked only one question. That is, what kind of binder you are using for your porthole repair?
Pardon me, sir. What kind of binder?
Binder you are using.
In
your, you have mentioned something about porthole repair.
Porthole repair. Yeah. Actually, this is I was very emotionally attached with this product. One of my friend was traveling on a bike on Mumbai, Oshivara, and because of rain, that pothole was filled with the water, and he got toppled, and truck ran over him, and his head was crushed. Means one cannot identify whose body it was, and that particular incident has bursted me emotionally like this. Being a background of civil engineer, working for construction industry for long, we people cannot build the roads what supposed to be. So that has led to the development of this product. So we worked on various rapid setting cements, rapid setting concretes, because I firmly believe that bituminous products used for repairs of the road in Mumbai or coastal region, they doesn't stand. Within one shower, everything gets removed because of the water resistance and many other issues, apart from corruption. I don't want to talk on that. But then practically, technically, I wanted something. So I always believed in concrete and its properties and its strengths. So we decided to work on a concrete which can be hardened enough, because Mumbai doesn't stop for anybody for any minute. So we wanted a product which will harden within few minutes, and we can open the roads and people can move on. And that is how almost 1.5 years we worked on. We were used aggregates, specific aggregates with specific gravity, particular specific gravity, then granulation, typical granulation pattern we identified. What can be locked and less amount of voids can be remain into the entire mass, because that voids may lead to cracks. And then as one of friend has asked about the binder, yes, definitely binder is cement plus there is something what we developed. I have my own rotary kiln where I have a special cementitious binder I manufacture. I developed one specific binder, which is more or less cement manufacturing process. So in Mumbai, I have my own small cement plant where rotary kiln, I have a rotary kiln which goes up to 1550 degrees centigrade. Right now, I converted that into a gas fired to now I converted into a furnace oil fired because of the cost constraint. So this small rotary kilns we design and develop ourselves. So that is there, and this is an advantage to me. So that's why a lot of trials I was able to do, and we developed this particular binder. And this binder, along with the OPC cement, and there are some certain other polymeric material and chemical material which changes the static charges on the material, so that the material becomes more flowable. And this particular mass, now we are in a position to give in a dry bag, 25 kg dry bag. Just beside the pothole, you open it, just add 2 liters of water, mix it, place it, just go away. Things will be perfect. So this is now approved by Thane Municipal Corporation, PWD, local PWD, Maharashtra PWD. Now MMRDA, Mumbai Metropolitan Administration, this area, they have also tried this material and people are happy about it now.
You have patented this product?
Yeah, definitely.
Okay, thank you. Thank you very much, Dr. Sanjay.
With the emotion, that emotion drove me to develop this particular product. You require something, that passion, and that passion has, unfortunately, my friend has to die for that. So it's very unfortunate, but finally, somewhere we are able to save some other friends. So that is what the satisfaction we are getting out of it.
That's why we say innovation is a state of mind, and you don't know when you will not do it. Yeah. Okay. Thank you, Dr. Sanjay, for your excellent presentation and your thinking for future.
Thank you, Sanjay ji. Dr. Mukesh Kumar, I had only one suggestion. If we could have CRI, CBRI, and Dr. Sanjay Konde on a same platform, which because I want this series to continue wherever we can, and even in the magazine, I want to carry these articles so that we have greater reach in reaching out to people. This is what I want to do, and whoever is a small player, I want him to become big. I want him to contribute to the industry and take advantage of that. With that, I would request Dr. Surendra Kumar Biswal to just give me 10 minutes, because Mr. Debojyoti Roy is waiting for a long time. He's a good friend of mine. He's there on my WhatsApp group. I give him a little advantage so that he doesn't run away. And Mr. Debojyoti Roy is the Principal Executive Officer of Tata Steel BSL, and it's a joint venture between Tata Steel and Bhushan. I mean, rather the Bhushan plant, which was taken over by Tata Steel. So Mr. Debojyoti Roy is, I would say, responsible for the entire waste management of Tata Steel BSL. So that is why this is it is out of passion that he wanted to address this audience. And Dr. Biswal, I'm just taking 10 minutes because he was planning to move. He would have, by now, I would have lost Mr. Debojyoti Roy. I don't want to lose a good friend. I want my friend with me. So I give him the opportunity to take the floor with your kind permission, Dr. Mukesh Kumar. You will come back because we'll come back to Dr. Biswal. Debojyoti, the floor is yours.
Thank you, Nirmaloda, and thank you for inviting me in this. Actually, really, I'm enlightened to have such a big and very highly knowledgeable panelists in the session. And I went through all the presentation. It was really good to see that how technologies are changing, how we are making move for some very state-of-the-art technology, which is changing the way we'll be handling the waste. And as we call that, waste is not waste, waste is money. So the question is that how we can convert this waste in a way that it makes economical sense. It is sustainable, because we keep on hearing that a lot of things are happening, but if things are not sustainable, then it is very difficult to have faith on that type of technology. So I think that is where Tata Steel BSL, as all of you know, has been taken from Tata Bhushan Steel very recently. And we saw that there are a lot of processes. Tata Steel Bhushan, as I see it, is also such an integrated steel plant which has almost every facility which a normal other Tata Steel plants doesn't have. It has DRI, it has power plant, it has Konark. So when we took over, we saw that this is one of the area where we need to put real focus on identifying that how to have sustainable solution, because one is the statutory requirements, and second is obviously that the value that we are losing out from the waste that we are either not using internally or we are not able to convert them into an economical value. So first of all, our major issue was the time, that we didn't have much of time to get into lot of R&D. And as you know that unless we have some bit of solid understanding of the subject, it is very difficult to get into that type of new products development. So we took the process of collaboration. And today I think what I'll focus is on collaboration. I think a lot of technological discussion has already happened during all the earlier sessions. So we took collaboration as the primary focus area, specifically in the waste, and also how we can convert and we can touch upon the society that we are serving, as this being a very core value of Tata Group. So I'll put my total session into two parts. One is how we are doing some technological collaboration with the key people who are here only, Harsco, EcoMaster. And I'll also put some focus on what we are doing along with the entrepreneurs, startups, and the social organizations that are around, in and around the plant. So I'll just cover up the initial part, which is more on collaboration with the technological partners. To start with Harsco. So Mr. Abhijit Gupta is here, and I think what we are doing with Harsco, Harsco worked with us very closely in our MRP operation last year, and now we are working with Harsco on very different platform in terms of developing new products, complete slag management, and how to ensure that what are the other products that we can convert into a usable product. For example, whether it is LF slag, whether it is LD sludge. So we have our own briquetting plant, but with Harsco, we are developing the products that can be used in the BOF plant. So Harsco is helping us in putting up the recipe. So we are doing a lot of trials, and I hope that within next 2 to 3 months, we'll be in a position to have the right product mix that will get into the BOF and Konark as the replacement of fluxes. And we can clearly see that this is going to add a lot of value in terms of the overall cost reduction as well as sustainable usage of the waste that is currently being dumped or being used in a very low-end usage in sinter making. So as a blast furnace person, I normally feel that sinter making, whatever is going into the sinter making, if something can be actually pushed forward in the process, it will have more value rather than putting in sinter making, because the efficiency goes down significantly in the sinter because of either the lower usage or lower contribution to the process. So this is where we are working very closely with Harsco. And during my last visit in US Steel, along with the Harsco team, Chicago, I could also find today what we discussed is that the LD slag products that are not only going to the steel plants, but that are going out of the steel plants, going to the other industries. So as Mr. Abhijit Gupta also emphasized on the point that how the LD slag products are going into aluminum plants. So I feel that this is a big opportunity for a state like Odisha, which has a lot of aluminum industry and where a lot of other products are required. Currently, they may be either sourcing it from the import source, or they must be buying it at a very high cost. So together, maybe along with HARSCO, we are planning that can we develop such products and bring those technology to India so that we collaborate and find out a way to these aluminum plants. So this is the first thing that we are doing with HARSCO, along with the other things that I have just discussed. Along with EcoMaster, I think all of you know that in Tata Steel BSL, there was a EcoMaster plant that ran for 1 or 2 years, and after that, it couldn't run because of either the technological issues or the economic reasons. So now, along with the EcoMaster team, we are reviving the plant. We have put a lot of efforts, and Mr. Amit Srivastava and his team, they are working with our team to identify that how we can quickly revive this plant. So the revival plan has been already put in place, and Mr. Srivastava and his team are working in tandem with our team, so that all the issues that we faced and the learning that we had during the first phase of that plant, which ran for 2 years, around 2 years, how we can go above that, how we can debottleneck those issues, and how we can run this plant sustainably, because I feel that this is a very, very unique technology. So today what I also learned with that, how we can convert or how we can extract energy out of the process, but maybe our plant is in a primitive state where it cannot generate energy. But obviously I can say that it can develop sustainable products out of the EcoMaster plant that is there. And will be maybe another 2 to 3 months, we'll be in a position to do the first trials. And once the trials are successful, we'll be very happy to continue the operations of EcoMaster plant. So these are two major areas where we are focusing with the technology partners like HARSCO and EcoMaster. Going to the next stage where we are actually working with a lot of local community. So we have seen that there is a huge amount of requirement for paver blocks and bricks, which obviously is in a very normal stage of technology that is required. So what the major issue is that there are small entrepreneurs and micro enterprises who are working here in the vicinity of around 20 to 50 kilometer radius of the plant. So we have created a community of those micro enterprises, around 50 of them, which with them we are creating a complete supply chain and logistic infrastructure, so that they, being a very small companies, they cannot afford to have their own logistics and other systems developed, because that doesn't become economical for them. So we have developed a milk run type of environment where we will be supplying door-to-door material like processed LD slag, fly ash, and other material that they will be requiring like char for developing the paver blocks and the bricks that will come out, and that will go into the local industries as well as the other local demands that will be fulfilled by those 50 small micro enterprises. Apart from that, we are also working with an entrepreneur in the local area who, along with our technologists from Tata Steel and Tata Steel BSL, are developing a specific plant which will be in the just next door to the plant, where we'll be using a mix of fly ash, LD slag, and a part of BF slag to develop different type of product like extruded pavers. It will be having a lot of other products like the GGBS. I think all of you know that.
I think he lost his connection. Hope he will. Ankit, has Devajyoti lost his connection?
No, he's still there in the panel, but his video has turned off.
Maybe a power cut or something like that?
Could be, could be. Should we move
Devajyoti,
on?
can you hear us?
And wait for him to come back?
Devajyoti, can you hear us? I think he will rejoin. Devajyoti, I can't see him anymore.
Dropped from the panel. I think there is some connection issue from his end.
Okay, till he comes back, till Devajyoti comes back, what we'll do is we'll utilize that time for Mr. Biswal to give his presentation, and then when Devajitita comes back, we'll join in. Dr. Biswal, you can start your presentation. So by the time Devajitita comes back, we'll take him in.
I think people may not be aware about Dr. Biswal. Dr. Biswal is a very, very eminent scientist and working for the last several years in IMT Bhubaneswar, and he has worked on various mineral exploration, mineral processing, coal processing, waste processing, and so many other technologies he has worked. And he is associated with number of organizations also like JSW, Tata, JSPL, and Coal India Limited, NALCO. So many industries he is supporting them in various waste management as well as mineral beneficiation. So, Dr. Biswal, now the floor is yours.
Yeah, thank you, Dr. Kumar, for nice introduction. And good evening to all respected panelists, respected participants. At the outset, I thank to the organizer giving the opportunity to present my work. Yesterday also, I have full time, I have listened, and this is the, I may tell, this is the one of the good platform for exchange of the knowledge. Now I will go forward to present my the waste utilization, part of the waste utilization of the steel plants. Yeah, because today, last 2 days, we have debated in different topics regarding the utilization of the steel plant waste. But that is because of the new, that is the environmental policy and regulation, all industries are now interested to utilize their respective waste. But already people have told the new steel policy, we are going to aiming to 300 tons of the steel. No doubt the production of the waste will be multiplied. But the R words, many people have used either 6, 7, 8 like that. But if you look after the R, they reduce. How will you reduce it? That's the main thing is if you can input material quality, you can improve. Either iron ore or limestone, whatever your raw material you are using. If you can put up the good material, automatically the generation of the waste will reduce. And number of reuse already people have told, but I will only emphasize the reprocess, the how to recover the values from that waste. And apart from that, after these 2 days, at least we may agree that this is the resource. We should not tell the waste. This is one of the different types of resources. And also now it has the value. Now it has people are looking after the revenue from this. I am highlighting some of the major waste generated by the integrated steel plants. That is the coke bridge, blast furnace slag, SMS slag, mill scale, dust from sintering process, dust from blow, BF, and also BF sludge, SMS sludge. I will only, the mill scale already lot of presentation has been made, but as our R&D laboratory and we have utilized, particularly for the pelletization, the ArcelorMittal Nippon Steel, which is earlier the Essar Steel in Paradip, now they are using the mill scale for pelletization. We have done a lot of tests in this regards, but I will highlight about only the blast furnace flue dust sludge and SMS sludge. If you look after the blast furnace flue dust, on an average, it contains the carbon 20 to 25%, and iron around 30 to 45%. It mostly in form of magnetite, it has been present. And silica, alumina, and calcium oxide and magnesium is there. And some people have also started told zinc is one of the issue which we have also addressed, but because if you go for the separation of carbon and iron phase mineral, the zinc level, it goes down because of the lot of water used for the process, automatically dilution is happened. But whatever product we get it, because now many people have directly utilizing the sinter feed through micro pellets. But if you separate it, by the carbon material and iron material, it may be utilized for number of other purposes. Like the iron phase mineral, you can use as a washer media. Carbon material can be used again the carbon making. I will show my process flow sheet. It's a simple process flow sheet. The blast furnace flue dust, because from the more than 2 decades, we have worked number of blast furnace flue dust from different industry, from Tata Steel, RSP, and also Essar Steel, which is now the ArcelorMittal. The blast furnace flue dust, you have to do the first take out the carbon by flotation methods. We are using either flotation cell or flotation column. You can take out the carbon. And that carbon material, because of the concentrate contain the good amount of water, but filtration problem there, you can use the steel belt filter. The steel belt filter has the both option, both vacuum as well as pressure. It is mostly being utilized in coal industry in USA. Then you can get the carbon material, either you can use for sinter or you can use in pellet plant as a carbon 1% we are using, or you can recycle to the cocoa van to put it again back for coke making. And whatever the tailings generated from the column flotation, we go for the limbs or MIMS depending upon the oxidation state. Then you can get the concentrate having the 64-65 grade of the iron values. That you can use for the sinter purpose, or you can go for the pellet purpose, or you can go for the media purpose. And why I am telling that this coke can go for the coke making, because recently Dr. Kumar is also involved in our institutes, and we have done the non-coking coal to coke. Normally coking coal used for the coke, because India do not have the much coking coal. We have tried non-coking coal to coke by using the different types of binder like biomass, organic binder, inorganic binder. Even coking coal, if the prime coking coal is there, they have the binding properties more, you can blend it. Direct non-coking coal to metallurgical coke, we have done it. And also, whatever this flue dust we are giving the magnetite, because we have also making the ferrocoke, even non-coking coal with the iron ore fine, particularly the magnetite, because magnetite will give the exothermic reactions. That way we have also done ferrocoke. You can see that the non-coking coal was used in our study, and we have done the non-coking to after carbonation we get the coke. More or less we are getting the same property of the coke. Similarly, we have done also for production of ferrocoke by using the iron ore fines, the magnetite as well as non-coking coal. In place of non-coking coal, you can use this coke, whatever carbon, because this is the most of the coke fine particles is coming in the flue dust. That you can combination of the non-coking coal as well as the coking coal, you can produce for the coke. And SMS sludge, which you can say we have collected number of samples, but I have given the example 3 samples. It is containing mostly the austite and magnetite, and that is a region it is containing the FeO, almost 75 to 80% of FeO. That is the good material for the pellet making, or you make the micro pellet go for the sinter. But because it has contained the good amount of the FeO, it gives the exothermic reaction during the pelletization, and particles are ultra fine. Better we should put as a sweetener in the basic iron ore pellet, because basic pellet, why I am telling, because it the calcium oxide content around 10%, and we have done it with the blending with the other normal ores. One of the ore, one example I am giving, it is containing 63.580% Fe with having the LY 2.588%. Once 25% we have blended. Once we blend it, we are getting almost 64% Fe in the pellet, and that is the CCS in 260, porosity 23%. Other metallurgical properties is meet whatever need by the DRA and blast furnace. Now I am telling because of I have the steel sector, because Mr. Sharma has told that the China is taking the low grade ore from India and making the steel. Why we are not doing it? why we are not utilizing our ores. We have developed the process, the reduction roasting of low and lean grade iron resources. You can see we have a lot of BHQ, BHG and BGQ. BGQ is only available in Rajasthan. And low grade dumps are lying in the different mines, particularly from Odisha, Chhattisgarh, Jharkhand, and also Karnataka. And lot of slimes, because lot of even Shell and Tata Steel, till now they are washing the iron ore. A lot of slimes they are generating. It contains good amount of Fe value. It may vary from 51 to 60% of Fe. Similarly, lot of laterite low grade ores are available, up to 35-40% ores also available near the mines as they are rejecting. And if you do the reduction roasting means we are only changing over the hematite to goethite to magnetite, and then we are grinding it to the liberation sites, making the manganese separation, getting the magnetite concentrate. You can see the picture how color is changing. This is the iron ore, and we are reduction roasting. We are doing the converting the magnetite. Then after grinding, we are doing the magnetite separation using the low intensity magnetite separation, getting the magnetite product. One of the example I can give the BHQ, which contain 47%. This is the Karnataka BHQ. After reduction roasting, you can see that from 47, you are getting the 72% yield with 66% Fe, and FeO is 70.26, and overall iron recovery is 93%. You can see the tailings, it contains only 11.85. Any BHQ and BHJ and BGQ, all blended material ores, iron ores, it is giving good response to the reduction roasting. And we have also calculated the economy, commercial point of view, because we have tie up with FL Smith and engineering sites. We have gone, and this test we have done in pilot scale in our plant. This is only 100 kg per hour, and again it has been gone for a commercial 20 tons per hour. We have tested in that is the hospital area, that is the BMI Ispat. It was successfully demonstrated. Even low grade ores, those are the 55%. If you take the 55% of ore, go for the conventional beneficiation, because our ore, particularly Odisha and Jharkhand, contains good amount of goethite along with the hematite. That's why it is called the goethitic hematite ore. Conventional beneficiation has given a lot of difficulty, because we have already put up the plant for the BRPL and Isar Steel and SMPL and Bhushan, that is the Jharsuguda. We have observed that because goethite percent goes on, then the difficulty getting the yield is a problem, grade is the problem, diverting is problem, making it pellet is also problem. That's why we have thought that below 55%, instead of going for a conventional beneficiation, we can go for the reduction roasting process. You can see that 80% yield with the 65 grade, and LIMS non-mag is containing 34% Fe. And overall recovery is around 89%. This is a simple process, flow sheet by rotor clean, then you grind it to the liberation size, do the LIMS, and because of the reduction roasting, the filtration, both the tailing as well as the concentrate can be possible, so that the overall water consumption, the recycling water is improved, almost 50% water consumption ever reduced. And if you do the beneficiation from the low grade ore, from the fines or BHQ and BHJ or BGQ or slimes, then you either, if it's the high grade ore, you go for the beneficiation, otherwise you go for reduction roasting, and to produce the pellet, which pellet can be utilized both blast furnace as well as the DRI. And this is the process flow sheet we have developed. This process has been adopted not in India, it is already adopted in Nigeria. And again, because of to reduce the cost, overall cost, instead of going for magnetite, because when you go for the goethite for reduction roasting, you have to very much careful about the thermodynamics and kinetics. It should not form the oostite, because the oostite will not attract by the LIMS. That problem we have observed that to again further to reduce the Fe value in the tailings, we have gone for the micro nugget production using the JSPL Tensa ore. You can able to see that Fe in the mag around, it has gone maximum 84-85%, and non-mag percentage, you can see that within the 10% Fe in the there. then if you that nugget will form, then you can go directly the nugget to make the briquette, the pelletization, DRI, you can remove it to reduce the overall cost. Then both can be utilized in blast furnace or induction furnace directly. My conclusion is the word should be changed from waste to the secondary mineral resources. That the attempt should be made to reduce the generation of reject in the process by using the high quality input material and using the advanced technology. And R&D activity with the industry or engineering consultant equipment manufacturer should be emphasized so that we may get the synergistic results. Thank you.
Thank you, Dr. Biswal. Thank you for concluding on time and talking about again. In particular, you covered only the blast furnace aspect, and primarily with regard to the raw material aspects, not going down too much into the process of other LD, slag, or other issues. Dr. Mukesh Kumar, if you have a question for Mr. Biswal, otherwise, if you don't have a question for Dr. Biswal, we will bring in Debojyoti back again. So, Dr. Mukesh Kumar.
No, I don't have. I think what IMT is working on the utilization of the low grade ore, it will increase our reserve base to a large extent. And there are number of mines in Karnataka, there are number of mines in eastern part also, where it is having this type of bauxite available, this type of iron ore available there. And with the use of the technology developed by IMT Bhubaneswar, I think most of the this type of ore, which today we are finding it difficult to use, like in Chhattisgarh or in Jharkhand area, we will be in a position to use it. I think this will be a good technology for in time to come.
May I ask a question, sir? Sir, may I ask a question, sir?
Yeah.
Dr. Biswal, you have created a product where you are showing that CRI is around 40 to 45 and CSR is 30 to 35. Because these products will be used in the blast furnace, and with the high PCI application in blast furnace, if your CRI is 40 to 45, this will create a problem because it will not hold good in the burden. So can you throw some light on it?
Yes,
even your CSR is even your CSR value is
yeah, it is required the 70, I know, 60 to 70 is needed. We are improving it. But whatever we have at present, we have got it. It is good for the ferroalloys because of the blast furnace directly it cannot be used. But we are trying to again further improve to up to the value of 60 to 70.
Yes, otherwise it cannot be used in blast furnace because you have been claiming that it will be used in blast furnace. Once your CRI is coming down, this cannot be directly used in. So just I think there requires some more work on this.
Yeah, this is the basic work is going on. Once go for the pilot scale test, that the property will again further will be improved. Yeah.
Thank you, sir.
Thank you, Dr. Biswal. Thank you, Argoda. As we all know, Mineral Beneficiation Division of RRL, now called IOMT, has done a lot of work. And our own Dr. Bhima Rao was also in that same Mineral Beneficiation Division. So I have been interacting with RRL for the last 25 years. Now, coming back to my good friend Debojyoti, let me, Shobhata, you had a question. So I'll ask that question to Debojyoti right away. Which batch GT of Tata Steel are you? 93 or 94?
99.
So that was the question. 99 batch GT. So yeah. much younger than you, Shobhata. You're free to ask your question.
No, that's all right. I was just curious because if he's from Tata Steel, I have got a few friends who are still with Tata Steel, and just wanted to know which batch GT is. My friend, one of my good friends, Sumant Sinha, is in the chief marketing long products in Kolkata.
No, he is in now byproduct marketing, so he is very closely associated with me. He is my counterpart. So while for Tata Steel BSL, I am looking after both operation and marketing both. Sumant Sinha is looking after the overall Tata Steel IBMD, we call it industrial byproduct division now, which was secondary products earlier. So he's looking after the complete marketing and sales of IBMD. So he has moved from long products to the IBMD department.
Okay, I didn't know that. Thank you for updating me. But he's my classmate, and yeah,
so
and
I
then
definitely updated.
and you said that you are from iron making. So one of my other classmates for a little while was in Tata Steel, I believe, and then now he's with Tata Metallics in Kharagpur. His name is Somujyoti Sarkar.
Yeah, so we worked together in blast furnaces. So he was in operation and I was in maintenance of F blast furnace. So we worked together. Again, very closely associated with him also. So I know them both very closely. Yeah.
Okay, world is small. Thank you so much. Okay, Nimalo.
Yeah, Devajit, the floor is yours.
Yeah, thank you. Sorry for this interruption. Suddenly the network got dropped, so you don't know.
We could understand.
A regular problem. So I'll just quickly close in another 2 to 3 minutes. I have taken a lot of time. So the other collaboration projects that we are working, one is that along with our corporate service, because our corporate service works with the local community in a very big way. So along with our corporate services team, we have developed again in-house paver and brick manufacturing plant inside the plant. And we are actually promoting the local community to run this plant, and that will have a capacity of almost 1 lakh unit after it ramps up. So it is just going to start within 10-15 days. So it can ramp up to around 1 lakh unit per month to suffice the domestic requirement, as well as it can go for sales also. So we are also trying to do some sort of branding for the local sales and all. As I've told all of you that we are also doing a lot of collaboration with some startups for developing new products. So one of the product that comes out of the HSM is the HSM grinding dust. So I think you all know that grinding dust is something which cannot be used in sinter plant because of its high chromium content. So we have developed a startup who is working on developing ferrous sulfate hydrate. So this is a product which is used for water treatment. It also goes for medicinal use. So we are now developing this, we are collaborating with them, and we are developing this product using the hot strip mill grinding dust. And if that is successful, so we have done a very good trial last month, and now we are starting to move on a regular basis. If it is really going to work well, then it will be a good breakthrough, and it is a very, again, a local industry within a vicinity of 60-70 kilometers. So it will also help in developing those industry by supporting them and giving them a raw material security. Another project that we are working, and I think that has really given a good result, is that the DRI char, which was earlier dumped because of its properties, we saw that it has got good calorific value and which can be used, while the cement plants definitely use this product. But since in Tata Steel BSL vicinity, we don't have any cement plant very close by. So we have done a trial of this DRI char in the power plant that we have. And this has helped us in replacing that quantity of imported coal, because as you know that our power plant has to use a mix of imported coal as well as the local coal as per the statutory norms. We could actually get a good result using the DRI char in the power plant, and we replaced the imported coal. And based on that, we also got a approval from the statutory authorities that we can replace up to that extent. So this is how we are trying to find out usage, whether it is internally or whether it is in the local community or whether it is along with the partner, that we can develop these products, and how we can actually build up a sustainable ecosystem using the byproducts that is coming out of the steel plants. The last point that I would like to share with all of you is that we have, Tata Steel BSL has 2 downstream units. One is in Saibabad in Ghaziabad, and another is in Khopoli, which is in Maharashtra. So these 2 plants, these are specifically the cold rolling mills and the tube mills, which are catering to the auto industry and the export industry there. So that generates a lot of steel scrap, and it was actually becoming very difficult to handle that scrap, having a lot of very low bulk density and all. So we have collaborated on one side for the Saibabad. We are collaborating with the steel recycle business that Tata Steel has started, which will be taking the entire amount of steel scrap that will be generated in Saibabad, and it will be again a type of raw material security that will be providing them, and then they will convert into the different steel products. Similarly, we have done a collaboration with Mahindra Sanyo, who has a nearby steel recycling unit in Khopoli, which is just 5-6 kilometers away from our plant. So we are working with them, and from next month onwards, the scraps will start going to them with a very good commercial implication, as well as a good supply chain infrastructure that has been developed, so that together we can actually build up some good quality product, and this material should not move too far, because that then the logistic cost gets a big impact on the overall profitability. So this is what I would like to share about the Tata Steel BSL byproduct business, and how we are trying to develop the ecosystem which is more sustainable in nature. While a lot of things are under trial, and I'm sure that within next 6 to 8 months we'll be having a lot of projects which will actually get implemented, and the industry as a whole will start getting benefit out of that. Today we got a lot of input from the other panelists in terms of the technology that are being developed in the different laboratories as well as the different facilities. With respect from Tata Steel BSL, I'll be very happy to collaborate with them to identify something which we can do together, whether it is CRRT or IMMT. So anyway, IMMT is helping us in doing a lot of trials of our product. So I'm sure that we can actually develop some new projects, and that will help us in developing the system in a more sustainable way. Thank you all for giving me time and giving me opportunity to share my thoughts.
Thank you, Debojyoti. It was again, you covered basically all the aspects. And I think both HASCO and EcoMaster must be very happy that you are here today to address, the issues which they need to give a solution for. So it was very well covered. And I invited a common friend of ours, Prabhat, to make sure he listens to your entire presentation. And Prabhat was there to listen to your entire presentation. So with that, Dr. Mukesh Kumar, if you have anything to add, because I have a small little request, Dr. Mukesh Kumar. What I would like to do, since we have a colleague of Debojyoti waiting for a long time, Ritesh Kumar, who's head marketing and business development, industrial byproduct management division. He is waiting for a long time on WebEx, because it is little complicated, because WebEx has to be routed through YouTube and YouTube to Zoom. So it is a little complicated process. I would like to do that first, so that we can come back to Pawan Kumar Verma, who's again a solution provider, who can listen to Ritesh, and he can reply better. So we'll put Ritesh.
Question was there for Dr. For Mr. Debojyoti.
Sir, you are the boss.
No. This question has been raised by Mr. P.K. Misra, that Tata is converting BOF sludge to charge to converter in their UK plant. So is there any plans to use similar type of thing in India also? Debojyoti, can you hear me?
Yeah, sorry, sir.
One Mr. P.K. Misra is there. He has raised one question that Tata is converting all BOF sludge into briquettes and charging into the converter in UK plant. So is there any plan to use similar type of thing in India also, either in Tata BSL or Tata Jamshedpur?
Yes, sir. So as I have shared that this BF sludge and LF slag, we are planning to convert into briquettes, and HASCO is definitely helping us in developing the total recipe, because while the plant is available with us, the briquetting plant, which has just been commissioned, but it doesn't have the right, we don't have the right recipe which can be actually fed to the BOF plant. So I think another 2 months down the line, we'll be in a position to start feeding this BOF sludge as well as LF slag to vessels. And I hope that once it is stabilized, then we can actually ramp up the usage inside the plant itself.
Thank you. Nirmala ji, you can take Ritesh into this thing.
Yeah. Amit, is Ritesh ji there on WebEx, can you route him through to our Zoom? My good friend Sanjeev Manocha is also waiting for a long time. So we'll have to rush up a little bit so that I can put Sanjeev, though he is in London. I mean, what is it, 4:30 in London right now. So Amit, you have my good friend who is also in your city in London.
Okay.
So maybe as a Londoner, you should try to push him in.
Yeah.
He's a very good old friend of mine.
Okay.
Friend for almost 25 years.
Yeah,
So
just
I
give
have,
me
I have
5
to.
second. I will just put Ritesh here, and it's also like you can talk to Mr. Ritesh, like Ritesh was watching you all till now, but now you all will be watching Mr. Ritesh. So that's how it is now.
Hello.
Hi.
Yeah, Ritesh, please go ahead.
Yeah, Ritesh, the floor is yours. Please go ahead.
You're audible, Ritesh. Ritesh, you are audible. You can start.
Yeah. Hi. Good evening, everyone. So just I'll attach my slides. Let me know when it is visible.
Absolutely, absolutely. We can see your screen.
Yes, Ritesh, we can see your screen.
Okay. Yeah, good evening, everyone. It's an honor for me to be speaking among this steam gathering. And I think there has been a lot of discussion on PS slag and LD slag utilization already. And our EIC, Mr. Prabhat Kumar, had a detailed presentation on this. Even Devjyoti just spoke about the initiatives taken at TSPSL. So I'll just do a quick revision and focus mainly on the way forward, which we are doing. So just to start off, to give you a brief introduction of about the industrial byproduct management at Tata Steel. So in Tata Steel, IBMD handles all the byproducts across the value chain, and we are a profit center. Our main purpose is to recover and process metallics from the steel slag, then reuse it in the steel furnaces as well as using the external applications, and of course converting this byproducts into a valuable and marketable product. As Dr. Santiago and others also mentioned, that there's nothing called byproduct. It's a product, and everything has a value and it's worth using. So we have a vision to be recognized as one of the most innovative and enterprising byproducts division in the world, and we are working on the 3R principles of the circular economy. And as far as our product portfolio are concerned, we cater to over 1,500 plus customers, and we offer 250 plus products to them. As you all know that most of our product is, base of the steel plant is majorly slag. So LD slag and BS slag contributes to over 60% of the byproducts generated. We are first division of byproducts to brand our products. So we have 3 brands: Tata Ferroshorts, Tata Nirman, and Tata Agri2. So I'll talk about Tata Nirman and Tata Agri2 a bit.
Habib, namaskar ji.
Yeah. So moving forward, as we'll just have a quick glance on the value chain of PS slag and LD slag. So here in Tata Steel, we have both granulated as well as air-cooled blast furnace slag. And granulated slag, we are all aware, it goes into cement making. We have also upstream and produced GTBS, which we are commercially selling in the market. And this gives us a much better value than just selling in a as-is form, the BF slag. And as far as air-cooled cast iron slag is, for past 1.5 years, we have been sort of successful in establishing it in road applications and through some value addition in terms of crushing and screening. And it's been well accepted by the customers and is currently being utilized in the construction of national highways in the vicinity of Jamshedpur. Now, talking about LD slag, so here we have our MRP plant where the metal is separated and then further the slag is crushed and screened. And as we all know that the LD slag cannot be used in as-is form, so it also undergoes weathering. And to that we have a processed steel slag, which is Tata Aggregato, and it's a coarser form of coarser aggregates. Basically, its size above 6 mm to 5 mm, whereas the finer size fraction, it is in unweathered condition. This is Tata Nirman. So Tata Aggregato is, while it is being utilized in road making, Tata Nirman finds its usage in brick making. So in fly ash brick manufacturing, it is being used as a replacement of sand as well as partial replacement of lime, because it has got a lime content. So I'll talk a little bit about LD slag. So we all know LD slag comes with a lot of challenges. I mean, as some of our expert panelists showed, that in India, the utilization percentage is much lower as compared to the world benchmark. So basically, there are a couple of limitations which are restricting its usage. One is, of course, not everyone is aware about its usage in the market, because when we go and approach various road construction companies or the other builders, they say that it has to be in the specification, or it's not widely known, they are not confident about it. So there's a limited knowledge of the applications. There's no requisite standards. While there has been development in past couple of years where it has been included in IRC, and now recently MOT has also come up with a circular which kind of mandates that can be used in line with the IS 383 in the road making. Now, we also know that it has a free lag content, so which leads to the expansion property possesses. Hence, it needs further processing, which incurs a lot of cost. But when I talk of cost, I mean, at Tata Steel, we talk of triple bottom line. So people, planet, and profit. So not just profit, but also planet and people are equally important. So we must see it as a sustainable solution in conserving our ecological environment, rather than just piling it up as a landfill. So that is why we have taken effort and leveraged our technology in developing solutions for that. And it also provides us immense opportunity. We all know that how difficult it is to get natural aggregates, get a mining permit, and it also involves a lot of damage to the nearby environment. So it is better that why not use a greener product or terms of manufactured aggregates, in which category LD slag falls in. So with this, we can of course promote circular economy and save our environment. So quickly, I'll run past through our processing. So in order to overcome the limitation, we first do the metallic separation, then crushing, and then screening. And during the screening process itself, we get 0 to 6 fines. Hello? I hope I am audible.
Yes, you're audible. Please go ahead.
Yeah. So 0 to 6 fine aggregates, which is Tata Nirman. As I told you, it goes into a brick making industry. Now we take it to our processing yard where it is weathered. So for weathering, we have presently two technologies, dry and wet cycle, and other one is steam aging, which has been talked about. And of course, it has to go through stringent quality inspection before it is being certified for usage of the customers. Yeah, so this is just a bit of detailing of that two processes which we have. So dry and wet cycle aging has been there for quite some time. I mean, within 1.5 years or 2 years, we have been doing it. Whereas open steam aging has just now completed 1 year of operation. And almost in last 2 years, we have supplied more than 2 lakh tons of aggregates, processed aggregates from both the facilities. So as you all know that since this is a new business development and the quality is of utmost important, otherwise all the efforts which we have put in for about a decade, that may be at risk. So we ensure that it has to be tested in all parameters, and we are first company to provide sort of test certificate for our our manufactured aggregates which we are supplying to the road construction companies. So as you can see here, volume expansion, iron soundness, pre-lime, water absorption, impact value, crushing value, all these parameters, each of these parameters are tested for each and every pile of the LD slag which is being processed. And just to reinforce this, I mean, there was along with CRRI, we have been developing this application, doing the study. So they also did the testing of our product, and they have certified that apart from specific gravity and the water absorption value, all the rest of the values are much better than the natural aggregates. So in order to further promote our product, we have branded it as you know that we provide test certificate also in order to have a greater reach and giving confidence to our customers. So Tata Greenko comes with a brand promise of export quality, guaranteed availability. Since steel plant runs throughout the year, there's going to be consistent generation, and you will be able to supply at any time whenever it is required. And of course, the size mix is consistent because it undergoes a screening process. And the benefit is that it has got superior pavement properties, and it comes with a lower cost, cost to the customer, cost to the environment, both is lower in this case. And if you talk of specific properties such as higher angular shape, rough texture, this helps in having a high skid resistance property, good abrasion resistance, and of course the high bearing strength. Now, all these efforts has not been, so easy. I mean, there's been a lot of support from all the industry bodies and well as ministries and the CRRI lab, IRC, all. So we have been working along with, and also the steel fraternity. I mean, we have a Apex Slag committee chaired by Dr. Saraswat of Niti Aayog. So we keep meeting and discussing about the developments in our respective plants and sharing ideas so that this LD slag utilization is being taken into commercial stage. And we are all working together, and we see that the time will come soon, and it will have similar pull as it has for blast furnace slag as on today. So these are a couple of examples where we have already utilized the steel slag. So this is a rural road near Jamshedpur. This Timna road stretch in Jamshedpur, and this has been also tested by CRRI. And the National Highway NH33 and NH32, which is being constructed near Jamshedpur. there we are also utilizing our LD slag process aggregates. And CRRI is working along with us. I think we have taken samples from all the steel plants, and based on that, standard specification will come out, and this will be part of the auth handbook, so that it will be of ready reference to anybody who wants to use LD slag aggregates in future for road making purpose. Now, as I mentioned about the air-cooled blast furnace slag, so we generate approximately around 15 to 18 kg of air-cooled slag per month, and this was getting accumulated for years in our Galudi yard and was underutilized. So we worked along with our energy contractor as well as IIT Kharagpur, and they helped us to kind of find a solution, do the gradation for that, and the suitable design mix for usage of these aggregates in the ASP layer of the national highway. So till date, I think in past 1.5 years, we have supplied close to 3 lakh tons of air-cooled blast furnace slag into the national highway. Now talking about the way forward. So I have discussed about road, I have discussed about fly ash pits, and we have also developed paver blocks. So in paver blocks, we are replacing both coarse as well as the fine aggregates. So 6 to 10 is the Tata Aggregato, the coarse aggregate, and 0 to 6 Tata Nirman is being replaced, and these paver blocks are working quite well. And we are going to very soon scale up this operations. And we discussed, there was in panel, there was question about how to use it in clinker or cement. I would like to inform the House that we have already conducted a study along with NCCM, where the results are quite promising. So very soon we will try to get it included in BIS applications also. So as per the data, approximately 9% of LD slag can replace the blast furnace slag in a PSC cement. So you may call it a composite cement, where as a standard, normally the PS slag is in PSA is around 60%. So out of that 60%, approximately 9% can be replaced. Now talking about the rail ballast application, so this is another area where we had a trial stretch, but unfortunately the test results could not be concluded. So we are again working on these lines, and I understand CRRI and RDSO is also working on some specifications or guidelines through which this can be utilized. Parallelly, we are also doing our own R&D and research in terms of using Tata Aggregato as a blanketing material for this railway track. So near Jamshedpur, there is a third line which is getting constructed from Tata Nagar to Kharagpur. So there we are working along with RVNL and its contractor and trying to see if this product can be used as a blanketing material. Lastly, talking about the agriculture, I think as Mr. Abhijit also mentioned about that, they have done good progress in this regard. I would also like to update that at Tata Steel, we have also conducted several studies along with 5 different agencies. One is, of course, Birsa Agricultural University, Ranchi, and BCKV, West Bengal, US, Bangalore, KVK, Baramati, and Punjab University. And based on the research findings and the recommendations which they have got, we had approached to even Ministry of Agriculture, and what I understand, they have asked for certain recommendations letter directly from the universities just to validate the findings, and based on that they would further initiate process of including it in FCO as a provisional fertilizer for the lily flag. So that's all. I think I'll be happy to take more questions if there are any.
Thank you, Ritesh. Thank you so much for an excellent presentation once again. Now, what Tata Steel has shown the way is primarily with the Aggregato being developed as a brand. I think it's a sort of a way forward for the entire industry to take up. Tata Steel in a lot of areas have been pioneers. We know the legacy of Tata Steel, what it has done for the industry in many areas. Let me talk about my good friend, Mr. Muthuraman, who was very close to me. I used to interact with Mr. Muthuraman very often. And one of the things he told me, I remember, was the steel industry should move out of the commodity cycle. So that Tata Steel actually paved the way. Yeah, sorry. Yeah. Yeah, sorry for that interference and feedback. It was primarily because, we are trying to run two platforms together. We are running two platforms together, so that is why the feedback. Yeah, sorry for that interruption because of two platforms being merged together.
Narmada, what I'm doing, I'm just stopping Mr. Ritesh, and Mr. Ritesh will watch you, so he can answer from there. Mr. Ritesh, I'm just patching you in Zoom, so you can watch Narmada.
What you can try doing, Amit uncle, is you can try to share the screen without the audio.
Okay.
Yeah, and we can hear him through your microphone if you are on.
I was doing the same thing, Ankit, but I've just switched off my mic, but since there is something else interfering in between. But what I'm doing now is just sharing my WebEx to Ritesh so he can watch your Zoom.
Yeah, yeah, okay. If there is a question, Ankit, what I would request you to do is Dr. Mukesh Kumar has a guest, so he has just taken a break. So in the meantime, just see if there is any question for Ritesh, you can put it up on the Q&A and Ankit will read it out for Amit to ask Ritesh. So Ankit, any questions so far on Q&A?
So
if anyone wants to put it.
We've had a question from a couple of questions from Mr. PK Mishra. So he just asked that Tata is converting BOF sludge to charge to converter at UK plant. Why not in India? And the second question he asked was Tata is converting BOF sludge into briquettes to charge into converter in their UK. Okay, it's the same question that he has asked. Yeah.
Ankit, I believe Debojyoti did answer that question. So let's move the question saying answered live so that they don't stay there anymore.
Yes, okay. Yeah. So in that case, we can move on to the next speaker.
Yeah, next speaker is Mr. Pawan Verma, CEO, Techno Enviro Services. Again, a very good human being. Not just a good human being, I'll say a very helpful person. The fact that, we could interact with Harsco was only because of Pawanji, who actually introduced us to Harsco, and Mr. Pawan Verma has also helped a lot in the ground realities part, and he has promised to be there for our other series of webinars also. So Pawanji, a big thank you to you before you start. एकदम दिल से आपका हम आभारी हैं ये हैं कि आपने बहुत help किया to organize the session 2, especially today's session. Your help is well recognized. And just after Mr. Pawan Verma, we'll go to my good friend Sanjeev, who is also waiting. Manocha is waiting. Sanjeev Manocha is waiting for a very long time. Sanjeev, can I have you on screen? Can you put on your video now? So that just after Pawanji, you can say, hi. Good to see you, my friend, after such a long time. Just to brief, Sanjeev was in Indomag, which is now called SMS Demag India. So those days, from his Indomag days, we know each other, which is almost 25 years now. And he has maintained the relationship all these 25 years, wherever he was. He was in ArcelorMittal, and even then he was in touch with me. So all through he has maintained the relationship, a very good friend indeed for the last 25 years. So he's been living in London for quite some time now. Sanjeev, just give me 10 minutes before Pawanji completes.
Yeah, don't worry. Thank you very much. Thank you.
Thank you, brother. Thank you, brother. Thank you so much. Pawanji, the floor is yours.
Yep.
Yes, Pawanji, you can start. Go ahead. We can see your screen. Oh, you're trying to go to the slideshow. Okay.
I think Nirmala, we lost him. Nirmala, I think he had a connection issue and we lost him.
Okay, then Sanjeev, please take over. Let him come. Once he comes back, we can take him up again. Sanjeev, you can start. Sanjeev is going to primarily talk about line.
Okay, thank you very much, Dada. Thank you for your introduction. I really appreciate that. Okay, just a brief introduction before I begin my presentation. I mean, thanks again, Dada, for introducing me, and thank you for inviting me today. I think it's a great pleasure to be here with great esteemed personalities from different parts of the world. Thank you very much. So I come from India, of course, and I have been sort of working in different parts of the world. And my main sort of work has been with SMS DMAG, which was Indomag at that time. And from there, I would say that I have learned a lot on the technology side, and I've been more or less technologist basically in my life. I can call like technologist. And since then, I have moved on to different parts of the world. I was in Indonesia with Ispat Indo. Then I moved to Middle East, and from Middle East, I came to UK to run a steel mill as a general manager. And then I moved to Carmeos back in 2014, and we are the lime producer, Carmeos globally. So probably most of you know us. I will just introduce a little bit, but I will talk today quite different perspective. I mean, I think it was very interesting sessions what I heard today. It was really, really good. I think it was really worth spending every single minute today actually on this webinar. So thank you very much for that. I'm going to talk a little bit not from the, I would say, waste sort of utilization. I'm just going to talk a little bit about how we can reduce the waste actually in the first stage. And then, of course, we have waste to wealth. I'm sure that you are able to see my screen, right?
Yeah, absolutely. Loud and clear.
Yeah, okay, thank you. Okay, so my agenda today would be that I'll just give a brief introduction about Carmeos, if you allow me. And then I talk about a little bit about technology side. We are generally a product manufacturer, but we also very much love technology, and we have partnership with different technology companies. And I'll talk about a little bit about lime, that why lime is important and what product characteristics we are looking for different processes. And last but not least, it is about reuse and recycle of the waste within the steel industry. Just coming back to the theme, what I've been asked to do today. So then concluding my talk, and happy to take any questions. And I'll try to be within 8 minutes slot, which I've been given today, right? Okay, so just in a snapshot, what Carmeus is all about. So we are the lime producer. So we are about 1.4 billion euro company, and we have about 80 plants around the world and different quarries around the world. And so we have a number of customers around the world we are serving. So these are the locations where we are producing lime. I mean, you can see that we are the largest one in the US, and then we are in Europe. Turkey, we are supplying to other countries like India. We supply from mainly from Majan, from Carmeus Middle East, we call. And we have operations in Thailand. So we are expanding to Asia Pacific, but we were mainly originated from Belgium. And then we expanded gradually basically to the rest of the world. We have also got a new company, I would call it a baby of Carmeus, because we know a lot about lime manufacturing for 160 years now. We have been making lime. So we know a lot about kilns now. So we started supplying kiln technology also now. So we are giving the complete package of our customers to start from producing lime to using lime and sort of also supplying the products what you need. So our iron and steel industry is our largest sort of customer base, and I'm globally responsible for iron and steel business of Carmeus. And then of course we have different other industries, civil engineering and sort of different industries. The reason I'm showing you that we have knowledge, I would say more or less in every industry, because there are people like me, those who are working for different industries within Carmeus. So the theme of the topic, the theme of today's webinar, I will just focus on that one now for the time being, is that technology, of course, is very important to all of us. But using the technology with the right product, I think that's the most important thing, actually. So just having a technology for the sake of having technology doesn't mean anything. So you need to have the right product, right knowledge how to use the technology, as you all know that. Then about the waste awareness, I think the most important thing for us, even sitting in Europe, when I visit customers, I sometimes really feel bad that my customers in sort of so-called developed world, they still do not understand that what is waste actually and how to sort of utilize waste. My experience when I was given job in UK to run a steel mill as general manager, and I could see huge amount of waste within a steel mill because people thought it is the way of life actually, but that is not the way of life actually. I think people have to be very careful, and we have to make them aware about the waste, where it is coming from. As it is a culture which I try to bring, and then sort of having Lean Six Sigma background, being master black belt in Lean Six Sigma. So that is my passion also, to reduce waste everywhere. Then of course, recycling and reusing. I think I will not cover a lot on this thing because you guys have done a wonderful job today on recycling and reuse. I learned a lot today, so thank you for that. Okay, so just talking on technology side, so we embrace all different types of technologies, and we have a number of partners around the world. The first one, let's talk about three major technologies which we are working on today, is having sort of a sinter plant, mainly about the lime, where it should go, when it should go, and how much it should go, and what type of lime it should be actually. So I think all these things are important to make an efficient and effective use of your products into any process, so that you can reduce your waste actually at the first stage. So if you reduce your waste, of course, you have less waste to process and all those stuff. So sinter plant lime dosing. So we have been doing a lot of work on this one with the different universities. We have done a lot of research on this one, just to really find out that what type of lime do you need, and when do you need, and where do you need, and all those stuff. So we are working with different customers also on this technology. The second one is about the BOF lime injection. I mean, this is something which we have, I would say we have invested a lot of time, money, and resources on this one. So we are still waiting for, I would say, the success in this technology. We have done the trials and all the stuff in one of our operations in USA, but we are still waiting for sort of a really commercial sort of acceptance of basically this technology. But we have our partners with us. Then last but not least is the EAF lime injection. So I think you all are very well aware of that the lime injection is very sort of important, very good, because it gives you 100% recovery of the lime. And I just read in the newspaper that we have a colleague from Big River Steel over here, that you guys have just sort of given some sort of, I think, signed LOI basically for having lime injection or commissioned lime injection system actually at your plant. So why lime injection and how does it help actually? So the lime injection, whether it is in the sinter or it is in the sort of BOF or in the electric arc furnace, I'm just going to talk a little bit about electric arc furnace because I think we have a lot more references on lime injection in the electric arc furnace. It is coherent jet of lime injection with no waste whatever, because shrouded with oxygen and everything. And it can help you to sort of really bring foamy slag even at the most critical stage when just before tapping, when you go to the temperature, which is superheat phase. At that time also, you can just maintain your sort of foaminess of the slag. And it brings lots of other benefits with it, like metallic and yield improvement, the power consumption, the power on time, the electrode consumption, and so on and so on. So I said earlier that the technology with the correct product selection is the key to success. That is the most important thing. And just to show you a couple of slides on this one, that we have sort of our pilot plant in USA. We have a place called Millersville in the USA. And we have a pilot plant where this is on the left-hand side of the picture, where we run the product basically through simulation, basically, that before we supply our product to our customer, just to make sure that the product meets the customer's needs, actually, of the flow rate of everything. Then this is sort of, again, one of the plant in USA. I just took a screenshot. So I'm not sure whether I'm allowed to share this screenshot or not, but I'm just putting it over here, that we have huge amount of experience working with different sort of technology companies, PTI, Mori, and all those companies. But this is, things are working excellent. I was in that plant actually about a year ago. And so the system was working fabulous actually over there. So this is one of my plant in Italy, where we have supplied lime injection system, and we have done sort of after sort of supplying the lime injection system, we sort of worked together with the university, with academic world, to really find out whether the customer is really getting benefit or not, just to substantiate what we are saying is right or not. As you can see, there are a couple of sort of graphs which I put it over here as sort of pictures, is that you can see that the power consumption goes down, which is, I've taken basically two different types of steel, which was one carbon steel, another one special steel. And then you can see also the power on time. And then the most important thing is the foaminess. Actually, you can see that how we have moved actually from a lump lime and to really go into the sort of the point where we should see the foaminess actually of the slag. So that is something very sort of encouraging for us and for the customer, what we got those results. So product selection, I know that you guys are probably, all of you are from the steel industry background, and probably you know everyone better than me. But I would say that having worked in the steel industry, now working in the lime industry and sort of helping customers, I would say that for each and every process, you have to pick basically the right product that you're looking at. Why do you need that material actually? So like for the hot metal desulfurization, fluidizing agent and galvanometry is very critical. In the BOF, basically you need soft point lime. So never ever compromise on sort of soft point lime, because at the end of the day, what you need is there should not be any free lime, basically free CaO in the slag actually. So that is what we need actually. So this is like my Bible, I would say, for the lime, that how you should see lime when you make your contracts for the lime sort of probably you need to educate your purchasers also at some time, that when you're really looking at the lime when you're buying, so really what you should look at. So this is a graph, this is a picture that you are paying for CaO, you're not paying for impurities, you're not paying for CO2 content. And that's what we should look at, and sort of reactivity and sort of all those stuff actually. So just talking about the product side, that what sort of impact does this product have on, beside you have your safety, you have productivity improvement, you have the cost improvement, you have the quality improvement, all these small things, but when you accumulate all those small things, it becomes really a big picture actually on this one. So this is one of the example from another customer. This is how we started working with that customer. This is one of my project we took up in 2013, 2014. they were at about 91 kilogram per ton of liquid steel lime consumption. And today they are at 70 kilogram per ton of lime consumption. And then I also had the figure basically at that how much they have saved on metallic yield and how much they have saved on the lime consumption and other parameters also. So this is how that selecting a right product basically for the right process can bring huge amount of benefits to a customer, and you reduce your waste at the end of the day. So we are also worked with the University of Warwick in UK, where we have our total cost of ownership model, value in use model, if we call it this way. And where we have, like for the steel plant, we take the entire sort of your input, metallic inputs and other inputs, and we simulate with different types of lime or tow lime. And the model will tell you exactly that what type of lime is best for you, what type of lime can give what type of benefits, and then it can really count on those benefits. So just a couple of final slides from me. This is like from waste and byproducts in sort of European environment. I just took these figures from Euroslag, which we normally refer to. Seen the picture, sort of the numbers in the previous presentations, actually, that the amount of slag what we generate in India is huge. We said that 400 to 500 kilogram per ton, if I am right, for the blast furnace. But in Europe, we have 185 kilogram on an average, plus minus 5-10 kilogram per ton. And I was given for SMS about between 70 and 170. So this is average figure which we get from Europe, 170, which is including EAF, BOF, and of course, secondary metallurgy all combined together. The most important thing, what I would like to highlight here is the presence of free CaO in the slag, which is if you really want to use that byproduct, and I think it was highlighted in one of the previous presentations, that when you have free CaO, you can't use that slag basically because it is going to expand and all those stuff. How can you reduce that free CaO is that you need to use lime which is reactive enough, which is used well on time, and which can really give you exactly what you really need so that it is in a compound form, not in the free form when you tap your steel actually. So that is something very important. The timing, the process, the product quality and everything is very, very important to make sure that you use your byproduct, the slag in the best way possible. So this is again some statistics which is coming out of Europe, that in Europe we are using nearly 100% of the blast furnace slag. I mean, you know that over here basically that blast furnace is like a hot cake actually, so you sell it very quickly. And also blast furnace is being looked after in agriculture industry and sort of soil acidity correction and all those stuff. And for the steel making slags, we have different legislations. I'm based in UK. I know that for ladle furnace slag, when I was working for a steel plant, I had a big problem to get rid of my ladle furnace slag, white slag, because we were not allowed. It was called as hazard slag rather than sort of a byproduct. But yeah, but generally it is about 75% slag, which is being used actually recycled in Europe. And the BOF slags are largely used in the road construction, but again, you need to have free lime, basically less than 7%. That is sort of the criteria we have over here. And EF slags, as you know, it is used mainly in aggregates, all this material. So just to summarize what I said is that, I mean, appreciating everything over the last couple of days, what I've been attending, learning a lot. I think lime plays a bit of small but quite important role actually within the steel industry. So I would suggest that just step back a little bit and look at the possibilities in reducing the waste, actually reducing the byproducts. Can we do that? Maybe look at the technology. Are you able to embrace technology to improve the recovery of lime, like lime injection actually, or in the sinter plants? Can you just revisit your sort of handling and storage facilities within the steel plant and see if there is any possibility? I mean, of course, we have all the expertise within Carmeos, so you can always give me a call. I mean, I said that I'm good friend of Mr. Nilvam Mukherjee, but all of you can have my contact and anytime call me actually on this one. I'll happy to help anyone. And just revisit your logistic arrangements. Actually, I'm working with the steel plant. I don't want to name, sorry, for confidentiality reasons, but we are looking at entire logistic arrangement, external as well as internal logistic arrangement, to reduce the fines and to reduce the CO2 footprint. Sometimes people call me stupid because I'm selling lime, but I'm also helping my customers to reduce the amount of lime they're using. I think at the end of the day, we all know if I don't help, someone else will come and help basically them, and they will achieve the results. I think it's a happy customer is sort of always a customer which we can serve forever. Actually, that is a sort of policy we work on. Then digitalization, automation, when we have people like Big River Steel actually over here sitting on this panel, I don't want to talk a lot about digitalization, but sure, actually, I think that we always encourage our customers to step back a little bit and look at that where you can sort of automate and where you can digitalize. Even we provide technology that if you want to look at your lime sort of silos, control, limestone heap, or how much you're carrying if you have a captive lime kiln and all those stuff, everything is possible actually. So that is something which helps a lot. And then final thing is that can we recirculate? Actually, I think there was a lot discussion on this one. But within Carmeos, because my first slide was that we also serve many other different industries, not only steel industry. Steel industry takes only 1/3 of our business. So we have a possibility and we have a lot of knowledge here to look at different applications, to go into agriculture, to go into construction and all those stuff. So we are not competing with Harsco, we are not competing with anyone else, but we are just helping our customers to look at different options because we have knowledge actually on that particular thing. So that's how I will conclude. So thank you very, very much again, Mr. Mukherjee, really appreciate that. And thank you everyone for listening to me. Appreciate that. I'm happy to take, if there is a time to take any questions now, or maybe later by email, I'm happy to answer also.
I have a small question for you. Just two part of it. Just two part of it.
Orgoda, I knew you will have a question because Orgoda and Shobhoda, both of them, Sanjeev, let me share it with you. During the last few sessions where we are having discussions on Waste to Wealth 1 and 2. By the way, Sanjeev, were you there yesterday?
Yes, I was partly, not full. Yes.
Okay. So all these days, Orgoda started by saying, Dada started saying that we are talking only about reusing, but reducing part, reusing and recycling was always being discussed, but no one was talking about reducing. So you were the first one to talk about reducing in real sense.
Thank you.
So
Thank you.
that is why Shobhoda and Orgoda, both of them will be having at least some question or the other. Wait for them. Orgoda first, then Shobhoda.
Appreciate that. Thank you.
And by the way, Ankit, let me share something with you. A very personal experience. A good human being gives an example of how good he is. Sanjeev met your mother, and we were both of us were traveling in the same flight to Delhi. So he met you, your mother, and me. Both of us were in the same flight. And the moment I told him, Sanjeev, my son is now in Germany. He's doing his master's in Germany. He said, Dada, I am very close to Europe. I'm in UK, I'm in London. Anytime your son needs any help, do not forget to remember me because I'm always there for you, Dada. So this is what proves how good a human being Sanjeev is. And that's from the bottom of my heart, I can tell you, he's really been a good friend. All these years I've known him. A wonderful human being.
Thank you so much. Thank you. I appreciate that.
Thank you.
And you are a friend. You are a friend forever, Sanjeev. Wherever in the world you are, my friendship with you stays. Orgoda, it's yours.
Thank you so much. Thank you.
It's nice to talk with a very good human being, Mr. Sanjeev. Nice to get introduced through Nirmala Mukherjee, who is very humble in his own stature. I have a small question. First question is that you have spoken about 20% reduction of production, increase of the production 20% through the lime addition at sinter plant. The one is, could you share some of the data of this? Another thing is that how much maximum lime can be used in sinter plant so that my productivity at least reaches this 20% or beyond that? This is my small question.
Yeah, I can answer, and I can also share that we have some technical papers on this one. So to answer briefly actually on this question, that we go around 2% of lime basically in the sinter plant, but that can help you to improve productivity by about 20%. The moment you go beyond 2%, that is 20 kilogram per ton, there's a plateau actually. So you don't see that benefit. You increase your cost basically on the lime, but you don't see much benefit on this one. So then we prefer that you stay with the limestone to meet your persisting needs. And just to improve the productivity is something about 2%, 2.5%, but it also depends on your iron ore, that what type of iron ore you are using. So, but I'm more than happy to share, if I'll get your email address, I'm more happy to share our research work on this one. Sure, absolutely.
And by the way, Sanjeev is already there in our WhatsApp group for a long time. So in the WhatsApp group also, if you ask him, he'll be ready to posting. Shobhoda, I know you will have one question at least.
No, I don't have any questions. Sanjeev, it's courtesy, Nirmalo, that we are getting to know each other on this platform. It's actually a very good platform, a global platform. You mentioned a lot of compliments about Big River Seal.
Oh, I've heard you guys a lot actually. Yourself, Dave Stickler, everyone. Yes.
Yeah, on behalf of entire Big River Steel Collective, and I would certainly mention to Dave on Monday when I see him. Thank you for the notations. We are trying to do a little bit of things here. We are, in fact, one of the latest in the steel industry. We were born in 2017. So 2017 January was our first commercial production, and where we are today and how the world recognizes us is a story to be reckoned with. And I am very obliged to be here representing Big River Steel today, and for so many other days as well. But Sanjeev, let's share our contact and
sure.
Stay in touch.
My pleasure.
Yes, absolutely. You know Carmeuse from a long time. I was in Canada with Coco, and I used to use Carmeuse line all the time.
Okay, thank you very much. Thank you. Appreciate that.
Okay, all right. Thanks. Good speech.
Subrata has a question. Subrata, please unmute yourself. Subrata, you have to unmute yourself.
Yes, already done. Now, you have told about this lime injection in EAF is practiced worldwide, no issue. Lime injection in BOF. When you inject lime, doesn't the gas cleaning system suck the lime dust? Or what is the technology? You did not reply. Can I, if we have exchange later on also?
No, I can quickly reply on this one, and I'm happy to share my sort of paper actually, which we presented actually in one of the leading conferences on lime injection in the BOF. So it is through the lance actually. We just work with through the lance actually. We work with the lance manufacturing company, and we take the center hole basically in the lance, and it goes with oxygen. Yes.
Same oxygen. Okay.
Yes. So that's how we work actually.
Thank you.
Thank you.
Any more, Ankit? Any more questions?
Good innovation, Sanjeev.
No, I appreciate that. Thank you very, very much. I mean, as we are learning from you guys a lot, actually, we are appreciating always you guys. We're following you very closely. Thank you.
So we have a couple of questions in the Q&A section. So one question we have is from Mr. P. If lime availability is a constraint, would you suggest to give priority for lime dosing at center or give for making briquetting with converters slush to feed to the converter? This is the question from Mr. P.
Sorry, I just missed that question. I just need to. Is it okay if I can reply if it is on there? That I can reply directly, right?
Yeah. We can also save some time. You
yeah,
can,
sure. I will answer on that one. Yes. Thank you. Thank you very much, Mr. Mishra. Thank you, Ankit.
Thank you, Sanjeev. Let's keep in touch as always.
I will be. I'm here till end of the session.
Yeah, and I will need you for our future Waste to Wealth also. Then just today, I conceptualized one on digitization, where I need you and Mr. Sabyasachi Bandyopadhyay both to address this on digitization solutions in the new normal era. So that is something I'll discuss with you either this weekend or by Monday.
I appreciate that. Anytime.
We just planned. It just came to me today itself. So I'm yet to share it with Shobhoda and Subrata. Once I do that, then we'll have the entire system in place.
Anytime. So with that, thank you very much. Thank you.
Thank you, Sanjeev. Please stay back. And now I'll hand it over to my son Ankit to take it forward. I'll take a 10-minute break.
Okay, so Mr. Pavan Verma has returned, and Mr. Verma, are you there?
Yeah, I'm there. Very much.
Yeah, so Mr. Verma, you can now restart your presentation and take it forward.
Can I just do the share screen, the green button?
Yes, click on the, if you have your presentation open, it will show up when you click on the green button.
On my screen, it is there on the laptop screen.
So you just have to click on the share screen button, the green button at the bottom, and it will open up a, yeah, this should, yeah, it's working. We can see your desktop. Mr. Verma, are you there with us?
I believe, Ankit, that he has little challenges with the connectivity there.
Yeah.
No.
Mr. Verma, can you hear us? Okay, I think we can just move on to the next speaker, and when he comes back, we can try again to start his presentation. So our final speaker for today is Mr. Anil Pasari. He's the Managing Director of Gang Engineering Private Limited. So I would request Mr. Anil Pasari to deliver his address. Mr. Anil Pasari?
Yeah, I can very well. Can I start my presentation?
Yes, please. You can start.
Can everybody see my screen?
Yes.
Hello, can you hear me?
Yes, visible and audible perfectly.
Okay.
Something different now? I'll do one thing. I'll leave now because I have tomorrow morning to drive 540 kilometers.
Okay, Mr. Verma, if you can give just a short address without a presentation, maybe that would be possible.
Because I find that there's some system problem that it is not connecting to my presentation. But I don't know. I think I'll leave it now. Maybe some other time we'll do it.
Okay. I mean, if you could just say a few words without a presentation, just your thoughts.
Yeah, I can tell you that our approach is very different than all those. Rather, what we are talking about our present government, Make in India. I've been doing last 40 years to Make in India. In fact, like aluminum smelters, entire mobile fleet which they use in aluminum smelter is designed by me, one by one. Like a furnace tending vehicle, which we call a debraking machine in the steel plant, like anode transfer vehicle, like you have those lateral transport vehicles, then the pot room sweeping and the vacuum cleaning systems, mobile truck mounted systems, all were indigenized. Now you find everywhere. When I was first talking to Nalco that we will indigenize, they said there are two companies in the world. I said I'll create the third. It's a total indigenization. Like that, even now you see very common sight is that bulker, the cement tankers, or you can say CTCs. The first bulker I had indigenized 94 for Nalco. Now you have thousands of bulker in India, hundreds of manufacturers. And like that only for the last, I can say from the 2005, we started I started focusing into the steel plant-based recycle. But it's irony that in our country, we don't promote. Like in China, we say the way they're developing because they promote the indigenization. Here we don't. 2005, we had done 100 tons trial of BOF sludge without mill scale in a converter in Indian Steel Company, successfully. Later on, they placed order for 50 tons per day plant. But they were not giving us for a long period. You put up a plant of 25 crores and they give you only 3 years, you can't. So we had to withdraw from that. The many reminders were there. So like that, now, for the last 5-6 years, we have given so many proposals. Every steel plant, whether it's a JSPL, whether it's a Tata Steel, whether it is Bhushan, or maybe it is all steel plants. Every corner of whatever generation of ferruginous waste I'm talking has been there. I have seen, assessed, suggested, solutions to them. Even sold written letters to their head of the companies that how much you can save in a year. Establishing the credentials not accepted. We have done a tie-up with IMT Bhubaneswar. We have sent samples to them. They are developing at the lab scale. We have to do the then industrial scale. Industrial scale, you can't do without putting up a plant of 10 to 25 or 40 crore rupees. We are ready to do that also, that okay, we'll put up the plant, you give us a guarantee, if we give you 5 days, 6 days, successful product, and we give you in also the lab or maybe the pilot scale, maybe few kgs of material with the strength and everything. You will, I could have shared with you what strength we had achieved in that 2005 of our sludge briquettes. And I tell you, in our country, in fact, in Vajak steel plant, the bricking and palletization tender which they have done, I have done a pre-study. I have given all the details. I have done so many details. The others also did. I know it. The HASCO also did. But even location, how much land required, marking the land on the ground, everything we also did. But ultimately, what happens? It happens that you have to have a 1 million ton plant running for the last 5 years or another 75,000 tons running plant. So obviously, when in India it is not, whatever the MNCs are doing in India, they will not share with us. And what we develop in India is out of any value. We have to go. We ran off after the POSCO plant, where there is another company doing $1 million, they were charging the fee. We agreed for that. But ultimately, when they found that in the JV agreement, there's a jointly and severally responsibility coming to them, they ran away. We withdrew from that tender. We could not continue. Now re-tendering done, we are not there because we don't have experience. So if you ask like that, we are putting up a 80 crore rupees plant. If we don't have the proper technology, if we are not sure of our technology, why we'll spend 40, 80 crore rupees? Why are you putting such stringent qualifications? I tell you another thing, Techno Enviro Services, for the last 7 years, we are startup company. We are MSME. There are directives from the government, strict direction from the 2018 also. Who bothers? Nobody. I'm especially talking the PSUs who had to take care of the startups and MSUs, MSMEs, and also the indigenization. We don't trust our IMTs, CSIRs. Then how will we ever become Atmanirbhar or Make in India? I share you with very interesting, the furnace standing vehicle, which they were buying from 4.5 crore rupees, I developed for 1 crore rupees, better than the one machine came under project from the international company, and one mine was commissioned in 1 week, other was commissioned in 1 month. Ours are never less than 85% ability, 95% ability, they were never above 80. But when similar machine is used as a debraking machine in a steel plant, in LT of some of the PSUs, when I asked them to issue me also the LT, Arey bhaiya, aapne to, you have made it in for the aluminum industry, you have not made it for steel industry. Our system was running for almost 5 years, 4 years, where we were demand. Because I said, whether you are buying a truck, you do see that where is carrying the iron sheets or is carrying the wooden logs. You do see how much is the tonnage required, how much is the horsepower and how much is torque power and what all other specifications. You compare that way. This is how in India, Make in India is never happens. I have given a proposal which I know that nobody else can do. I cannot share details about that. There's a 57 lakh rupees per day loss to the company. And for the last 6 years, they are procrastinating. The procrastination and decision making, I'm talking especially in the PSUs, and where they are also a major player and generator of waste. And you can see how till now any effective solution has been found. Secondly, another thing I found, most of the people were talking that we can do the micropelletization, put in the sinter plant. Sintering itself is a very, very, I can say, CO2 footing industry. At the same time, it's slowly becoming obsolete. And why to do? Because I know there's a bigger challenge to put the LOFE material as a briquette into the blast furnace, because the compressive strength required goes beyond 200. And we have developed that briquette also. But in my lab scale, 200 compressive strength is required beyond for using in the blast furnace. But you think if you can put low Fe, like your beer sludge and the dust, or other low Fe like your material handling area dust and all, low material, if you put into blast furnace, you are saving not only the energy, you are also saving the sintering cost, you're saving on everything. But no, we don't have experience. But did you have any plant running in anywhere in the world? Sorry, we don't have. So this is the crux of the situation. Who is going to bother about it? We have so many. I have attended maybe 200 different type of seminars and this type of webinar, and maybe I'm not very used to. And even in Niti Oil 3 days workshop, today Mr. Satpathy was there. He was there in that 3-day workshop with me. I've done in international presentations, talked about what we can do in India, but in India we can't do, because we are all after MNCs, bring them, do it, just make money. That's all. We don't promote Indian concept, and we don't want Indians to come. Thank you very much. And I think the main purpose was to share that we had done in 2009, 2005 the briquetting. I could show you the strength and what were the chemical composition and how the orders were placed and how it was not placed in a very practical way, and how we were divided to now. We had raised this question that we have the past experience. We have IMT with us to develop the technology. Why we cannot? Why you put conditions of 2 million ton or 1 million ton plant running for last 5 years when we have to put up at a BOO project? I don't know what we do. And this was my thought to share with you all, and what we have been achieved, what we have been done by us, and what we are doing now. That slides I couldn't share with you. And with that, I'll conclude. And more or less, this is how we are in India. Thank you very much.
So anyone from the panel would like to respond to what Mr. Verma has said about the challenges that he had faced? Mr. Pasari, yes, please. You have to unmute. Yeah, we can hear you.
Now he's muted again. Anil ji, unmute कर लीजिए. हाँ, अभी ठीक है. Go ahead.
Okay. I'll 100% agree with Mr. Pawan Verma ji, because my company Gang Engineering Private Limited have made 2 pellet plant of 1.2 million ton capacity, and both of my pellet plant are operating at rated capacity since their inception. And very unfortunate, when the tender for NMDC Nagarnar steel plant is coming up for a 2 million ton pellet plant, they have made stringent deliberately to eliminate us, that we cannot bid the tender, and then they have made it that eligibility criteria should be 2 million. If I have made 1.2 million ton, why I cannot make 2 million ton? But it is very unfortunate that we have been deliberately eliminated in that tender process by the eligibility criteria. I don't know who is behind this, but it is happening in India. And Mr. Pawan Verma is very much correct. These are the things how we are unable to understand how we will become Atmanirbhar.
Anil ji, you have attended.
And I think these are the things which I think the platforms like Mr. Mukherjee should also raise with the government, that there should be MSME support and also startup support and promoting the Indian research institutes. Wonderful things they are doing in IMT Bhubaneswar. Wonderful things. Talk about anything they are having.
Yeah,
but
today
commercialization is possible through the private industry. Private industry can do it. Tata Steel can do, Bhushan can do, and the other companies can do. JSPL can introduce, but no public sector companies.
Let me tell you, Dr. Mukesh Kumar, could you hear it? Dr. Mukesh Kumar, are you back? I can see him, he is still there, but he had some guests, so maybe he's tied up. What we will do is, I will discuss this in the next webinar also, because we are going to have this series together, where I will take it up with Dr. V.K. Saraswat. Dr. Saraswat, I invited for this, but today he was tied up. He came for our last refractory webinar. So Dr. Saraswat, I'm always in touch with. So once we have Dr. Saraswat or Dr. Wattal, any of them from NITI Aayog, I'm going to raise this issue because this has to go to the Prime Minister's office, and the Prime Minister's office, the way we can reach is through either Dr. V.K. Srivastava, or Mr. Wattal. So Mr. Saraswat or Mr. Wattal, I'll try and get in this one of the series. And Pawanji, I need you to be vocal, and also through my magazine. And Anilji has attended quite a few of my webinars.
Mr. Mukherjee, in fact, in your earlier webinar on raw material, Atmanirbhar or something like that, in which the company from Austria, the gentleman had also said about this thing.
Yeah,
Andrin. Yes, it was picked up earlier also.
Andrin brought up the, right. So this is something which is
I know.
Yeah, policy making decision which only Dr. Saraswat or Mr. Wattal, either of these two gentlemen can take it up, because they're directly working with the Prime Minister's office.
Mr. Mukesh Kumar, I know for the last 30 years, we had a lot of interaction on these issues. As you know, policy and other things are different and ground realities are different.
Let me tell you, let me tell you, whether it is politicization or Ministry of Steel has very little to do, because Ministry of Steel is pushing it, but it has to be not at the Ministry of Steel level, but at the Prime Minister's office level. So in the Prime Minister's office, once we have NITI Aayog directly involved, today you had advisor to the Principal Scientific Officer to the Prime Minister, who was there addressing us this morning, this afternoon. But even at his level, it will not work. It will work only if you get directly to the PMO. To get it directly to the PMO, only NITI Aayog can raise this issue. I think we'll have to get NITI Aayog involved.
I think my signal is weak. I can't.
Pawanji, आपका connectivity issue है शायद. I faced it this afternoon also. So I am going to carry this forward, and as Mr. Subrata Mitra and Mr. Sabyasachi Bandyopadhyay, both of them, we are working closely to have to address in the final series on policy making. So for the policy making part, we are going to take it forward, and it's not that we're going to stop here. In all the forums, Anil Pasari ji has attended my seminars 10 years ago. So he knows how I have been working on raising these issues on various platforms. And in fact, I was surprised when Dr. Saraswat, I brought him for the last refractory webinar where we had, Subrata was also there, when Mr. Saraswat, Dr. Saraswat was there. So he does a lot of research. I could see Dr. Saraswat digging into the issue. Dr. Sanjay Konde was also there in that webinar. I think Dr. Konde knows how much of research work Dr. V.K. Saraswat has been doing on the subject you bring to his notice. So we will relentlessly work on it. And as Sabyasachi and Subrata both, we have decided we will keep working on this with these series one after another. And the last one, we will concentrate only on policy decision. So this is one issue we are going to raise it.
In policy decision, Mr. Mukherjee, I feel that in policy decision, at least there should be a space given for the Indian research and Indian technology development also in the implementation of technologies in India. And one more point which because of my signal got disrupted, I couldn't continue. We are talking a lot about micropalletization for the sinter plant, which I couldn't continue, disconnected my voice in between. I will suggest that high Fe material which can replace the scrap in the converter, which we did 100 times trial in India, why we are going still for the micropalletization? There should be some policy decision by the government not to waste. There is a CO2 addition will be in from sintering to blast furnace, then coming to the BOF, and where you will be saving the scrap, high value scrap, instead of replacing then the micropallet low value iron. Because the micropalletization generally will have 55 to 58% iron, not more than that. So I feel that is one more issue which has to be in policy decision, that government or the Ministry of Steel or the think tank people have to decide. We cannot just decide any technology, anytime, anywhere. One has to see which is the best for the country, best for the our circular economy and sustainability. We cannot just decide, I want to make micropallet, I don't want to make briquetting. There should be some way to decide. I can tell you, like yesterday I found one of the steel company CEO was saying, we are going for micropalletization. I know they're putting everything. In other company also I found that they're going for micropalletization. Whereas high Fe, I found, I did analysis of their BOF sludge is containing more than 65% Fe. And then you're making it, putting in the micropalletization, including mill scale also. So it's I'll say the national waste, which we have done earlier also, we have been doing for the last 30, 40 years, dumping it outside, mixing it all, fly ash and everything, and making it of non-usable or reusable, I can say, other than landfill. I can tell you, I have known one cement steel plant in PSU only, where this BF sludge, which is 150 tons per day, containing around 31% carbon, which I analyzed, and 42% iron, which Mr. IMT Chief Scientist, Mr. Biswal was talking of separation of carbon and all, that is being mixed with a this fly ash pumping station and goes into the fly ash pond for the last 40 years, 150 tons per day. How much iron and how much carbon we are wasting? Who is asking questions? Nobody. Yeah. We are talking, deliberating for the last 7 years. I'm into various platforms and forums, from NITI Aayog to the CIA and FICCI, Ministry of Steel, and first time I'm on into yours, otherwise in many other steel platforms. But what implementation, procrastination, and I'm talking hats off to our private sector companies. JSW, I will salute them. Then many others. But some decision making little bit delayed in, like in Tata Bhushan, the plant which they have put up, that plant, every nut and bolt I had done studies, because we are also was earlier tied up with the company who was supplied to them technology and the equipments in Korea. I have been to 7 steel companies in the world to see how they are processing. I would have shown you the slides. I would have shown nobody calls even the balance sheet of the POSCO, they don't call waste work at all. They call it byproduct. I never use in my presentation waste. I'm putting waste to wealth in my presentation today because it was a waste to wealth presentation today. Otherwise, I call it a byproduct, and let us make it valuable. Name it first. When you talk waste, we think, chalo yaar, waste hai. Baad mein dekhenge. Right, sir. Thank you very much.
Thank you. If you have noticed, when our topic reads reducing, reusing and recycling of byproducts. We have not said reusing your waste to wealth, because people conceive it as waste. That's why we are calling it waste.
Yes.
People conceive it that way. But as you must have seen yesterday and today, Dr. Mukesh Kumar started by saying nothing is waste. So when we talk about zero waste, we say nothing is waste, because that's why we target zero waste. maybe Shobhuda will have one comment, one quick comment to add on.
Byproduct in India. Even Tata Steel, I said in 2005, it's a byproduct. Nobody was using word byproduct in India in 2005.
Shobhuda, any quick comment?
No, I think Mr. Verma has his heart in the right place and his head is very clear. So I also personally think that we should think about circular economy with a focus, not necessarily invest on technology that's age old. So rather think about things that are going to be differently treated and can bring us results. So he's right on the carbon footprint because that's going to be the focus of the future. I mean, there are every year there are conferences and there are assemblies of the head of the states and they're making promises, they're making commitments, but where is it going? And that's why Nirmala, in fact, Subhrata also raised it in one of our internal meetings. And I think we need to think about how we bring all these thoughts into another stage, another level. And the level should be, I think we create that platform. Nirmala, you have been able to create this platform. Let's create this platform where people like Mr. Satpathy or Dr. Saraswat or other policy makers, they don't leave the session. They listen to people like Pawan Verma and get the input. So maybe we make them shorter. So I take encouragement from Mr. Verma's words, and I think if we continue to remain in the committee and if this is going to be, in my belief, will be several sessions that we will hold and host.
That's what I conveyed to Pawanji in the message box, that don't worry, this is a series which is going to continue longer than what we thought. And in our next internal meeting, what we will do is we will, when we talk about the policy decision-making part, we are going to ensure that, the structure is different so that there are a few speakers who speak before, let's say Dr. Saraswat or before Mr. Satpathy. These people should stay back till a few speakers have targeted the issue, and then we give them a chance to talk.
Yes. Yes.
Yes. Very correct. Very correct.
They're very correct. That's what we need to do. That's what we need to do.
But the issue is they won't stay back for more than 1 hour. So within that 1 hour, we'll have to get it.
So let's do it. So then let's do it. Let's
you select only the people who have the right issue to take up. You select the people, the speakers in the beginning before they come, and they can listen to them, give their deliberations. There are persons who have a very specific, ask them to submit to you what every panelist then submit to you what exactly they want to say regarding the policy. And if you find that the policies are important, then you put them before. That will be, I think, my suggestion.
I'll give you an example.
Nirmala, can we take this internally through our meetings rather than?
Yeah, we'll have only the last speaker left, Mr. Anil Pasari. So Anil ji, थोड़ा जल्दी आज खत्म कर लीजिए. Next issue we are going to, the next one where we are going to discuss pelletization. I'll give you ample opportunity to start at the beginning and finish at the end. तो आज के लिए बस इतना कर दीजिए, जल्दी खत्म कर दीजिए, so that I can have my dinner. मैं बहुत भूखा हूँ.
I think it's too late now. I think you should have given him a proper full platform, because you can go for a webinar, especially on the pelletization and beneficiation, both combined. One session on that during the recycle.
For raw material का जिसमें किए थे Manufacturers Association का जो head है, भटनागर जी Pellet Manufacturers Association of India का head, उनको भी लाए थे. नवीन जी भी थे, नवीन जिंदल was also there. So उस platform पे we discussed, Steel Minister को भी लाए थे. So we brought everyone in every, but it cannot be one. It has to be a series. So without wasting much time, Pasari ji, आप 5 मिनट में खत्म करके तैयार हो जाइए next webinar के लिए. आप 15-20 साल से हमारे conference attend कर रहे हैं. I remember in 2005, 4, 5 also you were there for our pelletization wherever you see. So for such a long time we are pushing this pelletization issue और करते रहेंगे. बस आप मेरा इतना कर दीजिए, मैं भूखा ना रहूं. अब 5 मिनट में खत्म कर दीजिए. चलिए अनिल जी.
Hello. Everybody can listen me?
Yes.
Okay, thanks. So since
Yes,
you
we
have
can.
gave my presentation in a very precise and a very small way, so I will take it that way only. I'll not go my regular presentation. I'll just give my whatever we are doing and what we can do. That is what I'm interested to also speak. So we are working presently on following project jointly with steel companies. That is micro pellets for Fe and carbon flux waste steel plants. We are interested to work for manufacture of calcium ferrite and doloferrite using these all waste, because they contain calcium, they contain ferrite. So if we make calcium ferrite flux, which can easily replace synthetic fluxes in the country, which is being used by manufacturing. So this waste material can be used and recycled for making calcium ferrite. We are working for production of fertilizer from steel plant basic slag, and we are already done it. We have already produced about 100 tons of material. We have given it to the various fields in the Chhattisgarh states, and we are getting excellent and marvelous results. Marvelous means about, you can say, 20 to 30% growth is there. So if you can convert this into the volume of money terms, the Pradhan Mantri is telling that we have to double the income of the farmer. This can easily be used and can be achieved by using slag. And then we are ready to work with steel companies who are interested to work for indigenization of the technology. For particularly if any important technology is there, if you want to indigenize it, we have done it in past and we can easily do it. My company is the only company right now in India who can give you 1.2 million ton and above capacity straight gate technology based pellet plant. Otherwise, you have to just import it, and we are almost, you can say, third in the world. After Autotech Metso have joined hand. So now Autotech Metso is one company, then Uralmas and my company is the third company who can give straight gate technology pellet plant. We are on. Then we have already made trial production of fertilizer. So I can give the presentation, but okay, if time does not permit, so there's no problem. So
we keep it for the next one. We will keep it for the next one.
Yeah,
अगले महीने आपको फिर बुलाएंगे, मेरा वादा रहा.
No issue, sir. I am very comfortable with this much.
आप राउरकेला में है ना?
अरे कहीं भी रहेंगे, आप तो इंडिया क्या पूरा वर्ल्ड एक ही है, वो कोई बात ही नहीं है.
आपको बुला लेंगे एकदम. आप इतने सालों से जुड़े हुए हैं मेरे साथ.
Thank you very much.
Thank you, Anil ji. We keep it for the next one. Or Subrata da, one line each for each of the speakers. You did not, cover the entire. Just one line on each speaker. That is enough. Just once, or let's say 4 seconds or 5 seconds per speaker, so that we can finish in the time. Subrata, it's yours. Subrata, please unmute.
I may make this mistake. So, the role of solution providers, Shobhoshaji gave an initial talk. Then Mr. Mukesh Kumar introduced Mr. B.N. Satpathy, principal scientist for the PM's office. He talked about various plans, what were done in the Ministry of Steel, looked for what has to be done, and he spoke about the ambience in corona atmosphere, what will happen, and as a confident that a lot of initiatives will be taken up by SRTMI with Dr. Manoj, Dr. Kumar. Then the third speaker was Mr. Saxena, Director of Operation RINL, who last night, yesterday, he also spoke on various initiatives using slime, NMDC slime, 30% slime for sinter plant. So anthracite coal is being used also. Then Prabhat Kumar Puroi, Senior VP GSW, talked on what is happening there, what are the initiatives taken in LD slag utilization.
it's not up to the desired level, but it has to be increased, and talked about care process and R&D initiatives that is being carried on. Mr. V.R. Sharma gave an elaborate talk in various subjects on what to do and how it can be his ideas. His basic fundamental idea was power cost rationalization across the country, so that scrap that is generated 1.8 billion can be melted through electric furnace route to reduce the CO2 emission. So that initiative government has to take over, and according to him, the electricity cost should not exceed 3.5 rupees per kilowatt hour. If it is across the country, it is a big benefit. So coal to gas gasification technology being done in JSPL that he talked about is using for DRI production 70% syngas and 30% coke oven gas. That's the big achievement, coke oven gas utilization for DR making. Then HARSCO gave a very detailed presentation. HARSCO is known all over for their environment management. Vijay Gupta, director, spoke on HARSCO initiatives and various bills that are carried from 1956, including process of slag, environment business, slag utilization, scrap management, metal recovery. The goal is zero waste. Process.
I think Subrata dropped, right? Ankit, can you see him anywhere? I think he dropped.
Yes, he's there in the panel, but I cannot see his microphone icon.
By mistake, he may have switched it off.
Hello.
Subrata, can you hear us?
Yes, yes.
Please go ahead. Yeah.
But I can see myself.
Yeah, because your camera is somehow switched off.
But I have not put it off anyway. Something.
Yeah, you can continue. No, it's not an issue. You can continue.
Okay. She gave a.
I think again we are having connectivity issue. Ankit, if connectivity is poor, does the camera get off?
Yes, sometimes it happens.
Okay. Then
I have not done connectivity. Quickly finish. She gave certain initiatives she has done for utilizing slag for various items manufacturing. She has done the prototype and for various furnitures and tiles, benches, bricks, blocks, and other things that are being tried by her initiative, slag and quartz mix. Then EcoMeister, Mr. Amit Srivastava gave a presentation on EcoMeister along with CEO Santiago Jose. They gave a presentation on what EcoMeister is achieving and various plants they are utilizing there. Principle is molten granulated slag fast cooling so that no free lime is there. LF slag utilization in fertilizer is one of the products they have done, and conversion to cements. So there's a talk with EOD slag cement was suggested. Railway sleepers, flooring and pavement stones will also being done through EcoMeister utilization. Then Sanjay Pawande of CCRP Lab gave a presentation on sustainable development of resources and energy. Am I audible? Can you hear me?
Yes, it's loud and clear.
Talked on pyro and hydrometallurgy, sustainable development of resources and energy. Oily sludge can be used for clinker production. This is a good achievement. Waste lime can be fried in zinc recovery. That was one of the initiatives. Suggested in response concept foundry slag used for repairing of potholes. This is from his personal experience. He has developed pothole filling up mechanism by using foundry sand. And Debashiti Rai of Tata Bhushan spoke about various collaborations with HARSCO, MRP operation, metal recovery plant operation, complete slag management and conversion to products. Replacement of fluxes by waste material is being aimed at in Tata Bhushan. So that will be an achievement, trying to achieve EcoMeister revive EcoMeister in BSL because in between it was stopped for certain reasons. Local funds, community development is a good work that is being carried out by Tata Steel, where small entrepreneurs in and around Bhushan plant is helped to develop their enterprises. And Dr. S.K. Biswal, Chief Scientist, says IONT spoke about utilization of solid waste, conversion of utilization of non-coking coal and mixing with coking coal for coke preparation. Biomass binder is also used for preparing mixing of non-coking coal and major amount of coking coal to make coke. SMS sludge utilization was talked about, reduction roasting of low and lean grade iron ore was talked about. Beneficiation of mandate hematite ore was also talked about. Below 55% Fe was suggested not to be beneficiated, but reduction roasting can be done to for better utilization. Ritesh Kumar of Tata Steel Industrial Byproduct Management talked about the total volume of slag and waste material handled is 14 million ton. He talked about Tata Nirvan and Agrito brand. What they are doing, potential uses of high ash brick, road making, clinker, fever block, rail ballast, and agricultural use. Then Mr. Pawan Verma very transparently talked about the various issues being faced by his initiative, which although he has developed many of the mobile fleet and vehicles for the last 50 years and contributed a lot to the steel industry, but due to certain issues, the company is not getting enough order, including debraking machine. A lot of issues are being raised so that he cannot enter into the business properly, which we decide that will be a number of you discussed in one of the next webinars. Mr. Sanjeev Minocha of Global Industry Caramels talked about lime. This is a new area where utilize lime, good lime, to cut down production operating cost, and spoke on lime. The kiln technology they have up to 20 kg of lime used in sinter plant is also happening. Was talked about. A new subject was addressed, that was lime injection in POF vessels to oxygen lines. This is a new initiative which is being tried. Then Mr. Anil Pasari, Grand Engineering, also spoke in the same line as Mr. Pawan Verma. Of course, they are also facing a lot of problems. They have already got an experience of setting up 2 pellet plants of 1 million ton capacity. Straight gate technology. Micropelletizing is being done. Calcium ferrite and roloferrite production of fertilizers from waste has been tried very successfully. There's a good achievement. Ready to work with this company, ready to work with steel plants. They have in collaboration with Uralmash of Russia. So these are the topics discussed. It was a very value-added and very knowledgeable discussion. A lot of new technologies were discussed, and it was on whole, it was a very good webinar with so many experienced speakers and panelists spoke. Thank you.
Thank you, Subrata. Thank you so much for summing it up so very well. Every time you are a perfectionist, Dada. Without, as I keep saying, without Mr. Subrata Mitra and without Mr. Sabyasachi Bandyopadhyay, I am a big zero. I am what I am only because of Mr. Subrata Mitra and Mr. Sabyasachi Bandyopadhyay who have kept this together. I cannot forget what Dr. Mukesh Kumar has done. He has stood by me through thick and thin, and I remember my first interaction with Dr. Mukesh Kumar was when I went to interview him in his office in Delhi. That time he was sitting in Director Technical's office in Cell Lodi Road office. So that was his temporary office that time, where he was using Director Technical Sales office. till he moved out of that building and went to this building, which is, what is the building called, Dr. Mukesh Kumar? Hansala, no?
It is Bokaro Steel Plant Office at Parliament Street.
So that was the new office where he went. So from that time, you know, SRTMI is something which is very close to my heart, and I've always said that on every occasion I could get, because it's the first effort towards Atmanirbhar Bharat started, I think, with SRTMI. Without Steel Research and Technology Mission of India, Atmanirbhar Bharat would not be.
My battery is going out.
No problem. No problem, Subrata. Please carry on.
Thank you. Good night.
Good night. Good night. I will catch up with you tomorrow. Yeah, tomorrow I'll catch up with you sometime.
Okay. Thank you.
Good night.
Dr. Kumar, everybody.
Thank you.
Subhushachi. Ankit.
Thank you, Subrata. So this is what I keep saying.
Thank you, Dada.
Dr. Argo Majumdar has also been very helpful in today, especially bringing Rashmi Vidasaria, and bringing this session today was only because of my discussion with him and then with Subhusachida, that after Argoda sent that message to me. So today's session would not have happened without Argoda's, I would say, initiative at the first instance. My thanks to him. But at the end of the day, without whom this could never be possible is Mr. Abhijit Gupta. So if I don't thank Abhijit Gupta, who's the title sponsor for today, I would be, doing injustice to the subject. But one thing,
sir,
I must
sir, don't embarrass me, sir. We have not done anything. We were just part of the whole system, because we are just as I would say I'm a very small, minuscule in the kind of knowledge over here, and we can learn a lot of things. It's a humility, I would say, that a lot of people listen to our presentation. They have spent 40 years in their career with this kind of things. So it's a pleasure for us. It's a pleasure for us to.
Remember, two presentations of the day were taken by everyone, I would say, very seriously. One was your presentation and the other was EcoMaster. So these two presentations were taken very seriously today. So the first one, I would say, as Dr. Mukesh Kumar, immediately, if you remember, he mentioned that Hasko's presentation was excellent. So I would have, and one more thing I must tell you, Mr. Gupta, that without your push, my people would not have been able to get everyone together, because you are constantly pushing my people. That is why they managed to bring everyone together. And as you can see, Devajyoti Roy still listening to us. As you can see, Mr. Sailen Shukla from ArcelorMittal Nippon Steel still listening to us. Since Shubhajyoti Da yesterday covered most of the subject, so that's why Mr. Shukla did not have much to add, but he still did. And Amit Srivastava ji, my special thanks to you as well, because even otherwise you are there for right from the beginning. Not only that, you have assured my team that you will be there to support us in the long term. And I know with your group companies like GSB Refractories and your other joint ventures, we'll have something to do with your companies one by one. It will be a long-term relationship. And as Subhusachida mentioned, you are a very good soul. You're a good human being. So I would love to work with you in the long term, not just for today. Same goes for Pawan Verma ji. Same goes for Pawan Verma ji. And now my son Ankit will propose a vote of thanks. Ankit, be as fast as you can, as quick as you can, before my hunger pang goes bust. So my hunger is going and growing. So yes, please conclude as fast as you can.
Yeah. So
like a bullet train.
So speaking of vote of thanks, I mean, you have already covered most of my work. So I'll just keep it short. Firstly, we touched some very vital topics today and yesterday. We discussed about ideas and policies, technologies, and even challenges that are being faced by the technology providers. So there's still a lot left to be discussed and conclusions to be drawn, for which we have planned another webinar as a part of this series. As for today, I would like to thank all the panelists for being here and staying so late to take part in this interesting discussion. I believe our webinars can only be as good as the people in the panel who have all been wonderful in their respective addresses to make this webinar a successful one. My heartfelt gratitude to our title sponsors, Harsco Environmental, and our co-sponsors, EcoMeister Beats India Private Limited and CCRT Laboratories, who have not only sponsored the event, but also given wonderful addresses and wonderful presentations. A special thanks to every person in the organizing committee, led by Mr. Shubrata Mitra and Mr. Shopochachi Bandyopadhyay, whose relentless efforts have helped shape the entire structure of the webinar as we had today, as well as yesterday. I would also like to thank Dr. Mukesh Kumar for moderating the proceedings today wonderfully. Last but not the least, thanks to our technical partners, Amitech India, with whose help we were able to bridge WebEx together with Zoom, and many other technical support from them, as well as everyone from the Steel and Metallurgy team, without whom this event would not be possible. So thank you all for joining us today. And with that, I would like to conclude today's meeting. Thank you all.
Yeah.
Thank you.
And we will soon make the announcement for the next Waste to Wealth webinar. Thank you so much. Thank you.
Thank you, everybody.
Thank you, Sanjeev. Thank you, Mr. Devakati Roy. Thanks, Sanjeev. Thanks, Amit ji. Thanks, Opoda. Thank you.
Thank you, everybody. Bye. Namaskar.
Thank you, Mr. Abhijit Gupta. Bye.
Good night. Good night to everybody. Thank you, sir. Thank you very much.
Good day.